Hello students, welcome to Unacademy, the largest online learning platform in India. So today evening, I'm glad to have a YouTube live with all of you. And myself, Krishna Prakash, students love to call me as a KP sir, and some people call me as a EE sir. I'm going to teach the subjects of environmental engineering, hydrology, irrigation. I have 10 years of GATE and ES experience. Most of the students know about me very well. And I'm damn sure whatever I teach, if you go through my classes, surely all questions related to my subject, 100% you solve in your GATE and IS examinations. And I have 16 years of teaching experience. Now, I trained, out of this total 10 years of GATE and ES experience, I have trained around 150 batches of students and thousands of students, several thousands of students I trained, and I helped them to get top ranks in GATE and IS. I am ex-faculty of ACE Engineering Academy. I also worked previously in Vani Institute, GATE Forum, and other coaching centers. So, hi Krishna, hello. Then today our topic is related to our topic is related to air pollution. So this air pollution is the subject for civil engineering students. Air pollution is the subject for GATE and ESE technical students, civil engineering students, GATE and ESE technical subject. And also it is important in ESE general studies, the subject of energy and environment. In the subject of energy and environment for all branches students. Clear? For all branch students in the subject of energy and environment, we have air pollution. So this topic of air pollution is very important for you for your GATE and ESE examination. So how much important this topic is? First, let us see how much important this topic of air pollution. So first of all, we are discussing for GATE, ESE, how much important this air pollution topic is. So this subject, this topic air pollution, important for civil engineering students, and you have 2 to 3 marks from air pollution. Surely one theoretical question and surely one numerical question. Sometimes they may give only one numerical. That means 2 marks mandatory. Must, if you observe the recent trend of GATE and ESE previous papers, especially if you go for GATE, if you discuss in terms of marks, you will have 1-2 marks question. And the same model ESE, technical paper 2 for civil engineering. Paper 2 for civil engineering, how? 2 questions. And ESE, paper 1, general studies paper. Clear? ESE, paper 1, general studies, which is common for all branch students. This general studies technical paper is common for all branch students. In that we have the subject called energy and environment. Energy and environment. Again, in this paper also you have 2 questions. Clear? In this paper also you have 2 questions. For GATE and ESC, especially if you go for civil engineering students, 2 questions in ESC from technical, 2 questions. That means as a whole, for a civil engineering student from air pollution, paper 1 and paper 2 combinedly, in ESC he is going to write 4 questions. In paper 1 2 question, paper 2 2 question, mostly will get 4 questions from air pollution topic. For other branches, with respect to energy and environment, we have 2 questions. Okay. So today what we are going to discuss means air pollution we are going to study. So we are going to discuss air pollution in the form of 5 parts, 5 days. It is not going to be completed in a single day. Air pollution is a big concept, very important concept. It is not going to be finished in 1 day, 1 hour. We are going to have 5 lessons, 5 parts of air pollution. If required, we may extend 1 day or 1 more day also. 5 hours, 5 parts of air pollution we are going to discuss. Thank you, Prakash 1995. Thank you very much for your comment. Then, concepts what we are going to discuss under air pollution. First, air pollution. What is air pollution? What are pollutants? What are the causes of air pollution? What are types of air pollution we are discussing? Pollution, introduction, air pollution, its causes and its types of causes. Then, pollutants, air pollutants. The chemical or physical impurity which is responsible to impart pollution, that is said to be pollutant. What are different air pollutants, their types and their effects? Then we are going to discuss concentration units and their conversion. So this is important for numerical questions, especially for civil engineering students. In energy and environment, you can focus on these theoretical concepts, ESC. ESC students, energy environment paper 1, you focus on this theoretical concepts. Then civil engineering GATE and ESC technical paper, you focus on concentration units and their conversions. And it is important for both ESC technical paper and general studies paper, and also GATE technical paper of civil engineering for both. Very, very important topic. Nowhere in your colleges faculty will teach you meteorological factors affecting air pollution. Yes, very good, Deepak. Your observation is good. 2020 ESC 4 questions in prelims examination from air pollution. Just before I said, for ESC 4 questions for civil engineers, or ESC 4 questions from air pollution 2020. Recent, just Deepak commented on it. Recent, we have 4 questions. Meteorological factors. Remember, don't miss this topic because meteorological factors affecting air pollution, you can't find in local other textbooks. You can't find in Google searches, and your college faculty also not going to teach. Local coaching centers, not famous coaching centers, faculty also not going to teach you. So this is the most important. No one knows clarity regarding this. But by the end of my class, I promise you, you will get 100% concept clarity regarding meteorological concepts affecting, factors affecting air pollution. Then also we are discussing about plume behavior. In this meteorological factors only, this plume behavior theoretical questions and also other numerical aspects are very important. Then finally, air pollution control devices. These are recent questions in air pollution, especially appearing in GATE numerical questions. Maybe some theoretical question in ESC, but recent questions mostly they are going to ask. Hi Gopi Satish Malla. Recently they are going to ask this model of air pollution control devices questions. Now, good evening Gopi. Composition of atmosphere. Before going to discuss about air pollution, yes Teja, it is very much helpful for government examinations. Teja, not only for GATE ESC, for all state government examinations also, SSC, JEE, RRB, wherever, without question from air pollution, there is no paper. Even general studies paper also, one question from air pollution is mandatory, Teja. Deepak Kumar, what you expressed is very good, very correct. Meteorological factors is a tough topic. So I will make that tough topic very simple for you. I have written clearly. This is important also and tough also. I will make that topic very easy for you. So before going to discuss what is air pollution, what are the effects and all those things, complete concept. First of all, we need to know about atmosphere. So atmosphere is the zone of environment. Atmosphere is the zone of environment that comprises, what it comprises? Gases. Atmosphere is the zone of environment which comprises gases. And these gases, depending upon the composition, based on composition, we have differentiated into major gases, minor gases. Based on composition, the atmospheric gases classified into major gases and minor gases. Major gases, 3: nitrogen, oxygen, and argon. We have given clearly composition in this picture. Nitrogen, 78.08 for highest gas. The gas with the highest composition percentage in atmosphere. Followed by oxygen. Oxygen, 20.946 percentage. Argon, 0.934. All the other gases, see, even they are not equal to 0.1, less than 0.1. All minor gases are remaining. Depending upon composition, we have differentiated gases into major and minor gases. Major gases, nitrogen, oxygen, and argon. Minor gases, all the remaining gases comes under minor gases. Carbon dioxide, neon, helium, methane. So major portion is occupied by nitrogen, followed by oxygen. Then 1% all other gases, very, very less concentration. And based on their behavior, clear, based on composition, we said major and minor gases. Based on their behavior, these gases are differentiated into fixed gases, variable gases. Based on their composition, these gases are differentiated into fixed gases and variable gases. What are fixed gases? The gases which does not alter, does not modify. Nitrogen, very good, Yogeshwar, does not alter percentage, their composition. The gases which does not alter their composition from time to time, with time to time. Time to time, place to place, origin to origin, those which does not modify their percentage composition, those gases comes under fixed gases. We'll have the example, we'll give the example for fixed gases. Nitrogen, oxygen, argon, hydrogen, helium, neon. Nitrogen, oxygen, argon, hydrogen, helium, neon. These comes under fixed gases. Variable, the name itself indicate. What the name itself indicate? The name itself indicate variable. Change, modify. What modifies? Their percentage, composition, change their percentage or composition. Ashok Krishna, very good. Composition, time to time. With respect to time, those who are changing their percentages. Helium is the most stable gas. Yes, very good, correct, Vedant. Variable gases. So I am looking downward. Don't feel that I am copying. I am looking downward to check comments here. Okay. Based on your comments, I am going to respond. I am checking my mobile to look out regarding your comments only. Okay. Then those gases which change their percentage or composition time to time. For example, ozone, water vapor, carbon dioxide, oxides of sulfur, etc. Those gases which modify their percentage time to time. So gases available in the atmosphere, we have differentiated based on their behavior. Those which change their percentage, those are variable gases. Those which does not change their percentage time to time, fixed, stable, those are fixed stable gases. Which can change time to time, place to place, region to region, they modify their composition. Those are said to be variable gases. Then our problem is not with fixed gases. We don't have any problem with fixed gases. But change in composition of these variable gases mixed with other impurities in the atmosphere and environment resulted in new molecules, generated so much adverse effects on human life, plant life and animal life. The variable gases change, modify their composition. Clear? Variable gases change, modify their composition, deviate, mixed with other components in atmosphere. Here, deviate and mix with other components in atmosphere. Then release new molecules, contaminants into atmospheric air. Then atmospheric air will cause adverse effects. That is studied under air pollution. So I will write down here. Variable gases, other physical, chemical, biological. I think more adverse effects are due to oxides of sulfur and chlorine. Yes, correct, Dharam. Variable gases or other contaminants. Other contaminants, physical, chemical, biological contaminants, which bring modifications in atmospheric air and cause adverse effects on human life. Adverse effects on human, plant or animal life, even including properties, then that phenomena we consider it as air pollution. That phenomena we conclude as air pollution. Got it? The change in composition of variable gases, whose composition combined with other impurity or some contaminants are generated, physical, chemical, biological contaminants in nature, which cause adverse effects on human life, plant life or animal life. And that phenomena, if that adverse effects are created, that phenomena we consider it as air pollution. Got it? Then we are going to know about, first of all, we are going to know about the structure of atmosphere. What is the structure of atmosphere? We are going to discuss. atmosphere structure based on temperature levels, altitude with respect to altitude. So first of all, tell me what is altitude? Altitude is a vertical rise, height. Very good. Ashok, Manoj and Prakash. So you keep my name also Prakash. So height from MSL, height, Teja, Gopi. Very nice. Everyone is answering. Vertical rise, height from ground, elevation. Yes. Vertical rise from ground level, height from ground level, that is called altitude. So this altitude, clear, 0 to 12 kilometer altitude. Exactly 0 to 12 kilometer altitude, we consider that zone as a troposphere. Exactly 0 to 12 kilometers altitude. Troposphere, very good, Banu Prakash. Troposphere, and this troposphere, very important question you need to remember regarding troposphere. The zone of atmosphere where most of the weather phenomena takes place. This is the question important for your examination. The zone of atmosphere where most of the weather phenomena takes place, that is said to be troposphere. Then 12 to 50 kilometers or 48 kilometers, we can give 12 to 48 kilometers stratosphere. Stratosphere, which is said to be zone of ozone layer. Everyone knows about ozone layer very well. So the zone of ozone layer, 12 to 48 kilometers, that is said to be zone of ozone layer. Then 48 kilometer to 84 or 86 kilometers, 84 to 86 kilometers, we'll consider mesosphere. Mesosphere, with increase of height altitude, it increases its temperature. Thereafter, up to 120 kilometer, thermosphere, where most of photochemical reactions, ionic interactions, photochemical reactions are going to take place. So 0 to 12 kilometer troposphere, 12 to 48 kilometer stratosphere, 48 to 84 kilometer mesosphere, and thereafter up to 120 kilometer thermosphere. This is vertical distribution of atmospheric zones with respect to temperature. Clear? Vertical distribution of atmospheric zones with respect to, clearly we are showing here temperature modifications. See here, stratosphere with altitude, temperature goes on increasing. Sometime temperature is maintained. This temperature is on x-axis now. So sometimes same temperature is maintained. Temperature fall down with rise of altitude in the mesosphere. Clear? In stratosphere, temperature goes on increasing with rise of altitude. In mesosphere, temperature goes on decreasing. Again, thermosphere, temperature goes on increasing. So this is a temperature versus altitude graph in various 4 different zones of atmosphere. Is it clear? In 4 different zones of atmosphere, troposphere with increase of altitude, temperature fall down, clearly shown. Temperature fall down. In stratosphere, it goes on increasing. Mesosphere, it goes on decreasing. Thermosphere, it goes on again increasing. These are the 4 zones we have considered. So very important zone, as we discussed. Stratosphere is a zone of. So we love ozone layer actually, because we are hearing this word of ozone layer since our 6th standard or 7th standard. we are hearing about it. Ozone layer is the protective layer of Earth's strata. It interacts with ultraviolet light radiation from sun and stops penetration of UV light, harmful UV light into the Earth surface. But actually, ozone is generated in the stratosphere. Clear? Actually, ozone is generated in the stratosphere. Stratospheric oxygen, this is oxygen O2 molecule. This is oxygen 1, oxygen 2, two oxygen molecules. Got it? Oxygen O2, stratospheric oxygen, interacted with ultraviolet light radiation, sunlight. Harmful ultraviolet solar radiation splashed, interacted with oxygen and break down oxygen into two nascent oxygen free radicals. Here, oxygen is breakdown into two nascent oxygen free radicals. These nascent oxygen free radicals reacts with another oxygen molecule, generated ozone. Generated ozone molecule. Same here also. This nascent oxygen free radical interacted with another ozone, generated ozone molecule. So when we write down the chemical reaction, totally how many oxygens? Here one oxygen, two oxygen, three oxygens. So three oxygen molecules in presence of harmful ultraviolet light radiation, which is solar radiation, resulted formation of two ozone molecules. Here, three oxygen molecules. Finally, total, na? Step 1, step 2, combinedly. Step 1, one oxygen. Step 2, two oxygens, combinedly. Total 3 oxygen molecules are generated. Clear? Total 3 oxygen molecules are generated. React with a harmful ultraviolet light radiation, generated 2 ozone molecules. So, like that generated ozone, accumulated, converted into stratospheric ozone. That stratospheric ozone is forming ozone layer. So, this is the question given in 2019 ESC General Studies examination. This question related to ozone. Which of the molecule is responsible to interact with ultraviolet light radiation in atmosphere? So it is not ozone. What is our answer? Stratospheric oxygen, which is reacting with UV light radiation. Stratospheric oxygen. Stratospheric oxygen is reacting with UV light radiation. But mostly we are going to answer ozone. Ozone is not the answer. Remember it. Ozone is not the answer. Stratospheric oxygen. This is given in General Studies paper 1, common for all branches. Stratospheric oxygen is responsible to interact with the UV light. Got it? Then I have a question. Will this stratospheric ozone is harmful or harmless? This stratospheric ozone, shall we say ozone is a pollutant? Is it not? Ozone is a pollutant. No? Then tell me whether this stratospheric ozone is a harmful or harmless ozone. Any one of you? Yogeshwar, harmful? Yes, harmful. Yogeshwar. Any others? Harmless. Gopi Satish, very good. Harmful. Ashok Krishna. Ramya, harmful? No. Dharam Dhanush. Good. So this is harmless. Stratospheric ozone is harmless. Clear? Because this is helpful to protect Earth's surface. This is originated, not helpful actually. This is generated, originated as a protection of Earth strata from harmful ultraviolet light radiation. This is harmless. But ozone layer which is formed. For example, take this is ground level. This is industry. Clear? This is industry. From industrial chimney, various gases are liberated. Due to chemical interaction of those gases, ozone generated 3 to 4 kilometers above ground level. What we call that ozone? What we call that ozone? I'm writing here about that ozone. Troposphere ozone. Troposphere ozone. Ozone generated 3 to 4 kilometers or 5 kilometers away from ground level, from the ground level altitude 3 to 4 kilometers. Due to industrial chimneys, chemical interaction happened in the atmosphere. The chemical components reacted, volatile organic chemicals and nitrogen oxides chemically combined, generated ozone. This troposphere ozone, very, very important, remember. What happened? Harmful. Ozone generated near to human living area in the troposphere. How? By industrial pollution as a secondary pollutant. By industrial pollutant as a secondary pollutant. That ozone more dangerous, harmful. But what about this stratosphere? Clearly we have written it is harmless. It is not at all, nowhere concerned with harmfulness. Stratospheric ozone is harmless. Tropospheric ozone is harmful. Then, coming for air pollution, why and how air pollution is going to take place? The primary reason for air pollution is combustion. Combustion is the primary reason for air pollution. So, we are burning fuels, elements in fuel, burned in air, elements in fuel. What the fuel will consist of? Fuel consists of carbon, hydrogen, sulfur, nitrogen, lead, mercury, ash. So this fuel components, the fuel may be coal, kerosene oil, crude oil, petrol, diesel, whatever the fuel it may be. Some fuel from some sources combined with them, mixed with them. But atmospheric air containing nitrogen and oxygen burnt. Then that burning of that fuel combining with air releases carbon dioxide, carbon monoxide, nitrogen oxide, sulfur oxides, lead, mercury, suspended particulate matter, RSPM, PM10, VOCs, volatile organic chemicals. All this we call it as pollutants. Especially they harm air, they modify air. These are air pollutants. Got it? Combustion. Combustion is the primary reason for any kind of air pollution. The fuel, carbon, hydrogen, sulfur, nitrogen, lead containing fuel react with atmospheric air, nitrogen and oxygen. Released air pollutants, various components we have listed here. Then, so for your reference, just I am giving definition. For your reference, just I am giving definition of air pollution. The phenomena of presence of physical, chemical or biological contaminants. Contaminants means impurities which modify original nature. The impurities which bring modifications in the original nature of environment, those are called contaminants, impurities. So some physical, chemical or biological impurities where in the air. In some quantity, such quantity, this quantity is very important when those impurities exist greater than permissible means allowable limits. If they are less than allowable limits, no issue. We never thought, never think, no worries. Clear? If those physical, chemical, and biological contaminants in the air, in such quantity, what quantity? In such means what quantity? You tell me. In quantities, concentrations greater than allowable limit, their concentration is more than allowable limit, and for long duration they go stay in the atmosphere, stay for long duration in the atmosphere. Yes, greater than required. Very good, Ramya. Greater than accepted, greater than required. Very good, Ramya's concept. Greater than required. Then they cause adverse effects on human, animal, plant life, and also properties of human beings. Clear? Adverse effects on human life, animal life, plant life, and also properties unreasonably interfere with comfortable usage of air. So unnecessarily they disturb taking of air by human beings, plants, animals, and other properties. That phenomena we call it as air pollution. Students, got the clarity what is meant by air pollution, how it happened, why it happened? The impurities, physical, chemical, and biological impurity, more than required quantity, longer time duration spent in the atmosphere, cause adverse effects on human, animal, and plant life, or cause damage to properties. That makes air not under comfortable condition. That is called air pollution. Then we are considering sources of air pollution. This is simply normally in some textbooks or some local authors, it was written types of air pollution. We may take it as a types of air pollution, or we may consider it as sources of air pollution. So air pollution basically classified into three categories. First one based on size, based on origin of source, based on origin of source from where the source is originated. Second one based on spatial distribution, how it was distributed in the atmosphere, and based on source position, where source is located. Depending upon the three categories, air pollution has been classified. Clear? Based on origin of source, based on spatial distribution, based on position of source. Based on origin of source, natural sources. Meaning of natural, no human involvement. Nowhere human is concerned with this air pollution. The natural factors like volcanoes, mist, forest fire, etc. So is any involvement of human in this? Yes, pollen grains also, Ashok Krishna, very good. Pollen grains also. We can have a list, no problem. So is there any involvement of human beings? Volcanoes, mist, forest fires, bacteria and other sources, natural sources? No, human not at all involved. That naturally, the nature will create air pollution, that is natural sources. Anthropogenic. Anthropogenic is nothing but man-made air pollution, man-made sources. So we know, everyone will say what are man-made sources. Burning of fossil fuels, industrial pollutants, vehicular emissions, even we include cigarette smoking also as an anthropogenic source, because it is also releasing considerable amount of carbon monoxide, sulfur dioxide chemicals. So anthropogenic sources, man-made sources, which include, already we discussed, industrial air pollutants, air pollution, vehicular emission, cigarette smoking, burning of fossil fuels, whatever it may be, human involved air pollution, anthropogenic sources. Then, based on spatial distribution, point source, nothing but a single source. Pollutants released from that only one source. There are not more than one source. Pollutants are released only from one source. Example, only one industry located in a village. So in the entire village, no more industries, only one industry located at the outskirts of the village. So how many points of air pollutants are released? How many points of sources of air pollution? Only one point of source. That one point of source, that is a single industry. Aerial sources. So pollutants are distributed spatially, huge area. Why pollutants are distributed spatially in huge area? Because number of sources are several, n. When n number of sources are there, we'll take a city. City consists of several industries. Where the several industries are located? In a industrial area. Spatially distributed air pollutants. Huge area, industrial area. Ashok Krishna, volcanoes. So volcano may be also single source, na? Ashok Krishna. Volcano is also a single source. It is not a several sources. So industrial area consists of n number of sources. So aerially distributed air pollutant. Then, depending upon the location, position of source, stationary, the name itself, immovable source, static. The source always cause air pollution from a single static location. Immovable source, static location, not moving anywhere, immovable source. Example, again industry. Will industry moves anywhere? Will industry changes air pollution place to place, time to time? No. Once industry is constructed, the origin of air pollution from that industry is fixed at the same location. It is not at all varying. That is a static location, statically located source. Mobile sources, so moving sources. Simple. A truck moving on a highway. Will it cause air pollution at the same place? Vehicle. Very good. Dhanush. Truck moving on a highway. Will it cause air pollution in the same place every time? So it changes its location time to time. Mobile sources changes location of causing air pollution time to time. Changes location of causing air pollution from time to time. Got it? So these are the three basic categories of air pollution based on sources, based on origin, based on spatial distribution, and based on position of source. Now, shall we move on? So, types of air pollutants. So, what is air pollutant first? Tell me. I will write down here. Air pollutant. I will write down the definition here. This is a physical, chemical, or biological agent that cause, that contaminates atmospheric air, that contaminates atmospheric air and cause. What it causes? Adverse effects. Adverse effects on, as already we said, on human, plant or animal life. That is said to be air pollutant. That is said to be air pollutant. Yes, that is harmful for living beings if it is excess. Correct, Ramya? Contaminant adverse effect means harmful only. Whatever I have given as a adverse effect, that adverse effect, this is nothing but harmfulness only, Ramya. Physical, chemical, biological agent that cause contaminates atmospheric air and cause adverse effects on human life, plant life and animal life. That is said to be air pollutant. Now again, there is classification. I think you have got the clarity about definition. Now we have classification. Classification of air pollutants. First one, based on origin. Classification 1. Based on nature. Classification 2. Based on state of matter. Classification 3. So we come from the back end because first one is very huge. Elaborately we'll discuss first one. So we'll come from the back end. Based on state of matter. Particulates. Particulates are nothing but solid air pollutants. Solids. Like dust, fly ash, aerosols. These comes under solid air pollutants. Liquid. Liquid is mist. Even we'll take fog. Fog as a liquid air pollutant. Then third category, separately given gases. We can write down carbon dioxide, carbon monoxide, ozone, sulfur oxides, nitrogen oxides. We have a big list related to gases. Before I am going to give this classification, normally what you have thought in your brain, frankly telling, most of the people will feel air pollutant is a gas and it is a chemical molecule only. But remember, air pollutant is not only gas, it is a solid, liquid and gases, and not only chemical molecule, it may be physical, chemical and also biological molecule. Then based on chemical nature, air pollutants are differentiated into organic and inorganic. Organic air pollutants, hydrocarbons, volatile organic compounds, inorganic. Again, we can write down n number of lists, n number of inorganic pollutants. Based on origin, primary and secondary. Primary, from directly from source. Directly from source. Secondarily, it is not released directly from source, indirectly. So primary air pollutant is the air pollutant released directly from the source, and in the same original chemical form it is going causing air pollution, causing adverse effects to human life. It is not at all modified, it is not at all changing its structure, chemical composition and all those things. Within its original form directly as released from the source. In the same original form it releases, causes air pollution. That is primary. For example, I will give best example. From burning of fossil fuels, or some kind of coal. We'll take example. Burning of fossil fuel, carbon monoxide generated due to incomplete combustion. Carbon monoxide generated into atmosphere. Now this carbon monoxide gone for atmospheric tour. It visited troposphere, stratosphere, mesosphere, completed atmospheric tour for 1 to 2 years. Successfully completed, happily visited all zones, regions, places, and returning back onto Earth. Without modification as carbon monoxide only. Remember this point. Not chemically reacted, not physically reacted, returned back into the Earth strata as carbon monoxide. Now it is causing air pollution, entered into human body, causing carboxyhemoglobin formation. So such kind of air pollutant. Now carbon monoxide is called as a primary air pollutant. Then we consider secondary. From the same burning of fossil fuels, carbon dioxide is generated. Instead of carbon monoxide, now carbon dioxide is going to atmospheric tour. Okay. So previously carbon monoxide is gone to atmospheric tour. No change. The same original form it is entering into human body, causing problem to human life. Now carbon dioxide is released. It is gone into atmosphere, but during the journey, it may interact with water vapor available in the atmosphere. So carbon monoxide combined with water vapor in the atmosphere generated a new molecule. What is new molecule? H2CO3. Is it originated from the industry or fossil fuel? No. H2CO3 is originated from one primary air pollutant, carbon dioxide, one atmospheric component, water vapor, mixed together, generated acid rain, carbonic acid, H2CO3, acid rain, which is secondary air pollutant. Got the difference now? If as it is released from a source, it gone and again entered into human body, causing damage to human, plant and animal life without modification, that is primary source. Then if it entered into atmosphere, combined with other primary air pollutant or with atmospheric molecule, resulted a new molecule. That new molecule we call it as a secondary air pollutant. We'll give clear definition. Primary air pollutant and secondary air pollutant. Air pollutant released from the source directly and cause adverse effects in the same original form as released from source. As released from source. So my dear students, there is a power cut here. I think my voice and screen is visible to you. My photo is not visible to you. No issue. Within 2 minutes, generator will be on. You will get everything live. No issue regarding that. Okay, we are going to continue the class. Air pollutant released from the source directly and cause adverse effects in the same original form as released from the source. Very important. Without modification. Without modification is called as what we call it as a. So now the video is called as primary air pollutant. Is called as primary air pollutant. Clear? Air pollutant released from the source directly and cause adverse effects in the same original form as released from source without modification. Primary air pollutant. Got it? Then very important, you need to by heart the examples, because you have one minimum question related to examples, mostly repeated question related to air pollution. Identify list of primary air pollutants in the below options. Identify list of secondary air pollutants in the below options. That is very important question. So we can write down carbon dioxide, carbon monoxide, oxides of nitrogen, oxides of sulfur, hydrocarbons, suspended particulate matter, SPM, we call it as SPM, suspended particulate matter. Then aerosols, mist, volcanoes, dust particles. We can write down even the biological pollutants like bacteria, pollens, smoke, soot, etc. All these components, these are comes under primary air pollutants. This list of primary air pollutants is very important for you, students. Remember that carbon dioxide, carbon monoxide, oxides of nitrogen, oxides of sulfur, hydrocarbons, SPM, aerosols, mist, volcanoes, dust, bacteria, pollens, and soot. Secondary air pollutants. The air pollutants generated, where generated? In atmosphere, not from the source, in atmosphere. How? Due to interaction of primary air pollutant with another primary air pollutant or with atmospheric factors, gases or water vapor. Atmospheric gases like oxygen, water vapor. And then what it causes? And then causes adverse effects. Clear? And then causes adverse effects. This is called secondary. Clear? The air pollutant generated in atmosphere. How it is generated? Chemical or physical interaction of two primary air pollutants or one primary air pollutant with any one of the atmospheric factors like oxygen or water vapor, then causes adverse effects coming down to ground level. That is said to be secondary. For example, from fuel burning, we'll take from fuel burning, carbon dioxide, sulfur dioxide, nitrogen dioxide are generated. All these are primary. Burning of fuel generated carbon dioxide, sulfur dioxide, nitrogen dioxide. Then when they enter into atmosphere, what happened in the atmosphere? Water vapor interacted. Then this carbon dioxide water vapor generated H2CO3. Sulfur dioxide and H2O water vapor generated H2SO4. Nitrogen dioxide and water vapor generated HNO3. These are said to be secondary. What we call it as? We call it as acid rain. Acid rain is a secondary air pollutant generated due to carbon dioxide, sulfur dioxide, nitrogen dioxide chemical reaction with water vapor available in the atmosphere. So this is secondary and this is primary. Clear? Then we will write down examples for secondary air pollutants. Clear? Examples for secondary air pollutants. So as just now discussed, acid rain, ozone, smog. Smog is smoke plus fog. Vog. Vog is sulfur dioxide with volatile organic compounds, or smog with volatile organic compounds generated vog. Pan. Pan is peroxy acetyl nitrate, PBN, peroxy butyl nitrate, PPN, peroxy propyl nitrate. So these are the examples for secondary. Very important, remember it. Example for secondary air pollutant. Acid rain, ozone, smog, pan, PBN, PPN and vog. Those comes under example for secondary air pollutants. So we'll continue tomorrow. Clear? Tomorrow again the same topic, air pollution on YouTube live. Whatever your doubts, my mobile is switched off. So if you have given in the comments any doubts, I'm not getting. So you do one thing, you text WhatsApp message to my number 9704571767. This is my WhatsApp number. If any doubts related to air pollution or any subject, you just text me WhatsApp message. I will send the reply and give the solution to you. And in Unacademy platform, I'm going to teach civil engineering, environmental engineering, hydrology, irrigation, construction materials and management, open channel flow. And two of my friends from a big institutes also joined Unacademy. So we three combinedly going to complete entire GATE course, GATE or ESC course for civil engineering students. And in general studies, I am going to teach ESC general studies. I am going to teach energy and environment. Clear? I told you already, I have 150 plus batches training experience for GATE and ESC. I am top faculty in most of the GATE coaching centers in India. So now I joined Unacademy live classes. I'm going to teach environmental engineering, hydrology, irrigation, construction materials management, open channel flow for general studies, energy and environment. And my colleagues from big institutes also joined Unacademy. So we three members will complete entire GATE ESC civil engineering technical course. So we provide 100% knowledge and we make you to get completely crack GATE and ESC examination in the first attempt. Remember it. And if you want to subscribe Unacademy Plus course, paid course, use my code KPCivil. Generally, every faculty will say this. The faculty will provide you 10% discount. Only this is the benefit using the code with other faculty. But if you use my code, I will provide you free online test series. I have my own website. I will provide you free online test series for you. Any branch student, no issue. For each and every branch student, I will provide free online test series. I have free scanned copies of notes and other materials related to GATE and ESE. I will send you through mail, and my panel of faculty will support you throughout your career till you crack GATE and join PSU job, till you join your MTech in NITs and IITs. My panel of faculty will support you. And we have a WhatsApp group, Engineering Guru. In that Engineering Guru WhatsApp group, we clear the doubts. So many students, till now, 1,000 members of students are getting benefited through that WhatsApp group. So our panel of faculty will guide you for GATE preparation and also for post-GATE guidance. So if you use this code, just text me screenshot of your subscription. Immediately you get all the benefits, whatever I mentioned. Okay. Tomorrow at what time? Tomorrow at 8:30 p.m. Again, we are meeting on the YouTube live. Air pollution, same topic is continued for 5 or 6 days more. This is important for GATE and ESE Civil Engineering and also ESE General Studies. Students, remember, inform this to your other branch friends also. General Studies subject free live class on air pollution. You will get 2 questions from air pollution. Attend the class properly. Inform to your friends. Tomorrow we'll meet again. Until then, I'm signing off. Bye for today. Hello students, good evening all. Welcome to Unacademy, the largest learning online education platform in India. Unacademy providing a lot of free live lectures in its Unacademy platform and also YouTube platform to you. So you are glad to have knowledge from top educators in India through this Unacademy and other online learning platforms. Shall we go for audible, clear, very good. Sai Tejasvi, Sai Pavan, hi Sai Pavan, Abhinav Nanduri, Prakash 9995, I think Banu Prakash this is. Okay, we are good to start the class now. So yesterday we discussed air pollution part 1. For the new students who have joined, again I am going to repeat about myself. Old students don't get bored. The new students have to know me very well. Na? Old students know me. They spread regarding my teaching and other things. But old students also have to know about me. So myself, Krishna Prakash, have 10 years of GATE and ESE teaching experience in civil engineering. And I am going to teach the subjects environmental engineering, hydrology, irrigation, open channel flow, and also energy and environment from general studies of IES. I have an experience of 150 plus batches. I taught to 150 plus batches and trained n number of students, several thousands of students, and helped to get their ranks. I'm ex-ACE Academy faculty. I taught in all the big institutes in India. Now to help more number of students to reach out several students at a time, I'm entering into online platform because classroom is a confined space. So if we go for online coaching, so unlimited students can reach it from any part of the country, from remote places, towns and villages also. Students can watch the free live classes. So I am entering into this online live classes really. So now we are going to have a live session today regarding air pollution. Okay, we'll go ahead with the topic. Yesterday, what we have discussed regarding air pollution. So this is air pollution part 2. Part 1, yesterday we have finished. Air pollution part 2. Yesterday we finished, completed. What we completed? Air pollution, introduction, sources or causes of air pollution and its types. And also we completed types of air pollutants. Now the remaining individual air pollutants and their effects, their concentration units and its conversions. So today what we are discussing, individual air pollutants, their effects, estimation of concentration units and their conversions. Today we are going to discuss. And yesterday in the YouTube live, one student texted a message. Sir, please give some time for writing. Very good. Giving some time for writing is also very good. But some students, if I wait 5 minutes, 2 minutes, 3 minutes like that, some students getting bored. So, my dear student, don't worry if you want to write. This live class will be stored in the YouTube as a recorded version after the completion of class. From this recorded version, you can write. You can drag the mouse, you can drag the video wherever you want, you pass it, you can write the notes and you can continue it, so that no problem for writing the notes. Okay, in live session you go through the subject, you focus on the subject, learn the subject. If you have doubts, text it. Okay, in the yesterday's messages I have seen, so one student have written give some time for writing. So regarding writing in this live session we can't provide, because different students have different speed of writing. So you do one thing, you go for recorded video, you can pause it, you can write and go for next topic like that. First you focus on the subject concept. Okay, learn the subject now. So before going to start part 2, from the yesterday's class, I want to solve previous questions from GATE and IS. So yesterday's class, previous question, theoretical questions. First question. Consider 4 common air pollutants found in urban environments. 4 air pollutants: NO, SO2, soot and ozone. Among these, which one is the secondary air pollutant? Which one is secondary air pollutant? Good evening, Ashwin. So yesterday I told you, while giving examples for primary and secondary, clearly mentioned, the questions most repeated in air pollution is related to examples for primary and examples for secondary air pollutants. So identify the list, I said. Now they have given the list. Nitrous oxide, that is a primary air pollutant. Sulfur dioxide, also primary air pollutant, we have written. Soot is a black carbon mass. When coal is burned, cooking gas is burned, the black color powdered mass generated, that is said to be soot. That is also primary air pollutant. Yeah. So remaining, ozone. So most of the students opted A. Very good. So I feel very happy. You have answered option A, means all the students have followed yesterday's class. They learned something. I feel very happy today. So they have given correct answer option A, ozone. Ozone is a secondary air pollutant. Because ozone is formed due to chemical interaction of certain primary air pollutants and solar radiation in the atmosphere. So as a resultant of chemical reaction between primary air pollutants and solar radiation, ozone is generated. That is a secondary air pollutant. Next question. The atmospheric layer closest to the Earth's surface is. So this is a straightforward question, no twist in this question. Yesterday we have given layers or zones of atmosphere. What is the answer? Abhinav answered B. No, it is D. Yes, Abhinav corrected. Closest. D. Prakash, you have answered C. Okay, fourth one C you have given answer. So Prakash is very forward. He answered for fourth one. Okay, we'll go step by step. Troposphere is the zone of Earth, zone of atmosphere, which is closest to the Earth's surface and where most of the weather phenomena occur. Yesterday we have written this one also, but this is important. Again, I'm writing. So D is the answer. So everyone answered D. No one have doubt regarding this. Now, which one of the following is not present in acid rain? So clearly in the last minute I have given. When fuel burnt, it releases carbon dioxide, sulfur dioxide, nitrogen dioxide. That combines with water vapor resulted HNO3, H2SO4, H2CO3. 3 forms of acid rain. What is not possible? Clearly mentioned, not present. Not present. CH3COOH, which is called acetic acid. This kind of organic acid rains are not possible. Mineral acids, HNO3, H2SO4, H2CO3, these are said to be mineral acids. Mineral acids are forming acid rain. So CH3COOH is organic acid which is not capable of forming. Then two primary air pollutants are, I told you already, identify list of primary air pollutants. This is the list. Sulfur oxide and ozone. Ozone, just now we have answered, ozone is secondary. So we can eliminate option carrying ozone now. Then remaining two options. Nitrogen oxide, peroxyacetyl nitrate. This is a secondary. Peroxyacetyl nitrate is a secondary. So what is answer? Sulfur oxide and hydrocarbons are primary air pollutants. Got it? Next one. Consider the following statements related to ozone. Tropospheric ozone is harmful. Correct. Stratospheric ozone is harmless. This is also correct. During prevalence of photochemical smog, ozone is formed. I told you already. Photochemical reactions happen in the atmosphere. Primary air pollutants interact with the solar radiation resulted photochemical smog. That photochemical smog generates secondary air pollutant, that is ozone. So all three statements are correct. Clear? What is the answer now for this question? A. Subhajit Banerjee. Astosh Agarwal, what? Yes, you said yes. So option A, Banu Prakash answered A, Subhajit Banerjee answered A. So all the three statements are correct. 1, 2, 3. Troposphere, ozone is harmful. Clearly written. Stratosphere, ozone is harmless. Yesterday we have written clearly in the diagram also. Prevalence of photochemical smog, ozone is formed. So 1, 2, 3, all three are correct. Then ozone layer present in the atmosphere protects life on Earth by not permitting harmful radiations present in the sunlight to penetrate through it. Ozone layer, this is the question actually. Unnecessary, first data is unnecessary. Ozone layer is formed by the reaction of, tell me. Ozone layer is formed by the reaction of? This answer. So Banu Prakash answered 6th question C. Any other answers? Sahil Sinha answer A. Abhishek Singh answer C. C. Subhajit answer A. No. They are asking how ozone layer is formed by reaction of, not depleted by reaction of. That is very important thing you need to remember. Depleted by reaction of, answer is A. Ozone layer depletion. Then you give the answer option A, CFC on ozone. CFC on oxygen. CFC on oxygen. But the question is, ozone layer is formed, yesterday we explained, na? Solar ultraviolet light radiation on oxygen. So, UV light radiation plus 3 oxygens gives 2 ozone. This ozone is formed, ozone layer. So remember, answer for ozone layer formation, option C. For ozone layer depletion, the answer is option A. But the question is clearly mentioned, ozone layer is formed by the reaction of solar radiation on oxygen. Clear for everyone? How to build triceps? How to stay muscular? Killer boy. This is not the class of building biceps, muscles and other things. Just leave the class. This is unnecessary question for you, Mr. Killer boy. You are coming to learn the subject or you are coming to learn biceps and all those things. Then the topic now we are discussing here, concentration units of air pollutants. So this is the basic numerical question required for air pollution. Very important question also. So in air pollutants, the unit of expressing concentration is microgram per meter cube. Clear? How can I watch previous video? Aman Singh, previous video, you go for Unacademy live or text me. I will send the link to you. Aman Singh, I think you are in the group. You text me or you simply type air pollution civil engineering part 1 in YouTube. It will come. Okay. You type air pollution civil engineering part 1. You will get a link about it. YouTube. Yes. The concentration of air pollutant, whatever it may be, particulate matter, gases, whatever it may be, the units for expression, microgram per meter cube. The units for expressing air pollutants, microgram per meter cube. If we consider how to convert microgram per meter cube to ppm, how will convert this microgram per meter cube to ppm? Shall we write down 1 microgram per meter cube is equal to 1 ppm? Shall we write down like this? Like how what we have written in water pollution. In water pollution, we are going to write now 1 mg per liter is equal to 1 ppm. Same manner, shall we write here 1 microgram per meter cube is equal to 1 ppm? No, not possible. Then, few people consider 1 microgram per meter cube is equal to 10 power minus 3 milligram divided by 1000 liter, which is equal to 10 power minus 6 milligram per liter. And also, as we know from water pollution, 1 mg per liter is equal to 1 ppm. So now we can write down 1 microgram per meter cube is equal to 10 power minus 6. Instead of milligram per liter, we can write down ppm. So is it correct? 1 microgram per meter cube is equal to 10 power minus 6 ppm. First, we are converting microgram per meter cube to mg per liter. 1 mg per liter is equal to 1 ppm. So we are going to write 1 microgram per meter cube is equal to 10 power minus 6 ppm. Is it correct? No. Remember, this is also not correct. Then why writing and again striking off this is not correct, this is not correct? Why writing and striking off? Because if you have written this one in your notes, you are not going to do these mistakes in examination. If you have not noted down this in notes, in simple, few students will take directly 100 microgram per meter cube is equal to 100 ppm. Few students will take 100 microgram per meter cube is equal to 100 into 10 power minus 6, 10 power minus 4 ppm. But that conversion is not possible for air pollutants. Clear? That is for water pollutants. We are discussing air pollutant. Why? What is the difference between water and air? What is the difference between water and air? Because water is having fixed volume. Air is not having fixed volume. For example, I say 1 liter of water you have taken and filled into 2 liter water bottle. What is water volume? What is water volume? 1 liter water loaded into 2 liters container bottle. What is water volume? That is 1 liter only. But if you take 1 liter of gas loaded into 2-liter container, gas volume increases. That increased volume we call it as 2 liters now. So depending upon container size. Another example I will tell. 1 liter water you have and you will be provided with a 500 ml container, 500 ml water bottle. Will you fill total water into it? Yes, law of universal gas should be used. Correct, Vedant, very good. So I have given 1 liter water and asked to fill into 500 ml container. Is it possible? No, it is not at all possible. But I have given 1 liter gas, asked to fill into 500 ml container. It is possible. By increasing pressure, we can reduce volume. So the meaning of this, volume occupied by gas is not fixed. Volume occupied by gas not fixed. It is depending upon temperature and pressure. Got it? Got it, everyone? Volume occupied by the gas not fixed. It is changing with respect to temperature and pressure. So now we are going to write down. Now we are converting. First conversion, what we are doing? Conversion, what we are doing is the data is given X gas or X pollutant given parts per million. You have to convert to microgram per meter cube. X is given in parts per million. X given parts per million. You have to express microgram per meter cube. Remember, X, what is X? It may be carbon dioxide, it may be sulfur dioxide, it may be methane, whatever it may be. Some chemical component, X in microgram per meter cube is equal to. Given is X in parts per million, ppm. Remember, I am giving a simple, sweet shortcut formula. Just direct formula substitution, you will get the answer. X in microgram per meter cube is equal to X in ppm into molecular weight of X divided by volume. Molecular weight of X divided by volume. This volume we are taking liter per mole. Remember, this is very important. So volume you are taking in liter per mole, but you need to express in meter cube. So liter to meter cube will convert 10 power minus 3. 1 liter is equal to 10 power minus 3 meter cube. Where this 10 power minus 3? In denominator. That means 1 by 10 power minus 3. How can we take? 1000. Clear? 1 by 10 power minus 3. So we'll take 1000 in the numerator. So in the denominator volume always you are taking in liters. Because you are multiplied in the numerator with 1000. So you are expressing X in microgram per meter cube. So X in microgram per meter cube is equal to X in parts per million ppm into molecular weight of X by volume occupied by the gas. Volume occupied by the X into 1000. Then second conversion I am going to tell you. Second unit conversion you need. Concentration of X is given in ppb, parts per billion, and that is to be converted to microgram per meter cube. Concentration of X given in parts per billion ppb, that is to be converted to microgram per meter cube. Simple, very, very simple. So same, X is required microgram per meter cube and X is given in parts per billion, because X in ppb divided by 1000 is equal to X in ppm. Okay, that means in place of X in ppm we are taking X in ppb by 1000. So this 1000 and this 1000 is cancelled. Simple remaining. X in ppb into molecular weight of X by volume, same volume in the liter per mole. We have taken this 1000, but that 1000 was cancelled by unit conversion, X in ppb by 1000. Got it? Subhajit Banerjee, for this point, liter per mole last 2 marks in GATE 2020. So remember this one, Subhajit. So X in microgram per meter cube is equal to X in ppb into molecular weight of X by volume. That volume expressed in liter per mole, not liter per meter cube, liter per mole. Got it? Two formulas we have, unit conversion. ppm to microgram per meter cube, ppb to microgram per meter cube. Both cases, what we require? Molecular weight, volume. Molecular weight, we know it. What is molecular weight? So most of the students know about it. In simple, I will say molecular weight is equal to sum of atomic weights of elements. Molecular weight is equal to sum of atomic weights of elements. For example, I will show you here. You require molecular weight of carbon dioxide. Carbon atomic weight is 12 plus 2 oxygens are there. Each oxygen atomic weight is 16. So total carbon dioxide molecular weight, we can write it down as 44. Clear? Got it for everyone? Molecular weight is sum of atomic weights. For example, carbon dioxide, carbon 12, oxygen, 2 atoms are there, each 16, 2 into 16. So total 44 is a molecular weight of carbon dioxide. Okay. We'll estimate molecular weight like this. Then, how can you get volume occupied by X in the units of liter per mole? How can you get volume occupied by X in the units of liter per mole? Here there are two possible conditions. If no information regarding temperature and pressure, or if information is given, temperature is 273 Kelvin or it may be said to be 0 degrees Celsius. Pressure is 1 atmosphere. Clear? Whether in your numerical question, no information about temperature and pressure, you take it as STP, standard temperature and pressure. Then if nothing is given, happy, no need to worry. If temperature is given and that is 273 Kelvin or 0 degrees Celsius, pressure is given 1 atmosphere, both given, but both are standard values only. Then what you take volume? What you take volume? Volume is equal to 22.4 liters per mole. 22.4 liters per mole. From where we got this? This we got from Avogadro's law. A statement of Avogadro's law. 1 mole of any gas, the gas may be anything, at a standard temperature of 273 Kelvin and standard pressure of 1 atmosphere always occupy 22.4 liters volume. That is a statement of Avogadro's law. Clear? The basic statement of Avogadro's law we are considering here. Volume occupied by any gas at a standard temperature and pressure of 1 mole. 1 mole is 22.4 liter. And that is expressed mathematically using Avogadro's equation. PV is equal to nRT. Actually, in so many coaching centers and textbooks and materials, they have written PV is equal to nRT. So many values are given. Finally, volume is derived. All this is not required. You are a civil engineering student. You need to know how to solve the question. All this calculation derivations not required for exam. So, if temperature and pressure is given, blindly substitute 22.4. Temperature 273 Kelvin, pressure 1 atmosphere is given. In the previous formula, in this formula, directly take volume 22.4 liters. Easily your question is completed. Second condition. Conditions other than STP. So if temperature is not 273, pressure is not 1 atmosphere, conditions other than STP, they have provided some other conditions. What you will do? Temperature is not 0 degrees Celsius, pressure is not 1 atmosphere. For example, temperature 10 degrees Celsius, pressure 1.5, modified, non-STP. Then don't worry, again I will give you simplified formula. Few people will say, use P1 V1 by T1 is equal to P2 V2 by T2. P1 V1 T1, these are standard temperature, pressure and volume. P2 V2 T2, these are given condition. Given pressure, given temperature substituted, will get a volume. And PV by T is equal to constant. So we don't want all these things because I will give you a secret here. This is a secret formula. Directly you are getting volume. Simply you take one factor 0.082 into temperature by pressure. Given temperature by given pressure. So this is secret. Don't share with anyone. Only those who watch my video only should know. The remaining students don't get this one. The remaining students are roaming around. P1 V1 by T1 is equal to P2 V2 by T2 or PV is equal to nRT, substituting all the values, formulas, equation, wasting their time in exam. Just this one, if you remember, 0.082 factor. You are taking temperature in Kelvin, pressure in atmosphere. 0.082 into given temperature by given pressure. You will get volume in liter per mole. Don't waste your time in examination. That is very important. Clear? You have to solve the question in 2 minutes. So this shortcut formula is very helpful for competitive exam to save your time. So this is a secret formula. So remember, keep it secret only. Don't share with those students who have not attended the class. So this is the benefit you got by this class. V is equal to 0.082 into T by P. Wherever you observe textbook material notes of other faculty, other coaching center, they show either by PV is equal to nRT or by P1 V1 by T1 is equal to P2 V2 by T2. Finally, they will get the volume using this formula answer only. So remember this one. 0.082 into T by P, then that is substituted here. So simple question. First, by reading that concentration, you can observe whether temperature, pressure are given and they are STP or not. If they are STP, first condition you take 22.4 liter. Non-STP, then substitute in 0.082 into given temperature by given pressure, you will get the volume. Substitute volume here, you will get the X in microgram per meter cube. The simple best formulas, shortcut formulas. If you go for the big coaching center materials and notebooks, you have long derivations to solve the question and a lot of confusion. So just remember this 1 and 2 formula. X in ppm into molecular weight of X by volume into 1000. X in ppb into molecular weight by volume. Simple formula. Then V is equal to 22.4 liter per mole at STP. V is equal to 0.082 into T by P. Simply you solve the questions related to air pollution unit conversion. Is there any difficulty in this topic here? Long derivations don't want. We are going for a competitive exam to solve the question only. So simple solution for the question I have provided you. The short and sweet solution I have provided you. Here. Yes, Abhishek Singh I have given other than STP also. Abhishek Singh is in hurry. He need other than STP. Clear? Okay. So we are going to solve the numerical questions now. Express 400 microgram per mole. Sorry, microgram per meter cube. Remember this one. 400 microgram per meter cube. Sir, आप सही एक रिक्वेस्ट है, जस्ट क्लियरली से आप पढ़ाते तो प्लीज आप सिविल के सारे सब्जेक्ट्स तो पढ़ाते हो सर प्लीज. Yes, Abhishek Singh, I am going to teach nearly 5 subjects. If I am going to teach more than 5 subjects, you are getting bored. So first learn these 5 subjects. Later on, we'll think about remaining subjects. Okay. Express 400 microgram per meter cube of carbon dioxide in ppm and ppb at STP. So question is simplified. Easily given for us. STP, they mentioned STP means volume is equal to 22.4 liter per mole. Simple, na? STP given, volume is equal to 22.4 liter per mole. Then carbon dioxide molecular weight. It is molecular weight of carbon dioxide. Carbon 12, oxygen 2 into 16, 44. Now, 400 microgram per meter cube given. 400 microgram per meter cube is given. That is equal to required first ppm, carbon dioxide in ppm into molecular weight. What is molecular weight? 44 divided by 22.4 into 1000. So Subhajit already finished the question. 0.203 ppm. So carbon dioxide is equal to carbon dioxide in ppm is equal to 0.203 ppm. Very good, Subhajit. This fastness is only required. This fastness is only required in GATE and IS examination. But this fastness only will give you sometimes, not always, sometimes. If you have not having clarity about units to express, you will get negative marks sometimes. If you have clarity regarding units to express, it is easy. Now, carbon dioxide in ppb, simple. Carbon dioxide in ppm into 1000. Why? They are given clearly, na? See here. X in ppb by 1000 is equal to X in ppm. So X in ppb is equal to X in ppm into 1000. The same thing we did here. X in parts per billion is equal to X in parts per million into 1000. So 0.203 into 1000. 203. Clear? 203 ppb. Who have answered? Aswin answered. Subhajit answered. Deepak Kumar, very good Deepak Kumar. Aswin Venkat. Prakash. Vishwam Manoj. Abhishek Singh. Naresh Chauhan. Tomorrow schedule. Same schedule, Naresh Chauhan. No change. 8:30 to 9:30. Air pollution part 3. We'll go ahead. Till air pollution completion, we'll continue YouTube classes 8:30 to 9:30 schedule only. So I think you are asking now tomorrow schedule means you are leaving the class. Don't leave the class. Some more 20 minutes class is there. So we'll go for the next question. This one completed. The mean indoor airborne chloroform concentration. This is a previous GATE examination question. The mean airborne indoor chloroform concentration, CHCl3 concentration, 0.4 microgram per meter cube. The difference, temperature 293 Kelvin. Pressure, okay, 1 atmosphere, standard only. No? Pressure is standard only, no need to worry. But the temperature 293 Kelvin. R value, because we have some short and sweet formula. We don't want R value and other things. We directly go for solving. So volume is equal to 0.082 into 273 by 1. So we'll take 0.082 into, 293. 0.082 into 293 by 1. That is said to be volume. So Abhishek Singh is very fast. So that is previous question. Okay. 203. Abhishek Singh has given previous question. Volume 0.082 into 293 by 1. CHCl3. We need molecular weight. CHCl3, carbon 12, given na, carbon 12, hydrogen 1, chlorine 35.5. Carbon 12, hydrogen 1, chlorine 3 are there. 3 into 35.5. 3 into 35.5. Why we are calculating in ppm or ppb? So ppm parts per million and ppb parts per billion. These are the universal units, because in water also we are expressing in parts per million. So per 1 million parts of the gas, how many parts of pollutants are present? Means if you say 1 liter of a gas, 1 liter of a gas consists of 1 million parts of gas. In that 1 million parts of pure gas, how many parts of impure gases are present? In simple, 1 million parts of fresh air, how many parts of CHCl3 is present? 1 million parts of fresh air, how many parts of carbon dioxide is present? That is expressed in terms of ppm, parts per million. So what is CHCl3 molecular weight? CHCl3 molecular weight, 12 plus 1 plus 35.5, 119.5. This is molecular weight of CHCl3. Now, we require CHCl3 in what units? Parts per billion. ppb. Given. What is given? Microgram per meter cube is given. 4 microgram per meter cube is given. So 4 is substitute in our formula. 4 microgram per meter cube is equal to CHCl3 in ppb into molecular weight 119.5 divided by, what is divided by? Volume 0.082 into 293 temperature. Then after solving, we will get CHCl3 in ppb parts per billion. What you will get? 0.08 Yes, this one not 4. Very good. Good observation. This is 0.4. 0.08 ppb. Got it? Aswin, very good observation. That is 0.4 microgram per meter cube you have taken. So answer is 0.08 parts per billion. So everyone got the answer? Answer is option D, 0.08 ppb. Clear? You go for next one. The concentration of sulfur dioxide in ambient air 30 microgram per meter cube, SO2. SO2, 30 microgram per meter cube. Under the same condition, above sulfur dioxide concentration in ppm. Generally in exam, we read a question up to this only. We left it, we start solving the question. But a very important thing they have provided. P by RT is equal to 41.6 mole per meter cube. P by RT is equal to 41.6 mole per meter cube. What is this P by RT? So when we take Avogadro's equation, PV is equal to nRT, then volume is equal to nRT by P. But without knowing this P by RT, some people directly take it as V, volume. So if you are not considering anything regarding P by RT, anything you have not considered about this, directly you started substituting in ppm, option A. If you take P by RT as volume, started substituting. P by RT as volume, started substituting. That is option B. But actually, what is P by RT? 1 by V. 1 by V. 1 by V is equal to P by nRT. They considered n is equal to 1, so P by RT is equal to 1 by V. So what is V now? V is equal to 1 by 41.6. 1 by V is equal to P by RT, that is equal to 41.6. Then V is equal to 1 by 41.6. It is the unit. Meter cube per mole. Then we solve question considering directly V is equal to 1 by 41.6. That is option C. But in which units volume is required? Clearly we have written in the formulas now. Which units volume is required? Liter. Liter per mole. Remember, we require volume in the units liter per mole, not in meter cube per mole. So V is equal to 1000 by 41.6 liter per mole. So remember this point. So finally you derived volume from given P by RT. Got it? From given P by RT is 1 by V. Then V is equal to 1 by 41.6. So V is equal to 1 by 41.6 meter cube per mole. 1 meter cube is equal to 1000 liter. So 1000 by 41.6 liter per mole. Now what is given? Given is sulfur dioxide. Got it? What is given? Given is sulfur dioxide, 30 microgram per meter cube. Sulfur dioxide, 30 microgram per meter cube. Now we can write down sulfur. Sulfur 32 molecular weight plus oxygen 2 into how many? 16. So 64. 64 is molecular weight of sulfur dioxide. 64 is molecular weight of sulfur dioxide. So we can write down 30 microgram per meter cube is equal to sulfur dioxide required in ppm into molecular weight 64, volume 1000 by, what is given volume? 1000 by 41.6. 1000 by 41.6 into 1000. Now we need to express sulfur dioxide in the units of parts per million. 1000 getting cancelled. Then what is the value of sulfur dioxide in ppm now? Tell me what is the answer? 0.01126 ppm. Very good, Subhajit. 0.011 ppm. This is the answer. Got the clarity? The most simplest form of determination. The only confusion, see how few confusions here. Regarding this P by RT, if you understand this point, and the second one, you need to understand volume is required in liter per mole. If you understand these 2 points, question is completed. So everyone answered. Very good. Ashwin, Deepak Kumar, Subhajit, Engineering Guru, Vishwam Manoj, Arpan Kohli. Everyone answered. Very good. Volume in liter per mole. P by RT is not V. P by RT is 1 by V. 2 important points you need to remember. Easily you solve the question. Clear? Done. Then we'll discuss regarding small portion. Before 10 minutes class, I will finish it. 10 minutes. Before that, small portion will finish off. Major air pollutants. In the atmosphere, there are various n number of air pollutants are there. Those n number of air pollutants, we have differentiated majorly. Carbon monoxide, highest air pollutant, carbon monoxide, 48%. Emissions, especially we are talking only about, remember, primary air pollutant, classification of primary air pollutant. Carbon monoxide, 48%. Sulfur oxides, SOx, 16%. Nitrogen oxides, 16%. Particulate matter, 5%. Volatile organic matter, VOM, 15%. Remaining very small, negligible, rare concentrations. So major primary air pollutants we have classified. Carbon monoxide 48%, sulfur oxide 16%, and nitrogen oxide 16%, particulate matter 5%, volatile organic matter 15%. Then in that, the first one we are going to discuss, carbon monoxide. We are discussing about carbon monoxide. So these are said to be sources of release of carbon monoxide. This pie diagram. If I have given a diagram, that is easy for you to understand. If you write like a notes, so you are confusing, and that is simply dictating some theory information. If I give you some diagram, that picturization will be impressed on your brain. So I have drawn a pie diagram here. Sources. Major sources vehicles, road vehicles, on-road vehicles, 56%. Non-road vehicles and engines, like trains. So road vehicles are buses, cars, bikes and other things. Road vehicles, 56%. Trains and aeroplanes, non-road vehicles. Engines used in various industries, 22%. That means overall, vehicular emission releases 78% of carbon monoxide. Then fuel combustion, 6% of carbon monoxide. Industrial process, 4%, remaining all combinedly 12% of carbon monoxide. Here, the major cause of carbon monoxide. This major cause of carbon monoxide, incomplete combustion of fuel. incomplete combustion of fuel. The major cause of carbon monoxide, primarily incomplete combustion of fuel. That is primary cause. The very important word related to carbon monoxide you need to remember. Carbon monoxide is an acute toxicant. So what is an acute toxicant of all air pollutants? That is previous question. Carbon monoxide is an acute toxicant of all air pollutants. Why? Because this carbon monoxide combines with hemoglobin of blood circulation. Releases a toxic compound, carboxy hemoglobin. Generally, while we are taking fresh air, the oxygen component of the air combines with hemoglobin, resulting oxyhemoglobin. In this path, oxygen and hemoglobin both circulated to human body parts, where oxygen acts as a fuel, hemoglobin acts as a vehicle. Hemoglobin is a carrier that transports oxygen to every body organ. Both mutually benefited combinedly, oxygen and hemoglobin circulated to body organs. Oxygen acts as a fuel and hemoglobin acts as a vehicle. Vehicle and fuel both travel to each body part of human and circulated. If you have taken instead of fresh air, an air polluted or contaminated with excess amounts of carbon monoxide, now that excess amounts of carbon monoxide entered into body, then it started interacting with hemoglobin. Clear? Hemoglobin. Then that carbon monoxide interacted with hemoglobin, forms an asphyxiant, carboxyhemoglobin. Carboxyhemoglobin is an asphyxiant. Asphyxiant is an agent. What it causes? Asphyxiant is an agent which causes breathlessness, coma. Asphyxiant is an agent which causes breathlessness or coma. Then, so blood circulation is disturbed and high doses of carbon monoxide, high concentration. Carbon monoxide is high concentration. Then it leads to severe heart to stroke, heart attack. And it may lead to death. So because of that reason, carbon monoxide is said to be acute toxicant in your body. Incomplete combustion of fuels are going to release carbon monoxide. Carbon monoxide is an acute toxicant in the human body. It results carboxyhemoglobin. Here, carboxyhemoglobin is an asphyxiant which causes breathlessness. You are going for coma. High doses leads to heart to strokes, heart attack, and leads to death. High doses are going to cause. Then, estimation of carbon monoxide. Carbon monoxide is going to be estimated by using NDIR analyzer. Estimation of carbon monoxide is carried out using NDIR analyzer. What is NDIR analyzer? Non-dispersive infrared analyzer. This is an instrument which is used to estimate direct death after excess intake. Yes, correct, Ashwin. Direct death only caused after excess intake. So NDIR analyzer is a non-dispersive infrared analyzer which is going to estimate the amount of carbon monoxide. Then if carbon monoxide is present in atmosphere, it combines with oxygen in atmosphere, it releases carbon dioxide. Carbon monoxide in atmosphere combines with oxygen and releases carbon dioxide. Then limit. What is the permissible limit of carbon monoxide in atmosphere? Carbon monoxide is accepted up to 2 microgram per meter cube. Permissible limit of carbon monoxide, safe limit of carbon monoxide in the ambient air, atmospheric air, 2 microgram per meter cube. Got it? So that in this, the most important point you need to remember, what is an acute toxicant in the air pollutants? Second one, permissible limit of carbon monoxide. Permissible limit is 2 microgram per meter cube. Then 1 hour finished easily. I never feel 1 hour is completed, but time is up. Okay. Any doubts in today's class, my dear students? Any doubts, you tell me, you text me. I am observing your messages in this another tab. Another device, I am observing your comments and messages. So anything, any doubts related to today's topic or yesterday's topic, we'll discuss and close the session for today. And we'll have again same session, same YouTube live, 8:30 to 9:30. Tomorrow, air pollution part 3. Okay. So no one is going to type anything. I think there are no doubts related to today and yesterday's topic. I think so. Everything is clear for everyone. Got it, the concepts? So do one thing. Solve some numerical questions related to concentration unit conversions. If you have any doubt, you WhatsApp me, text me. So you have my number also. This is my number, my WhatsApp number 9704571767. And I have my Telegram channel. I think most of the students will know it. Engineering Guru. ENGGGURU, Engineering Guru. So tomorrow, same 8:30 p.m. YouTube live, air pollution part 3. And yesterday also I told you, if you want a full session of complete subject of GATE ESC, environmental engineering, clear, full session of GATE ESC, environmental engineering, then you subscribe using my code, either KP Civil or Engineering Guru. You can use my code, either KP Civil or Engineering Guru. Yesterday some student asked, KP Civil not working. No, you check once, KP Civil is working properly. How n is equal to 1? If not given, we are assuming Manoj. N is equal to 1, n is not given. Directly they have given P by RT. So you can assume it n is equal to 1. No issue regarding that. Previous n is equal to 1. Okay. Then benefits of using my code KP Civil or Engineering Guru. You will get 10% discount. So every student will get 10% discount. Don't worry about this. Free online test series. So every faculty in Unacademy will say use my code, you will get 10% discount. But along with that, I am providing you free online test series. I have my own website, own channel and everything. I will provide you free online test series. The scanned copies of notes of all subjects and other materials related to GATE and ESC preparation. My panel of faculty will support you. And also we have doubt clearance session in WhatsApp group. And subscribe to my Telegram channel, Engineering Guru. And a few students expressed some doubts. Sir, you are teaching very good. You teach 4 or 5 subjects. How we take, by seeing your class only, how we will take GATE total subscription. So don't worry. Myself, Krishna Prakash, I am going to teach the subjects environmental engineering, hydrology, irrigation, construction management, construction materials and management, open channel flow. And my friend from great institute came, Rajendra Prasad, RP sir, people know it, RP sir, one big institute, he's also working in one big institute. Yeah, he is also having 7 years of GATE teaching experience. He will teach transportation engineering, RCC, steel, and structural analysis. One more friend is going to come soon into Unacademy platform. He is going to teach you geotechnical engineering, surveying. So all civil related subjects completed for you. Clear? I'm going to teach 5 subjects, Rajendra Prasad 4 subjects, that other new, very big faculty from one of the big renowned institute, great institute is coming. He will teach geotech and survey. And mathematics and aptitude, we have best faculty in Unacademy. So you go through that Unacademy mathematics and aptitude classes. You are going to tell me who is the best faculty. And also fluid mechanics, strength of materials, we have mechanical faculty who are teaching that. The civil part of FMHM I am teaching OCF, open channel flow. Then fluid mechanics, strength of materials, Praveen Kulkarni sir is there. He will teach for civil engineering so that you will get best knowledge from him. So this waiting for hydrology class, sure Aswin, I will take it short time. I am waiting for geotechnical. Yes, one new faculty, he will satisfy more than you expected. One new faculty will come. So don't worry about syllabus completion, faculty feedback and all those things. I am the head for South Indian team of civil engineering in Unacademy, the English teaching faculty. I am the head for civil engineering in English teaching faculty. Whatever your doubt after taking subscription, whatever your problem related to Unacademy, I will solve, I will assure you. The only thing you want to do, you take subscription using my code KP Civil and get all the benefits. I will support you till you join a PSU or till you join NIT or IIT. Already those students who know me very well, they know how I supported them in their studies and career. So you also experience the same. Okay, tomorrow we'll meet again. Remember, this is my phone number and this is my civil, KP Civil is my code. If you want to join Telegram channel, Engineering Guru, ENGGGURU. So again, we'll meet tomorrow. Until then, for today, I'm signing off. Bye-bye. Good night, all of you. Good evening, all. Welcome to Unacademy, the largest online learning platform in India. Unacademy creates a huge opportunity for the students to go through n number of free live lectures, interactive lectures, and also provide the faculty to interact with n number of students to help the faculty as well as to help the student community. So it is a revolution in Indian online learning education. So spread the information regarding Unacademy and give information to your friends, juniors, relatives, anyone. Make them to learn through India's top educators in Unacademy. Don't be selfish. Normally students are too much selfish. Don't be selfish. Spread the information about the free live classes going on in Unacademy. Okay, this is a big platform given to students to have an opportunity to interact with various faculty throughout the country. The student may be at a village, very remote place. So he is interested to learn the subject just by his mobile. Will get whatever the subjects he want, he can learn through Unacademy platform. Okay? Is everything is clear? Video is clear? Audio is clear? So any one of you text me. Okay. Amiya Kumar Nayak, I have doubts. Can you please help me? Help for ecology and environmental studies. So Amiya Kumar Nayak, you continue the class till the end. My phone number will be there. You can text what is your doubt through WhatsApp, because this is a irrelevant subject now. If it is air pollution doubt, I will clear now itself. But it is not related to air pollution, ecology and environmental studies. By the end of the class, you will get my WhatsApp number. You send a message to that WhatsApp number. I will clarify all your doubts related to Ecology and Environmental Studies. No issue regarding it, Kumar. Then we'll go ahead. So myself, Krishna Prakash, students used to call me, love to call me as KP sir or double sir. I have 10 years of GATE teaching experience. I trained several thousands of students, several batches in all the GATE coaching centers, IS coaching centers in India. Now this is a new platform, Unacademy, made me very close to the students in the form of comment box. So now I am glad to have a live interactive session with you on YouTube. So till yesterday we discussed two parts of air pollution part 1 and part 2. In part 1 we discussed the basic concepts of air pollution. Part 2 we considered conversion of units, microgram per meter cube to ppm, ppb to ppm to microgram per meter cube, and also ppb to microgram per meter cube, and reverse vice versa. We have studied unit conversion of concentrations. Now, okay, done. We'll go ahead. So now today we are going to discuss about various pollutants in atmosphere. Amiya Kumar Nayak, my phone number I will share with you by the end of the class. My mobile number will be given to you. No issue. You will continue the class peacefully. Listen this class now. Now, in this class, in the previous class, we finished the first one. Air pollutants, types and their effects completed. Concentration unit conversions are completed. But in this individual air pollutants, we have studied air pollutants as groups. Primary, secondary, like that. But individual major air pollutants in nature, we are going to discuss. So yesterday we discussed about carbon monoxide. First one, yesterday we discussed carbon monoxide. Carbon monoxide is said to be what we call it as acute toxicant. Why it is acute toxicant? Because carbon monoxide reacts with hemoglobin in blood circulation, results formation of carboxyhemoglobin, which is an asphyxiant. Asphyxiant means, what is asphyxiant? Any one of you tell me? Asphyxiant. This is a chemical which causes breathlessness. Asphyxiant is a chemical which causes breathlessness. So, it causes coma or breathlessness. And excess concentration of carbon monoxide will lead to heart attacks. Good evening, Gopi Satish Malla. Good evening, all of you. Now, second one. Whatever regarding carbon monoxide I have written, I am not explaining in detail. In the yesterday's class, it is completed. So I am going for the next. Today's class. Oxides of sulfur, SOX. Oxides of sulfur, SOX. We have two types of oxides. SO2, sulfur dioxide. SO3, sulfur trioxide. SO2 and SO3, sulfur dioxide and sulfur trioxide. These two are said to be most dangerous air pollutants, most harmful air pollutants. What is the origin of sulfur oxides? So 65% power stations, 65% of sulfur oxides from thermal power stations. Here, thermal power stations, 65% of sulfur oxides gained from thermal power stations. Then domestic cooking from coal, wood, kerosene oil, that releases 6%. Oil refineries, iron and steel manufacturing industries, 12%. Other industries, 10%. Vehicular transport and others, 3 to 4%. So, major 65% from power stations, thermal power plants, major source of sulfur dioxide and sulfur trioxide. Hi Venkatesh. Clear? Major source of oxides of sulfur. Very important thing. Oxides of sulfur are said to be most abundant air pollutants in nature. Oxides of sulfur are considered to be most abundant air pollutants in nature. And these oxides of sulfur from an industry, from an industrial chimney, it was estimated using West and Geek method. Oxides of sulfur from an industry, from an industrial chimney, it is going to release. It was estimated using West and Geek method. What are the effects or damages caused by oxides of sulfur? We have to discuss about effects caused, damages caused by oxides of sulfur. The first effects, damages building materials. The building materials, especially marble structures. Oxides of sulfur especially affects building materials, especially we call it as marble structures. In simple we say it causes a deterioration of structures. Sulfides, oxides of sulfur, sulfur dioxide, sulfur trioxide causes a deterioration of building material, and these are respiratory irritants. Respiratory irritants. They cause irritation on mucous membrane. Mucous membrane is a respiratory lining, respiratory membrane. So it causes irritation on respiratory membrane, mucous membrane. And also it causes respiratory disorders. In humans and animals, they cause respiratory disorders, bronchitis and asthma. Oxides of sulfur excess concentration in the atmosphere. If we inhale, that irritates respiratory membrane or mucous membrane. And also they are responsible to impart bronchitis and asthma. Besides this, it is responsible for formation of smog, ozone and acid rains. These are responsible for formation of smog, ozone and acid rain. This is a primary source of acid rain. Primary source of acid rain. So yesterday we discussed three types of acid rains. Yes, Taj Mahal, Teja Kandula. Taj Mahal is the deterioration marble structure which is affected due to oxides of sulfur, sulfur dioxide and sulfur trioxide. Very good example. The structures undergone deterioration because of SO2, SO3. Taj Mahal is best example. And yesterday we discussed three types of acid rains. H2NO3, H2CO3 and H2SO4. For example, what is the primary form of acid rain in atmosphere? You need to select only one option. Then you can select H2SO4. H2SO4, oxides of sulfur in atmosphere combines with water, generates H2SO4, sulfuric acid rain. The most predominant acid rain in atmosphere. The most predominant acid rain in atmosphere is sulfuric acid rain. So for what pH we call the rain is acidic in nature? pH of acidic rain. pH is less than 5.5. the pH of a rain is less than 5.5, we consider it as a acid rain. And in that, the most predominant is sulfuric acid rain, H2SO4. So Manoj, H2CO3, HNO3 are not most regularly formed. H2SO4 is most regularly formed. That is a primary source of acid rain, sulfur oxides. And it is the primary constituent of VOG formation. It is VOG, let's say, volcanic eruption. Volcanic eruption consisting of sulfur dioxide and other impurities. Volcanic eruption consisting of sulfur dioxide and other impurity combined with oxygen in atmosphere, moisture, water vapor in the atmosphere, in presence of sunlight, in presence of solar radiation, sunlight, that volcanic smog generated, that is called VOG. Generally, it forms smog, but as the origin of impurities is from volcanic eruption, clear, generally we call it as a smog, but the origin is from volcanic eruption. Now that a smog originated from volcanic eruption, we call it as volcanic smog, VOG. So these are the effects caused due to oxides of sulfur, sulfur dioxide and sulfur trioxide. What is its permissible limit? Permissible limit in the external atmosphere up to 80 microgram per meter cube. The permissible limit of oxides of sulfur in external atmosphere is 80 microgram per meter cube. Is it clear? Then we'll go for a numerical question related to sulfur dioxide. So you feel that till now we have not discussed any formula, any numerical issues related to sulfur, sulfur dioxide or anything. How can we solve a numerical question? But this question does not have a single formula. We can't be expressed in the form of formula. Step by step, you can analyze the question. Easily you solve the question. Only your presence of mind, your analytical skills, if you are capable of thinking logically, that is enough to solve this model of question. But after seeing this question in examination, you feel that our faculty not taught this question. How can we solve related to air pollution, sulfur dioxide? No numerical question is taught by faculty. So you not even ready to read the entire question. But if you start reading question, analyzing step by step process, easily you can solve this question. Okay. Now, a coal containing 2% of sulfur is burned completely to ash in a brick kiln at a rate of 30 kg per minute. So coal per every minute 30 kg is burnt in a kiln. For 1 minute 30 kg of coal is burnt in a kiln and converted completely to ash. Clearly given. A coal of quantity 30 kg in 1 minute, completely burnt and converted to ash in a kiln. Then this coal consists of 2% of sulfur. This coal carry out of total weight 2% of sulfur. The sulfur content in the ash is found to be 6%. So this sulfur given into ash, So out of total sulfur, how much ash is containing? Out of total sulfur, 6% of sulfur converted into ash. Of total sulfur, 6% of sulfur is converted into ash. Clearly written, the sulfur content in the ash was found to be 6% of initial amount. What is initial amount? 2% of 30 kg. 2% of 30 kg is initial amount. Out of that, 6% is converted into ash. Now, the molecular weights of sulfur, hydrogen and oxygen, 32, 1 and 16 gram per mole respectively. The annual rate of sulfur dioxide emission from the kiln. From where sulfur dioxide is coming? Because out of total sulfur, 6% only present in ash. Remaining, what is remaining? 94%. Out of total 100% of sulfur, 6% is converted to ash. Remaining 94% is converted into sulfur dioxide. What the point? I will explain again step by step. First, coal. We know it. Coal is 30 kg per minute. In this, what is sulfur? 2%. 2% of what? 2% of total coal, 30 kg per minute. 2% of 30 kg per minute. We can write down 2%, 2 by 100 into, we are converting into fraction, into 30. Clear? 2 by 100 into 30. So, 0.6 kg per minute. This is the sulfur participating in the chemical reaction per minute. 0.6 kg per minute. Got it? The sulfur which is breakdown into ash and sulfur dioxide. Every minute, 0.6 kg of sulfur is breakdown into ashes and sulfur dioxide. Ash contains 6%. Clearly given. Ash contains 6% of initial amount. Initial amount is 0.6 kg. Remaining out of 100%, 6% is ashes. Remaining 94% is, what is remaining 94%? Remaining 94% is sulfur dioxide. Now, sulfur in sulfur dioxide, how much? 94% of total. 94% of total sulfur. 94 by 100 into 0.6. Is this your answer? 94 by 100 into 0.6. Is this your answer? 296.44 ton per year. The question is given to estimate in ton per year. Okay, very good. We have solved it. No issue. We'll discuss. So, is this your answer? No. Remember, what is required? Amount of sulfur dioxide. This is the amount of sulfur available in sulfur dioxide. So, S plus O2 gives SO2. Clear? Whatever 94 by 100 into 0.6 is only sulfur available in sulfur dioxide. We need sulfur dioxide quantity. So, we can consider sulfur. 32 grams of sulfur generates 62 grams because sulfur molecular weight is 32 gram per mole. Sulfur dioxide, sulfur is 32, Oxygen 16 into 2. Oxygen 16 into 2. So 64 total. 64 grams is sulfur dioxide. 1 mole of sulfur molecular weight 32. 1 mole of sulfur dioxide molecular weight 64. Now, what is the value of sulfur? 94 by 100 into 0.6. Then how much sulfur dioxide is there? This is simple cross multiplication. We can write down here. Sulfur dioxide is equal to 94 by 100 into 0.6 into 64 by 32. Clear? 94 by 100 into 0.6 into 0.6 into 64 by 32. In which units it is expressing? It is expressing in the unit kg per minute. In which unit we require? We require in ton per year. This is important. It is going to express in the unit kg per minute. We need in the unit ton per year. So multiply 10 power minus 3 to convert kg to ton into 24 hours into 60 minutes per 1 day. Clear? 1 hour consists of 60 minutes. 1 day consists of 24 hours. Per year. Year means 365 days. Year means 365 days. So now tell me what is the answer. Got it? A simple question, step by step you can analyze. Easily you can get. So mostly we finish the question at this point. We convert this to ton per year and we'll give it the answer. Option A. Remember, it is not the answer. That is only sulfur in sulfur dioxide. We require total sulfur dioxide available. 94 by 100 into 0.6 sulfur. Molecular weight of sulfur dioxide 64 divided by molecular weight of sulfur 32 into 10 power minus 3 kg to ton. Kg to ton conversion 10 power minus 3. 60 minutes in 1 hour. 24 hours in 1 day. Total per year 365 days. So we got the answer 592.88 ton per year. 592.88 ton per year. Manoj, got the difference? First you have given 296.44. 296.44 is the amount of sulfur. That is your option A. We need amount of, question is about amount of sulfur dioxide. Amount of sulfur dioxide is this one. Because the difference, molecular weight of sulfur and sulfur dioxide. Molecular weight of sulfur 32, sulfur dioxide 64, twice. So it is increased twice. So you got the answer 592.88 ton per year. Clear for everyone? Shall we go ahead? No response from anyone. Shall we go ahead? Is there any doubts in this question? Aswin Venkat, clear. Good. Manu Prakash. Rahul Dev. Is it clear? Okay. Takdir, no. What happened? No doubt. Okay, Takdir, no doubt. Clear. Okay. We'll go ahead. Now, the next major air pollutant we are going to discuss, oxides of nitrogen, NOx. Oxides of nitrogen we are going to discuss. NO, nitrous oxide. NO2, nitrogen dioxide. NO and NO2, nitrous oxide and nitrogen dioxide. So major air pollution caused due to nitrogen oxides, roads. Roads means roads are not doing anything. Vehicles on roads. Clear? Roads are not emitting NO, NO2. Vehicles moving on the roads emitting 65% of NO, NO2. Vehicles moving on minor roads. Vehicles moving with domestic gases. Commercial gases and commercial gas vehicles. So other impurity, other activities 1%. So mostly it is emitted from majorly vehicular emission. Major source of oxides of nitrogen, vehicular emission. Then industries are utilizing gas engines, other kind of engines. So industrial emissions. These are the sources of nitrous oxides. NO and NO2, these oxides of nitrogen, these are said to be second most. What is the first most? We have written already. Second most abundant air pollutant. First most is oxides of sulfur. First most is oxides of sulfur. This oxides of nitrogen will consider second most abundant air pollutant emitted from most of the vehicles and industrial emissions. These are going to be released out. Then estimation. This oxides of nitrogen estimated by Jacobs method. Chemical analysis method carried out inside the industry or indoor airborne pollution. That is carried out through Jacobs method. Then permissible limit. What value of this oxides of nitrogen permitted? Oxides of nitrogen permitted same up to 80 microgram per meter cube. Same like oxides of sulfur. Permitted up to 80 microgram per meter cube. Effects caused. If excess oxides of nitrogen are present, if excess oxides of nitrogen present in atmosphere, what are the effects caused by this excess oxides of nitrogen? First important effect. Effects alveoli of lungs. Alveoli is an organ participating in the respiration of human. That lung tissue present, that organ is present in the lung tissue. So, alveoli of lungs. So, alveoli is a organ available in the lungs, tissue available in the lungs that participate in the respiration of human being. So, it affects alveoli of lungs. Also, very important, damages plant life. Growth of plant is getting retarded. Damages plant life. Then major source. These oxides of nitrogen is a major source of various secondary air pollutants. Most of secondary air pollutants generated due to oxides of nitrogen. Major source of various secondary air pollutants. We have the names. PAN, peroxyacetyl nitrate, PBN, peroxybutyl nitrate, PPN, peroxypropyl nitrate. This oxides of nitrogen combined with VOC, volatile organic compounds. Oxides of nitrogen combined with VOC, volatile organic compounds generates. Yes, peroxybutyl nitrate, very good, update. So, oxides of nitrogen and volatile organic compounds in the atmosphere generates the secondary air pollutants PAN, PBN and PPN. This is first group. And also generates ozone. Ozone generation is done. Ozone is a secondary air pollutant that is also generated by this. And also NOx with atmospheric water vapor or moisture content results formation of HNO3 nitric acid, which is said to be, again we call it as acid rain. These are the different varieties of secondary air pollutants which are released due to chemical interaction of oxides of nitrogen with various elements in the atmosphere. So this is related to oxides of nitrogen. So it is released from vehicles and industries, second most abundant air pollutant, and estimated through Jacobs method, permissible limit 80 microgram per meter cube. With respect to humans, it causes damage to alveoli of lungs, damage plant life, and then secondary air pollutant PAN, PBN, PPM, ozone and acid rain is caused due to oxides of nitrogen. Clear? We'll go ahead. Again, there is a numerical question. So again, we have not discussed anything, but there is a numerical question to solve here. So that is the beauty of this air pollution. Without knowing formulas, if you have brain, you can solve the numerical questions related to air pollution. The simple logic reasoning, you can guess, you will solve easily. It's a very simple model. Assuming annual travel for each vehicle is to be 6,000 kilometers. That means one vehicle travels how many kilometers? 6,000. In how many days? Per 1 year. Clearly given annual travel. Assuming annual travel for each vehicle to be 6,000 kilometers per 1 year, what is the quantity of NOx produced from 5,000 vehicles with emission rate of 3 gram per kilometer per vehicle? If one vehicle travels in 1 year, how many kilometers? 6,000 kilometers. If the number of vehicles are 5,000, and one vehicle is going to emit NOx of 3 gram per kilometer per vehicle. So one vehicle travel 1 kilometer, emits 3 grams. 5,000 vehicles travel 6,000 kilometers. What is NOx? Got it? Very, very simple. Total NOx emission. Total NOx emission is equal to, per one vehicle how much? 3 grams per 1 kilometer. How many vehicles? 5,000 vehicles. Each vehicle how many kilometer? 6,000 kilometer. Clear? One vehicle is traveling 1 kilometer, releases 3 grams. 5,000 vehicles traveling 6,000 kilometer in 1 year. What is annual emission of nitrogen oxide? So this is, we need to express in tons. So converting gram to tons, 10 power minus 6. Convert gram to ton, 10 power minus 6. Answer is 90 tons. Very good, Manos. 90 into 10 power 7 is 9 into 10 power 7 is grams, Aswin. 9 into 10 power 7 is grams. We are expressing in tons. So into 10 power minus 6 to convert a gram to ton, 90 tons. Do you need any formula for this? Do you need any explanation? Big question model? Nothing. Simple model. One vehicle, 1 kilometer, this much. 5,000 vehicles, 6,000 kilometer, how much? Simple, just multiplication. Given the answer, 90 tons. Then, particulate matter. SPM, we call it as SPM. Suspended particulate matter. Suspended particulate matter. SPM we call it as. Sometimes it was given TSP. Total suspended particles. Total suspended particles, both are same. Suspended particulate matter, SPM. Total suspended particle, TSP, both are same. Yes, Neha, that is a simple IES question and GATE question also. IES and GATE, both they have given that model of questions. Now, suspended particulate matter or total suspended particulate matter, both are same. They have been differentiated into liquids, solids, and aerosols. They have been classified into three categories: liquids, solids, and aerosols. When we take liquid, mist, fumes, fog, dew, volcanic ashes, all these comes under liquids. Solids, we may give dust particles, ashes, including we can provide pollens also, solid particulate matter. All these comes under solid particle. What are aerosols? These are suspended particulate matter of less than 1 micron diameter. Naturally formed, not human involved here. They may be either liquid or solid particles generated in atmosphere without human involvement. Liquid or solid particles which are generated in atmosphere, particles of less than 1 micron diameter. Those are said to be aerosols. So particulate matter based on state of matter, liquids, solids, both state, liquid or solid state, aerosols, particles of less than 1 micron formed naturally in the atmosphere. Then same particulate matter, we call it as PM, particulate matter, based on their diameter. PM10, particles of diameter 10 microns or greater than 10 microns, PM10 particles. PM 2.5, particles of diameter 2.5 microns or greater than 2.5 microns. PM1, particles of diameter 1 micron or less, invisible fine particles. So depending upon the diameter, particulate matter in air, in atmosphere, we can differentiate. Mist is a form of smog created in the atmosphere combined with moisture content. some impurities combined with moisture content, whatever generated a mass in the atmosphere, that is called mist. Mist. Mist is atmospheric moisture combined with air pollutants generated a mass. That mass we call it as a mist. Then 10 micron, PM10, 10 micron, they may be removed through, they may be visible to human also, but removed through hair near to the nose, hair at the nose. So they are not going to be entered into human respiratory tract. Clear? The particulate matter of diameter greater than 10 microns obstructed by hair in the nose. So they are not allowed to enter into, no issue regarding this particle. And the limit, these are permitted, permitted up to 60 microgram per meter cube. Permitted up to 60 microgram per meter cube. Then for 2.5 micron, they passes through mucous membrane, enter into lungs and other body parts. Then passes through respiratory tract, mucous membrane, lungs and other body parts due to their smaller diameter. And it is accepted up to 20 microgram per meter cube. PM 2.5, particles of diameter 2.5 microns are lesser, that is going to be accepted up to 20 microgram per meter cube. 1 micron, these are not allowed to enter into human body because they passes through lymphocytes and cause major damage to human. Passes through lymphocytes and cause major damage to human. What are effects caused due to any kind of particulate matter? We'll discuss here. Effects caused due to whatever type, the effects caused due to any kind. Respiratory disorders, they act as irritants. Respiratory irritants. They create irritation of mucous membrane and other body organs. And also they lead to bronchitis and asthma. They cause bronchitis and asthma. Lungs and kidney disorders. Lungs and kidney disorders also caused by particulate matter. And the particulate matter PM1, 1 micron or less, too much dangerous. They may cause death also. Most dangerous particle, particulate matter 1, particulate matter less than or equal to 1 micron, clearly written, not allowed into atmosphere. Is it clear? WBC. Lymphocytes are the blood cells in the human body. They pass through blood cells, lymphocytes, WBC, whatever it may be. They pass through it and cause damage. So this is the diagram related to estimation of particulate matter, suspended particulate matter. The diagram, this is related to estimation of suspended particulate matter. So this suspended particulate matter is estimated using the instrument, this equipment. This equipment we call it as a high volume sampler. High volume sampler. Clear? That equipment we call it as high volume sampler. For any size, irrespective of size. The first one. Total suspended particulate matter of any size, first instrument, of only PM10, estimation of weight of PM10 particles. That is done by second one. Clear? This second high volume sampler to estimate PM10 particle, irrespective of size, any kind of particulate matter estimated by the first instrument. So here air is passed through this chamber, and this is a filter provided. This is the air filter which entrap impurities passed through the air. All the impure particles are stopped, clogged on the filter. Clear? Air inlet of air is given here. So air is passing through it. While it is entering into the chamber, filter is provided. Clearly mentioned, filter is provided. Then that filter stops. Clear? Filter obstruct means stop. Obstruct the passage of particles through the air. So only air is traveling through it. Most of the particulate matter is entrapped on the filter paper. Then the air passes in the direction. Flow sensor passes through flow sensor. Then from here, this is rotating. This wheel is rotating, allowing the air to exit out. This is the exhaust. Air completely passes through the sampler and filter system. Is it clear? Whatever orange color we have given here, this is the particles, clearly given. Particles which are obstructed, not allowed to pass through the filter paper. Particles which are not allowed to pass through the filter paper. The same thing, air is entered here, passed through these different chambers, entered into this chamber. The filter paper having a diameter 10 microns, pore diameter 10 micron. So all particles greater than 10 microns have been obstructed. Particles greater than 10 microns have been obstructed here, and air with particle less than 10 microns flowing through it. The speciality is filter paper pore diameter. Here filter paper pore diameter is exactly 10 micron, so that pores will not allow particles more than or equal to 10 micron. All particles more than or equal to 10 micron are obstructed here. Then remaining particle of air with particle less than 10 micron. Less than 10 micron and air passes through it, passes through flow sensor and goes like this towards exhaust. So procedure is the same. Filter paper diameter is varying. Here 10 microns. Here will give 1 micron diameter, pore diameter. So that is the only difference. Is it clear? The diameter of pore in the filter paper is varying. Here pore diameter is 1 micron. Here pore diameter is 10 microns. So I will explain here. So first, see this moving air is going out. So I will show you again. This is rotating. See this ball. Air is coming, rotating, exit out. And the particles are entrapped here. See, this is the particle. Particle is stopped here. Again, I am repeating. Show here air. Passing, flow sensor going out. Particles are coming now. See, particle. If any particle is coming, stopped. Particle is stopped here. Air is moving. See here, particle is stopped here. Air is moving. So see, air is moving now. Air, pass, flow through it. When it is particle, see here, when particle is stopped here. So that is the activity of this high volume sampler. Is it clear now? Whatever light blue color ball, that light blue color ball is moving. And whatever orange color or yellow color, that yellow color is going to be obstructed, that is said to be particle. So initial weight of filter paper will take. Initial weight means before placing into high volume sampler, that initial weight will take it as a W1. Final weight after completion of experiment, weight of filter paper with impurity, that is noted as W2. Very important point, this remember. Initial weight of filter paper W1, final weight after filtration is done, impurities are entrapped here, whatever entrapped, that is the final weight W2. Then we have the volume of air passed through it, V. So volume of air passed through it is obtained, V. What is the total suspended particle? We can take simple. W2 minus W1 by V. Weights must be taken in microgram, volume must be taken in meter cube. Got the point? Total suspended particulate matter. W2 is filter paper with impurity minus W1 only filter paper weight. So W2 minus W1 will give impurity weight by volume of air passed through it, concentration of TSP in microgram per meter cube. Then if you solve this question, that is easy for you to understand. So I have given one question here related to it. Total suspended particulate matter concentration, TSP concentration, in ambient air is to be measured using a high volume sampler. The filter used for this purpose had an initial dry weight of, what is this? W1, 9.787. We'll write down. W1, 9.787 grams. The filter was mounted in the sampler and initial air flow rate through the filter was set 1.5 meter cube per minute. Discharge is given 1.5 meter cube per minute. Sampling continued for 24 hours. The air flow rate after 24 hours was measured to be, air flow rate after 24 hours was measured to be 1.4 meter cube per minute after 24 hours. So take this one is Q1, this one is Q2. We can write down the first, on the first hour, whatever discharge air passed through it, 1.5 meter cube per minute. Last hour, after 24 hours, last hour, air flow rate 1.4 meter cube per minute. Discharge in the first hour and discharge in the last hour provided. Yes, very long question, but this is very simple. The dry weight of filter paper after 24 hours is 10.283 grams. Assuming linear decline in the air flow rate during sampling, what is the 24-hour average TSP concentration in ambient air? So, W2, what is W2? 10.283. 10.283 grams. W2, W1 is easy. They have provided simply directly. But volume is not given. Time is provided 24 hours. Discharge values are provided. But discharge, we have two values. Simply we'll take volume is equal to discharge into time. Discharge, we are taking average discharge. Q1 plus Q2 by 2. Average discharge into time T. So general formula for volume is equal to, every time we remember this one, volume is equal to discharge into time, V is equal to Q into T. But as we have two values, initial and final, so throughout 24 hours, how much happening? We'll take throughout 24 hours average discharge. average discharge is, we are going to have Q1 plus Q2 by 2 into T. Q1 1.5, Q2 1.4 by 2 into this T, 24 hours into 60. 24 hours. This is in minutes, na? Meter cube per minute. That is in minutes. So we are multiplying with the 60 to convert hour to minute. Now, TSP. What is TSP now? W2 10.283 minus W1 9.787. But in which units it is given? Grams. We require in micrograms into 10 power 6. Clear? 10.283 minus 9.787 into 10 power 6 divided by average of discharge 1.45 into 24 into 60 meter cube. This is 1.5 into 20, 1.45 into 25 in 24 into 60. So what is the answer now? 237 microgram per meter cube. 237 microgram per meter cube. So again, I am repeating regarding volume. Volume, we have the formula, volume is equal to discharge into time. But here there are two discharges, initial discharge, final discharge. So throughout 24 hours, air is pumped into it. So we have to take linear decline of 24-hour average. So Q1 plus Q2 by 2 initial plus final by 2 average into time 24 hours. Minutes to hour conversion into 60. So this is volume obtained in meter cube. Weights are given in grams, so multiplied with 10 power 6 to convert it into microgram. So we have the answer 237 microgram per meter cube. Got it? Clear for everyone? Is it clear for everyone? Shall we move ahead? Yes. Ashwin 237, Narendra 237, Manoj 237. Good, very good. Everyone is getting the answers. Then we'll continue tomorrow. Tomorrow we'll discuss about the smog and also some questions we are going to solve. And then finally tomorrow we have meteorological factors also. We'll discuss everything tomorrow. And so finally, so one student asked my mobile number. This is my mobile number 9704571767. This is my WhatsApp number. If you want to join in Telegram, my Telegram is Engineering Guru, ENGGGURU, Engineering Guru. So tomorrow we have again the class, same time, same YouTube live, air pollution part 4, not part 3. 3 parts over, part 4. And regarding Unacademy, so people are worrying about Unacademy, how we can choose the faculty, how we can believe Unacademy is a new platform. Remember, regarding civil engineering, Unacademy is civil engineering. Myself, I am going to teach 5 subjects: environmental engineering, hydrology, irrigation, construction metals and management, open channel flow. And a very important thing you need to remember here, this is a live interactive session. So many coaching centers are selling online classes, but actually that is not online, that is a recording class. Clear? Nowhere they will express, they are not going to clear your doubts. But here in Unacademy, if you put a message just in the comment box, you give the message, immediately the faculty clarify the doubt in the class itself. So ours is a live interactive. Actually, this is online. So every class, every coaching center putting online classes and they are selling out recording classes where the students' doubts are not clarified. And some coaching centers, they itself don't have clarity. Up to lockdown extension, they will give live classes. After that, they will ask you to come to classroom coaching again. This is a confusion. You have to adjust to new. So, irrespective of this, throughout your coaching period, Unacademy is giving you live interactive online class on the spot instantly. Your doubt is going to clarify. And coming to civil engineering, myself, I have 10 years of GATE teaching experience. I taught in all big coaching centers in India. I will teach you 5 subjects related to civil engineering. We take environmental, weightage minimum 10 marks, hydrology weightage minimum 6 marks, irrigation weightage, okay, you will take 1 mark only. Open channel flow, you have a weightage of 3 marks. Construction materials and management, you have a weightage of 3 marks. So, 23 marks weightage I am going to teach. And one of the faculty from big coaching center, Rajendra Prasad, he also in Unacademy is going to teach 4 subjects in Unacademy. He will teach transportation, which is 10 marks, structural analysis, RCC, steel. All 3 combined you have 12 marks. That means he will give you 22 marks. So additionally, top maths faculty already available in Unacademy, top aptitude faculty already available in Unacademy, which is 26 to 27 marks. As a whole, how much? 45 and 25 will take 60 marks already over. And in short time, we are bringing one more faculty, big faculty for geotech, which covers around 13 marks. Total 17 marks over. Combined subjects, FM, SOM, EM remain. So easily will get from mechanical engineering, topmost faculty are the combined subjects, they are going to teach it. So you follow me and my group panel of faculty, 100% we guarantee you, surely you crack GATE examination. No need to confuse whom to follow, whom to not follow. Just take subscription with my code. I will tell you how to crack GATE examination. KP Civil Engineering Group. Any of the code you can use. You will get 10% discount. All this faculty are with you till you crack GATE exam. You admit into PSUs. You take job in PSUs, admit into MTech, NIT or IIT. Till that time faculty are with you. They respond immediately. There are people who taken coaching in big coaching centers, where most of the faculty never reply to your text message through WhatsApp or a mail. So you inquire about KP sir, how I supported n number of students, how I given reply immediately to all WhatsApp messages, immediately I explain the questions to the students. The same thing done by my fellow faculty friends also. So they will support you if you subscribe to Unacademy, KP Civil or Engineering Guru code. And also I provide you personally free online test series with my website. And my panel of faculty will be with you till you become a ranker. I provide scanned copies of excellent top rankers notes and also other materials. Your doubts will be cleared in the WhatsApp group. After GATE also we provide post-GATE guidance. If any information required, you subscribe to our Engineering Guru Telegram channel or feel free to contact me through my WhatsApp number 9704571767. Clear? Don't worry about your future. You come join with Unacademy plus course. We are ready to support you. Within 4 months, your syllabus is going to be completed. Already we have started double E course. Again, repeated double E course also for new students, no issue. Like that, within 4 months, every day, you spend 6 hours. 2 hours double E, 2 hours TE, 2 hours GT. In 1.5 months, you will get 45 marks subjects easily. So come and join Unacademy plus course. Our panel of faculty will guide you. Don't deviate. Don't go for blindly online. Online means remember live interactive only. It is not recorded lessons. Don't go for recorded lessons. And also live classes up to lockdown. Classroom program after lockdown. This is unnecessary. You adjust it to only one platform. You follow one faculty, one group of faculty, surely you crack GATE exam. Faculty will only make you to success. coaching centers not make you success. So come to Unacademy, join live classes. You will crack GATE and ESC. So tomorrow we'll meet you at the same time, 8:30 p.m. YouTube live air pollution part 4. I will make the most difficult and most important air pollution very easy for you. Those who have not gone through part 1 and part 2, recorded videos are there. Spread the information to your friends, give the information. And also one more thing, I am taking free live classes Unacademy app also. Nearly 20 lectures of mine are on the Unacademy platform. Freely you can observe all important topics like hydrograph, BOD, how to prepare for GATE, how to prepare for IS. 20 hours free lectures are there. Go and type KP Civil, my profile will come. Free, no need to pay anything. Go and type KP Civil in Unacademy app. You will get my profile. Go through it and view free 20 hours classes, important, all important topics only. I have given from irrigation duty database period, from hydrology, hydrographs, from environmental engineering, BOD and other topics, quality analysis, numericals and other topics, very important topics. Free lectures are there. If you are not interested for plus subscription, go for free lectures, watch it, gain the knowledge, enjoy the subject. Okay, we'll meet again tomorrow. Good night for today. Hello students, good evening all. Welcome to Unacademy, the largest learning online platform which provides various number of free live lectures, especially live interactive sessions are provided for free. Special classes on Unacademy platform as well as YouTube live learning platform. The best top faculty in India. The top faculty in India teaching on Unacademy live classes. So today evening I am with you, Mr. Krishna Prakash. People used to call me, the students you love to call me KP sir. I have 10 years of GATE and ESC teaching experience. I taught to more than 150 plus batches and also helped so many thousands of students to get top ranks in GATE, ESC and other competitive examinations. And also I will teach APPSC, TSPSC, state government examination, SSC competitive exams also. So the ex-faculty of ACE Engineering Academy, GATE Forum. I will promise you, after learning my class, after learning subject from my class, if you directly go to the exam, surely you can answer all the questions related to the subject. 100% you solved all numericals and theoretical questions related to my subject. Then, good evening Ramya, good evening Manos. Now, we are discussing, we have completed 3 sessions of air pollution. Today the topic we are going to consider air pollution part 4. This air pollution is under GATE ESC civil engineering subject, GATE ESC civil engineering subject, and also it is in IES engineering service examination. We call it as ESC. In ESC general studies, we have the subject energy and environment. This is the subject. In this energy environment also you have the topic of air pollution. And also in your APPSC, TSPSC, SSC, RRB general studies subjects also you have the topic air pollution, science and technology or general science of the topic air pollution. So this live lecture will help you for all competitive exams where air pollution topic is there. Now we move on. Hi Narendra. Now yesterday, day before yesterday, total 3 days we have finished. Air pollution, introduction, causes and types, air pollutants and their effects. Only we have remaining some smog, ozone and lead. 3 air pollutants. Today we will finish off. Already this one numerical questions also, concentration, units and conversions already completed. Today, after completion of remaining 3 air pollutants, we are going to focus on the most important topic in air pollution. You never come across in your college life where your faculty is not going to teach you regarding this very important topic. Meteorological factors affecting air pollution. Good evening, Abhijit Sarkar. So before going to that, the first one, smog. We have remaining few air pollutants to discuss. First one, smog. Smog is a combination of smoke plus fog. Smog is a combination of smoke plus fog. From air pollution, from industries, from vehicles, from other pollutants, smoke is generated. From the atmosphere, fog is entered. Then that smoke plus fog combined together resulted smog, which is a secondary air pollutant. Because this is not directly released from source. From source, smoke is generated. From atmosphere, fog is present. Both combinedly resulting a dangerous component called smog. Smog is an urban air pollutant. Smog is an urban air pollutant. And it is caused due to combustion of fossil fuels. Mostly smog is entered due to combustion of fossil fuels. Fossil fuels means coal, wood, kerosene oil, crude oil resources. From such kind of fossil fuels, smog is getting generated. This smog we can differentiate into three types. Smog we can classify into three types. First type of smog, classical smog, London smog, or we may call it as killer smog. Classical smog, London smog, killer smog. The great smog of London, first physically identified smog in the world. This is classical smog, London smog, killer smog. Second one we call it as Los Angeles smog. Third one, Delhi smog. Based on the location where it is created, the names have been provided to it. Classical smog, London smog, killer smog. Los Angeles smog, which is also called Los Angeles smog, is also called as photochemical smog. And Delhi smog. So we have classified into three types: classical, photochemical, and Delhi smog. Now, first one we are going to discuss is about the first smog condition we are going to consider is about London smog. This London smog is generated and caused problem in the year 1952. The huge damage is caused. It causes death of over 4,000 population. This London smog caused in the year 1952 and results death of over 4,000 population. So what we call it as a great smog of London, classical smog, killer smog, sulfurous smog. Sulfurous smog. These are all alternate words of London smog. Hi Jagannath Reddy, Tadbir. What is going on when London smog is created? What is happening when London smog is created? Fossil fuels have been burnt. Clear, fossil fuels have been burnt. And from this burnt fossil fuels, oxides of sulfur, especially sulfur dioxide, we'll call sulfur dioxide or oxides of sulfur, released in very high concentration. Burning of fossil fuels in any manner generated, released sulfur dioxide into atmosphere, and this sulfur dioxide combines with fog. When it, at what time it causes? This sulfur dioxide combines with fog during early morning hours. During early morning hours, this sulfur dioxide combines with fog, resulted the great smog of London, which causes a death of over 4,000 population. This is caused due to the result of temperature inversion happened in the morning hours. Temperature inversion. Okay, no comments. Now, temperature inversion happened. Because of this temperature inversion, 5 days continuously worst smog situation is created. 5 days in the London city, brown color haze is created. Worst smog is created. So, 5 days worst smog is created continuously due to temperature inversion. What it causes? Effect. What is the effect caused due to this London smog? Effects. Lungs and heart diseases. Lung and heart diseases are caused due to this London smog that lead to death of humans. Lung and heart diseases important that lead to death of humans. Then what we call Los Angeles smog, photochemical smog, the most common word. It was first identified in the city Los Angeles. So it is called photochemical smog. So it is called Los Angeles smog, first identified in Los Angeles. Then origin of pollutants. Pollutants emitted from automobiles. Pollutants generated from automobiles. In the Los Angeles, automobile pollution resulted oxides of nitrogen combined with hydrocarbon vapors. Oxides of nitrogen that have been combined with hydrocarbon vapor created the smoke. And this smoke, hydrocarbon vapor and oxides of nitrogen smoke in presence of sunlight, not during early morning hours. When it is happened? Noon hours. Sunlight is very high during noon hours. So this oxides of nitrogen and hydrocarbon vapors generated the smoke. The smoke interacted with the sunlight in noon hours, resulted ozone, nitrogen oxide, nitrogen dioxide, with the release of huge amount of brownish colored smog. Brownish colored smog entered into atmosphere. So it generates secondary air pollutant ozone, nitrogen dioxide, and also brownish colored smog into the atmosphere. What are the effects? What it causes? effects caused due to photochemical smog. Photochemical smog created a reduction in the visibility. If on the roads visibility is reduced, what happened? You have gone to the road daytime, afternoon time, sunlight is there, but reduction in the visibility. That leads to fatal accidents are going to take place. So reduces visibility, cause damage to plant life, plant damage, eye irritation, allergy to the eyes, eye irritation is created, and also respiratory irritation, respiratory disorders caused due to this photochemical smog. Respiratory irritation. Yes, accidents. Manoj answered very good. Temperature inversion, Teja. Yes, we'll discuss in Delhi smog also. Tabdir. Teja, temperature inversion we'll discuss in meteorological factors. I will clearly explain what is inversion, what is temperature inversion, and all those things in the meteorological factors, Teja. So this photochemical smog reduces visibility, cause damage to plant life, eye irritation, and respiratory disorders. Then this is the diagram representing photochemical smog formation. Nitric oxide, nitrogen dioxide, hydrocarbons from the vehicles, oil tanks, paints, and gas stations, hydrocarbons are released. They enter into atmosphere, all types of nitrogen oxides, NOx. Then atmospheric oxygen also combined. UV light, sunlight, solar radiation, sunlight combined together. Clearly written, generated photochemical reaction, photochemical smog. What are constituents of the oxidants? Photochemical smog plus oxidants. Oxidant constituents are ozone, peroxyacetyl nitrate, aldehyde, and acrolein. These are the secondary air pollutants generated. Ozone, peroxyacetyl nitrate, aldehyde, and acrolein. Oxidants are consisting of these components. Nitrogen oxides from atmosphere, volatile organic compounds, secondary air pollutant peroxyacetyl nitrate generated in presence of sunlight, solar radiation, sunlight generated photochemical smog. Along with this, ozone is also generated. Clear? Same another model of diagram for your easy understanding. These are primary pollutants. NO, NO2, volatile organic chemicals, VOC, volatile organic chemicals. From these oceanic ships, from motor vehicles, from plants, from industries, from all other residential buildings. These are the components, primary pollutants. Primary pollutants act, sunlight act upon primary pollutants, resulted secondary pollutant ozone and PAN. Then we'll consider it as a smog. Photochemical, near us, very important question. The chemical reaction happened in presence of sunlight. I'll write down here. Chemical reaction in presence of light. Chemical reaction in presence of light, and that light now here is a natural light, solar radiation. That is called photochemical reaction. Got it? Near us? The differences between industrial smog and photochemical smog. Industrial smog means nothing but our London smog. London smog. Photochemical smog is a Los Angeles type of smog. It is grayish in color. This is brownish color. London smog, industrial smog, is a sulfurous smog because it contains sulfur oxides, and this consists of oxides of nitrogen will play very important role. Industrial smog, London smog consists of, it is formed from oxides of sulfur. Photochemical smog is generated from oxides of nitrogen. Sulfur oxides and particulate matter in the air combined to form industrial smog. Directly automobile use nitrogen oxides and organic compounds like hydrocarbons combined to form photochemical smog. This is the diagram representative. This is a gray colored, dark grayish color is generated in London smog. Brownish color is generated in the Los Angeles smog. Very important thing, brownish color smog generated in the noon hours. This grayish smog generated, and smog is creating problem in the early morning hours. That is the difference between London smog and Los Angeles. It is generated due to oxides of sulfur. It is generated due to oxides of nitrogen. Now, we are going to discuss about the third type, our Delhi smog. This Delhi smog is generated, caused due to PM 2.5 microns particulate matter of 2.5 microns, ozone, and the fog generated during early morning hours. Recently in Delhi, smog condition created and causes a loss of lives of population because burning of agricultural waste in Chandigarh, the smoke carried away and entered into Delhi. Then that smoke generated due to burning of agricultural waste consisting of particulate matter combined with the fog in the early morning hours created the situation, Delhi smog condition. So, Delhi smog is caused due to transportation vehicles. Transport means vehicular transport. Agricultural sector, burning of agricultural waste, agricultural activities, and also power plant generated particulate matter, smoke or particulate matter. These are responsible for causing Delhi smog condition. Got it? So what is the effects caused due to Delhi smog condition? Again, we can write down severe respiratory disorders. Severe respiratory disorders are caused. Severe respiratory disorders, first one. Then second one, eye irritation, allergy, eye irritation. Reduced visibility. Very important thing, it changes climatic condition also. Change in rainfall pattern in the Delhi city. Change in rainfall pattern, total climate change is caused due to this condition. Climate, adverse climatic conditions have been created due to this smog condition. These are the effects caused due to Delhi smog. Next air pollutant we are going to consider is ozone. Ozone we are considering the dangerous ozone, harmful air pollutant. Ozone we consider as a air pollutant and it is said to be dangerous when it is said to be surface or tropospheric ozone. Ozone available in the troposphere. As poor visibility means reduced visibility. Worst smog is Delhi smog only, Deepak. Very good, correct. Worst smog is Delhi smog only. So reduced visibility is poor visibility, no issue. Then coming for ozone, volatile organic compounds in presence of NOx, nitrogen oxides. Volatile organic compounds in presence of NOx combined together, chemical reaction takes place in sunlight, solar radiation. Ozone is generated. That results generation of ozone. So when we consider effects caused due to ozone, the effects caused due to ozone, excess ozone, what happened? Excess ozone initially reacts with metal ions. That reaction with the metal ions, it causes corrosion of metals, and it acts like a greenhouse gases, GHG. Ozone act like a greenhouse gas, increased earth surface temperature, global warming is going to be caused. This ozone is toxic to plants as well as animals, for both. Ozone is said to be toxic to plants as well as animals. Again, respiratory disorders, asthma, bronchitis. Asthma and bronchitis is going to be caused due to ozone. And also causes tire burning, cracks in tires. The automobile tires have undergone crack formation due to presence of ozone. The most dangerous tropospheric ozone is generated in presence of sunlight, volatile organic compound and nitrogen oxides. These are the effects caused due to it. When we take ozone under two circumstances, stratosphere ozone, troposphere ozone. The tropospheric ozone is dangerous ground level ozone caused due to thermal power plants, vehicular pollution, buildings, domestic pollution, industrial pollution, that causes pollution plus heat and sunlight. That results formation of ozone in the troposphere. Shall we cause stratospheric ozone as harmful? No. Stratospheric ozone is not harmful. This is good ozone. Stratospheric ozone is good ozone. Tropospheric ozone, we call it as bad ozone, harmful ozone. How ground level ozone forms? From the sunlight, ultraviolet light radiation from emissions from fuels, vapors and other activities, volatile organic compounds and NOx, and from industrial buildings. Industrial buildings, again volatile organic compounds and NOx. From plants and domestic buildings, volatile organic compounds. Three sources. Vehicular pollution, first one, volatile organic chemicals and NOx. Industrial emissions, second one, volatile organic chemical and NOx. And from residential buildings and plants, only volatile organic compounds. All mixed, interacted in presence of ultraviolet light radiation due to sun. Then ozone is coming down to ground level. This ends pollution concept. So that ends pollution concept, theoretical, whatever types of pollutants and their theoretical issues we have completed. A small question, two questions related to this theoretical questions. Sulfur dioxide and carbon monoxide adversely affected. What are the effects of sulfur dioxide and carbon monoxide? Sulfur dioxide will have n number of effects. We are discussing about it. Carbon monoxide, we know it. Carbon monoxide combines with hemoglobin of blood circulation, resulting carboxyhemoglobin. Then reduces oxygen carrying capacity of blood. Is it not? Carbon monoxide combines with hemoglobin, formed carboxyhemoglobin, which causes a reduction in oxygen carrying capacity of blood. So, affect oxygen carrying capacity of blood, but it is caused by second one, respectively. Respectively means the second one, it should be second one. So second one, where it is present, oxygen carrying capacity of blood, second one. And sulfur dioxide will cause reduction in functioning of respiratory system. So answer is option C. Sulfur dioxide will interrupt the functioning of respiratory system. Carbon monoxide will cause a reducing oxygen carrying capacity of blood circulation. So option C. Very good, Narendra, you have answered the question. Precursors of photochemical oxidants are, just now we have gone through it. Photochemical oxidation resulted smog. What are precursors? Precursors. This one, nitrogen oxide, volatile organic compounds, and sunlight. These are the precursors of photochemical oxidants. We have seen clearly. So nitrogen oxides, volatile organic compounds, sunlight. These are the precursors of photochemical reaction generating smog. So we go for it. Option A. Option A. Yes, Abhishek Singh, option A, very good. NOx, VOCs and sunlight. Match the following. Okay, we missed the quotes here. Okay, we'll go ahead. Match the following. Carbon monoxide. A is given carbon monoxide. What the carbon monoxide will do? Just now we discussed. Carbon monoxide causes acute toxicity. 2. A is 2. Carbon dioxide. Everyone knows carbon dioxide is going to cause greenhouse effect. So B is 4. Sulfur dioxide. Sulfur dioxide, acid rain. C is 1. Oxides of nitrogen. Just now, previous question also we discussed. Ozone liberation. D is 3. So 2, 4, 1, 3. What is the answer? Option C. 2, 4, 1, 3. Option C is the answer. Here, carbon monoxide acute toxicant, carbon dioxide greenhouse effect, sulfur dioxide acid rain, oxides of nitrogen ozone liberation. So now we are entering into very important meteorological factors affecting air pollution. So it is very important to write down what the meteorological factors will do. Meteorological factors are going to do affect. They are going to affect air pollution. Effect of meteorological factors on air pollution. So when we consider, there is a stack, opening or chimney of an industry. This is a stack or opening or chimney of an industry. From this chimney or stack or opening, we call it as a stack. Stack or opening or chimney. Pollutant mass, impurity mass. That the pollutant mass generated from the stack. We call this as, what is the name given to this pollutant mass from the chimney? Any one of you tell me this? Abhishek Singh, very good. You answered. Match the following question. Any one of you tell me what is the name given to pollutant mass released from the chimney? Any one of you tell me? Do you know it? So that the pollutant mass released from the chimney, plume mass, plum or plume mass we call it as. Yes, very good, Narendra. This is the mass. This mass going like this. This mass, whatever released from the chimney, this is said to be plume mass generated, circulated from the origin of the stack of the chimney. Plume mass. In which direction will this plume mass will travel? Any guess? Will it go exactly high above, vertically upward direction? Go straight away into atmosphere? Or will it spread horizontally, go away horizontally only? Not upward direction, not downward direction. Or will it fall down immediately near to the chimney? Exactly at the ground level? There are three kinds of fates for the pollutant mass released from the chimney. Either it may go high above the atmosphere, or it may travel horizontally throughout the atmosphere, or it may fall down. So out of this, which is going to be happen? Which is going to be happen? That is depending upon. What is going to be happen is depending upon meteorological factors. The factors controlling air pollution. So depending upon surrounding atmospheric airs, depending upon surrounding atmospheric air, temperature, pressure, humidity, wind velocity, depending upon these factors, the plume mass may go high above, horizontally they may travel, or they may sink down to groundward direction. That is depending upon it. Clear? Any direction. Very good, Narendra. Any direction. Both cases, Abhishek Singh. Spread, Teja. So these are the four factors controlling the behavior of plume. What we call it as that journey or fate of the plume. We call it as plume behavior. Plume behavior. And this plume behavior basically depends on two factors. Plume behavior basically depends on two factors. One is dispersion. Two phenomena, not factor actually. Two phenomena. One is dispersion. Second one is dilution. What is meant by dispersion and what is meant by dilution? Tell me. Any guess regarding dispersion and dilution? Dispersion is a spread. Dilution is a mix. Plume behavior controlled by two phenomena, dispersion and dilution. Dispersion is a spread and dilution is a mix. The pollutant mass released into atmosphere. So we'll take pollutant mass, impurity mass combined with fresh air in atmosphere. from the chimney, this mass of pollutants released from the chimney, this mass of pollutants released into atmosphere. This is mass of pollutant. Already atmosphere consists of fresh air, huge quantity. Now this is spread throughout this huge amount of fresh air. Then what happened to air pollution? Pollutant mass mixed with huge amount of fresh air. Then what happened? Dispersion and dilution is high. Dispersion and dilution is high. Then air pollution is getting reduced. Air pollution is said to be less. Pollutant mass released into huge area of fresh air. So spread of pollutants throughout the area mixing with fresh air will cause a reduction in air pollution. One spread, two mix. Abhishek, very good. Deepak, regarding this lecture, whatever I am teaching in YouTube, that will be available in a recorded session. So you go through after completion of the class. First listen and focus on the class, understand the subject. You have doubts, express it. And you want to write down, do one thing. Again, after completion of my lecture, then go to YouTube again. You can watch. You pass wherever you want. You can write it down, points individually. Otherwise, if I wait for each and every student, will take a long time. So I am going with the content, throughout the subject. I am going away. So if you want to write down the notes, dictating notes in the YouTube is not possible. You have an option. Whenever you want, how many times you want, freely you can view in the YouTube. You can go ahead, you pass the button, you write the notes. Is it clear, Deepak? Now, dispersion and dilution is high, air pollution is less. So, you remember, wherever we write down D and D, D and D is dispersion and dilution. And this is inversely proportional to air pollution. Dispersion and dilution is happened, air pollution is less. Dispersion and dilution is less and not happened, air pollution is more. That day we are going to discuss the factors individually. Whatever I have given the factor, temperature, pressure, humidity, velocity, we'll discuss individually. Wait for some time, I will explain it. So dispersion and dilution is more, air pollution is less. Dispersion and dilution is less, air pollution is more. And at the same time, dispersion and dilution is inversely proportional to stability of atmosphere. If atmosphere is more stable, dispersion and dilution is less. Atmosphere is less stable, then dispersion and dilution is more. Means stable atmosphere, meaning no temperature variation, no pressure variation, wind masses are not moving away. In such a case, dispersion and dilution is less, air pollution is high. Unstable atmosphere. What happened in the unstable atmosphere? What happened to an unstable atmosphere? Continuous fluctuations in temperature, pressure, wind velocity, humidity, so many variations are going to take place. Due to that, fresh air mass flow continuously, dispersion and dilution is high, So air pollution goes on decreasing. Air pollution goes on decreasing. So we need unstable atmosphere. This relation, if you understand very well, you can understand meteorological factor that much easily. Remember this relation. If we have unstable atmosphere, we have less air pollution. If we have stable atmosphere, we'll have more air pollution. Got it? Yes, correct, Neha. We need unstable atmosphere for less air pollution. Less air pollution, I can write down again for you. Less air pollution is happened when atmospheric changes are high. Unstable atmosphere is there. Atmospheric changes are high. Less air pollution is going to happen. Got it, Neha? Temperature. Now we are discussing effect of temperature on air pollution. Effect of temperature on air pollution we are discussing. And we'll consider here the very important word related to temperature. That very important word, what we call it as lapse rate. The very important word. You can understand, if you understand lapse rate, you can understand everything related to it. Rate of change of temperature with change in altitude. Rate of change of temperature with change in altitude. Altitude is vertical rise high above the ground level. So lapse rate, rate of change of temperature with when from ground level and goes on increasing, whatever change that is happening. Consider this is 0 kilometer, this is 1 kilometer. But the change in temperature from 0 to 1 kilometer, that rate of change of temperature with the altitude, that is called lapse rate. We can write down lapse rate is equal to dt by dz, change in temperature with change in altitude. Remember, T2 minus T1 by Z2 minus Z1, lapse rate LR. Lapse rate is equal to LR is equal to T2 minus T1 by Z2 minus Z1. Very important point. Temperature taken in degrees Celsius. Altitude must be taken in kilometer. In your exam, they provide this in meters, but you need to take in kilometer. Takdir, how it is possible? Regarding unstable atmosphere, less air pollution. Takdir, one simple example I will tell you. From the industry, pollutant mass is releasing. At the same time, suddenly high wind mass is flowing in the air. So that high wind mass will take out the pollutant mass. Na? So high wind mass is creating disturbance in air. Disturbance in air is nothing but unstable atmosphere. That disturbance created by continuously moving wind masses, creating unstable atmosphere. Taking out the pollutant mass far away, spread throughout the atmosphere, reducing impurity concentration. So that unstable atmosphere due to high wind mass reduce the concentration of pollutants. So less air pollution because of unstable atmosphere. then lapse rate is equal to T2 minus T1 by Z2 minus Z1. T2 minus T1 expressed in degrees Celsius, Z2 minus Z1 altitude expressed in kilometers. We will get a lapse rate. Lapse rate is classified into two types. Adiabatic lapse rate environmental lapse rate. Lapse rate is differentiated into two types. ALR, adiabatic lapse rate, ALR. Environmental lapse rate, ELR. So adiabatic lapse rate is said to be the standard lapse rate under any circumstances, fixed standard value dt by dz is said to be constant, fixed standard value with reference to under any circumstances, altitude to altitude, place to place, region to region, location to location, time to time, which is not going to vary. Clear? Adiabatic lapse rate. What is meant by adiabatic? Anyone tell me what is meant by adiabatic? Yes, ambient lapse rate. Correct, Abhishek? So, adiabatic is the condition. Adiabatic is the condition where gain or lose of temperature, increase or decrease of temperature. In simple, we'll explain. Increase and decrease of temperature happen without gain or loss of heat energy. Heat energy is not gained and heat energy is not lost from the body, but still temperature may fluctuate, may change, either increase or decrease is happening. How it is possible? Without gaining and losing heat energy, how temperature change will occur? Because of internal work done. Internal work done is going to cause increase or decrease in temperature. That condition is called adiabatic. So adiabatic lapse rate is a constant lapse rate. In simple, we'll take it as a reference value. Adiabatic lapse rate we'll take it as a reference value. Reference value to compare one to another. Environmental lapse rate. This is a prevailing lapse rate. Ambient lapse rate means time to time, place to place, altitude to altitude, practical or actual. When you measure a temperature at 0 degrees Celsius and a temperature at, when you measure temperature at 0 kilometer and a temperature at 1 kilometer. First you measure temperature at ground level, you gone to high above 1 kilometer and measure temperature. That difference, practical difference or actual difference, that practical or actual difference we call it as environmental lapse rate, prevailing lapse rate, ambient lapse rate, ELR. Got it? Adiabatic lapse rate and environmental lapse rate. So I will tell you adiabatic lapse rate. Again, this adiabatic lapse rate is differentiated. Average ALR, average adiabatic lapse rate throughout atmosphere from ground level to 120 kilometer, any altitude, any place throughout atmosphere under any circumstances. Got the point? Average value, average adiabatic lapse rate throughout the atmosphere minus 6.5 degrees Celsius per 1 kilometer. So it was identified and measured as a standard value from 0 to 120 kilometer high above under any circumstances. The average adiabatic lapse rate throughout the atmosphere is given dt by dz, average adiabatic lapse rate throughout the atmosphere minus 6.5 degrees Celsius per 1 kilometer. It means from 0 kilometer to 1 kilometer you have traveled. I will show the diagram. 0 kilometer, 1 kilometer. You traveled 0 to 1 kilometer. At 0 kilometer, you take temperature 40 degrees Celsius. After 1 kilometer travel, the temperature is given 40 minus 6.5. 33.5 degrees Celsius. This is average adiabatic lapse rate. Got it? The ground level, while you have started the journey, 40 degrees Celsius is the temperature. And you traveled 1 kilometer high above and measured temperature 33.5. What is difference? Decline of 6.5 degrees Celsius. A decline of temperature happened 0 to 1 kilometer. Decline of temperature happened 6.5 degrees Celsius. Then second one, very important one, what we call as a dry adiabatic lapse rate. Unsaturated dry air lapse rate in dry atmospheric air. Lapse rate in dry atmospheric air. Dry adiabatic lapse rate. Dry ALR. What is the value of dry ALR? You can write down dt by dz is equal to minus 9.8 degrees Celsius per kilometer. That means in the ground level, if it is 40, after 1 kilometer it is said to be 30. Clear? In the ground level it is said to be 40. Take at the ground level 40 degrees Celsius, 0 kilometer. After 1 kilometer it is 30 degrees. So rounded off, 9.8 rounded off. Decline minus, decline of 10 degrees Celsius per kilometer. Decline of 10 degrees Celsius per kilometer, that is said to be dry adiabatic lapse rate. Very important. All fluctuations in our country we are following through dry adiabatic lapse rate. For dry unsaturated atmospheric air with less or very negligible amount of moisture, nearly moisture content is equal to 0 condition. Next one, wet adiabatic lapse rate, wet ALR. Wet ALR, we call it as a saturated lapse rate. The total air mass occupied by moisture content, completely occupied moisture content. Saturated, the air mass is occupied, saturated with moisture. Wet air mass lapse rate in wet atmospheric air. Lapse rate in wet atmospheric air, we call it as wet adiabatic lapse rate. where we can take, what we can take? dt by dz is equal to minus 4 degrees Celsius per kilometer. 1 kilometer rise will reduce only 4 degrees Celsius of temperature. 1 kilometer rise will reduce only 4 degrees of temperature. So at ground level again we are going to take 40 degrees Celsius, 0 kilometer line. After 1 kilometer travel, temperature will become 36 degrees Celsius, so minus 4 degrees. After 1 kilometer journey, decline of temperature of 4 degrees happened. That is called wet adiabatic lapse rate. This too, average adiabatic lapse rate, just remember this minus 6.5 degrees Celsius. Wet adiabatic lapse rate, just remember minus 4 degrees Celsius. But you have to remember this very importantly, even though you forgot about the remaining two, but the dry adiabatic lapse rate is very important. The comparison with the dry adiabatic lapse rate only we are going to express the remaining all types of lapse rate in the practically occurring condition. The practically occurring lapse rate we call it as environmental lapse rate. That environmental lapse rate types are analyzed based on dry adiabatic lapse rate. Types of practical lapse rate is analyzed and explained depending upon dry adiabatic lapse rate. So you need to remember this. In dry adiabatic lapse rate, change in temperature to altitude dt by dz. Lapse rate is a decline of 9.8 degrees Celsius for every 1 kilometer rise. For every 1 kilometer altitude rise, there is a decline of 9.8 degrees Celsius. Clear? Is it clear? Anything to repeat in today's class? Tell me. Any doubts related to today's class? We will discuss. Tomorrow we are going to discuss about types of environmental lapse rate, super adiabatic, subadiabatic, neutral lapse rate, inversion, and different plume behaviors because of all these conditions. So don't miss tomorrow's class. So tomorrow time is also same. We are going to continue 8:30 to 9:30 tomorrow also. So tomorrow class at 8:30 p.m. same YouTube live. We are going to have air pollution part 5, not part 3. Part 4 completed. Air pollution part 5. And I would like to give some clear picture regarding what is Unacademy is going to provide you and what is I am going to teach you in Unacademy. What is my experience and all those things. So myself, most of you know Krishna Prakash. I trained several batches of students. I am ex-ACE Academy faculty. And also I would like to introduce my faculty team in Unacademy. My faculty team in Unacademy, now I am going to introduce you. So myself will teach you different subjects. Yesterday we discussed all the subjects weightage is 25 marks. Whatever I teach in Unacademy, environmental engineering, hydrology, irrigation, open channel flow, construction materials and management. So I am going to teach 25% weightage of gate syllabus, 25 marks. Then my friend, my colleague from same ACE Engineering Academy, again entered into Unacademy, Mr. Rajendra Prasad, RP sir, is going to teach the subjects transportation, steel structure, structural analysis, RCC and PSU. And this total weightage is 23 marks. We both combinedly going to teach 48 marks. Here we both combinedly going to teach 48 marks. One new faculty, big faculty is coming to teach geotech. So total we three combinedly teach for 60 marks. Clear? We three, myself, Rajendra Prasad, and one more new big faculty who is coming from big institute, going to teach geotechnical engineering. So total will cover 60 marks for your GATE examination. Then remaining subjects, remaining subjects, mathematics, aptitude, common subjects, fluid mechanics, strength of materials. Topmost faculty, top educators in India are there in Unacademy platform. You can go through them. Then what is the speciality of our team? Why you need to specifically join in Unacademy and go through our classes only? I want to give clear picture. Takdir, purpose of lapse rate to understand air pollution. Tomorrow you will get the clarity regarding what is lapse rate, how air pollution is affected, everything. Takdir, you will get a clear picture tomorrow. So time is 1 hour completed, Ankit Ranjan. So now I am going to tell speciality of my team, KPSR team. Why you need to go through Unacademy and especially to our lectures. What is the reason? My team of faculty will have vast experience in teaching GATE and ESC. Very important this point. So many people are showing experience in other activities. Experience in other activities will not give you cracking GATE and ESC. Experience in teaching GATE and ESC is very important. And we have a lot of subject, but we are not going to dump total subject to you. Only what is required for GATE and ESC only, that clarity we have. Clarity in the subject, because a teacher will read n number of books, but teacher don't try to incorporate the total knowledge into student for the respective exam for which the student is preparing. So regarding that respective exam only, the required content should be given to student. So student effectively take that content and delivered in the exam, he will succeed in the exam. So we know what to teach and what not to teach. What is required for exam and what is not required for exam. I've seen so many YouTube videos, NPTEL lectures. What is missing is clarity in the content. Whatever they know, they are simply delivering. That is not required. What is required for the exam point of view, especially for these competitive exams? Dumping content, if I give the time, every day 8 hours throughout the year, I will teach environmental engineering. Will it finish your GATE syllabus? No, no. Throughout year, if you are studying environmental engineering, you are getting 10 marks, no use. But you need to go what is required for GATE or what is required for ESC. That the clarity in subject depth delivery. Clear? That the clarity in subject delivery is there with our faculty only. So we are not dumping any unnecessary information. And so there is no confusion is created to the students. And we are providing excellent delivery of subject and we provide good notes. If you have doubts, you ask already enrolled students with us, already taken classes from us. We provide the best notes in the field. My notes, from my notes of environmental engineering only, surely you will get each and every question from GATE examination. 100% you clear, you solve each and every question in GATE exam. If you take my notes, so will give excellent delivery of subject and notes. And we are student supportive and we guide the students in preparation. Anytime you send a WhatsApp message, you will get a reply maybe within 1 hour or 2 hours. We are not making this, we are not maintaining this for this purpose. Before we are entering into Unacademy, before we are entering into other fields, we are maintaining student relationship. Whenever student have the doubt, immediately we are clarifying. If you have a doubt, you ask. Previously, you went to some coaching centers. How many of your faculty are in contact with you? Now, most of my students are in contact with me. So many students are working as scientists in various NITs and IITs. So many students are IAS officers. Still, they are in contact with me because I have clarified their doubts at any time. So I will support the students to get rank in GATE and IAS. Whatever the rank, whatever required for their career point of view, what is required for their exam point of view, I will provide you. What is advantages of Unacademy? Why we have so many learning platforms in India? What is only speciality of Unacademy? Unacademy has a live interactive sessions. So remember, online means a live class only. It is not a recording class. Remember this point. Online is always a live class only. Online is not a recording class. So live interactive sessions, whenever you want, you text in the comment box. Immediately your doubt is clear without any doubt. Is it not? If you are going for recording session, some coaching centers are giving recording. They will advertise online gate classes, but they are providing you recording session. Or for a time being, they will give live session. After that, they will invite for classroom coaching. Or after that, they will provide recorded sessions. Only after lockdown. Till time being of lockdown, they want to have some business. So till time being, they will give recorded sessions. Or they will come call for you classroom coaching. No. Throughout the year, forever, Unacademy is live interactive sessions only. And what happened if you miss the class? You will have a doubt. Sir, what happened if I miss the class? Don't worry. So your missed class will be watched any time till the end of your subscription. If you have taken subscription till end of your subscription, you download the video. It is not going to stay for 2 days, 3 days. Till the end of your subscription, that video will be saved in your saved downloaded videos forever. Then by the end of December, all coaching centers close their doors. Syllabus is over. Go away, pack your bags, go to your houses, prepare well. No, we are not closing the doors. We provide revision classes, previous question solving sessions, typical numerical sessions. We'll provide for you till the end of your subscription. Every day we'll provide numerical solving, revision classes, previous year questions. We never shut down the doors like normal traditional coaching centers. And we'll have several free special classes wherever, whenever you want. And Unacademy is a strong technical background is there. If you want to verify Unacademy website, so many legends from software industry are in Unacademy. So they have 24/7 technical support. Then finally, Unacademy provides forever, this is very important, forever live interactive sessions only. Not till lockdown ending. Never ask you to come for physical classroom coaching. And a complete live session only. Along with live, we are providing unlimited recording sessions. So online class means for Unacademy, what is online class? Online class means live interacted only, not a recorded class for Unacademy. Live interactive session only online means it is not recorded class for Unacademy. Remember this. We are in contact with the students. We are ready to help the students. We provide what you require. Then if you join Unacademy, you are having so many codes. Like that, I am also having one code, KP Civil Engineering Group. So everyone commonly they offer 10% discount. Then along with this 10% discount, you will get a free online test series. Yesterday also I told you, I have my own website for all branch students. I will provide any branch student subscribed with my code. I will provide free online test series. Copies of notes and other materials are provided to you. Support through my experienced panel faculty. Doubt clearance in WhatsApp group. We will be with you till you crack GATE and IS, till you join your PSU job or NIT IIT. Till that we are with you even after future you require. Anytime we maintain the relationship with the students. To get all the benefits, take subscription with the code Engineering Guru or KP Civil. Clear? Think twice before joining the courses. Go for best faculty in the field. So top civil engineering faculty now live on Unacademy, India's largest learning platform. If you have any doubts regarding subscription, any doubts regarding team, regarding subject, you WhatsApp me 9704571767. So we'll meet tomorrow again at 8:30. Until then, I'm signing off. Good night for all of you. We'll end the class for today. So is the video and the audio are clear? Any one of you just text me. Everything clear? Shall we go ahead? So Unacademy is providing the best opportunity for the students and also the top educators in India to interact with one another. The enthusiastic student is getting the topmost engineering faculty in India. So he's directly interacting just by a simple click in the comment box. The student is going to clear all his doubts in the subject related content. Yes. Okay, we'll go ahead. All is okay. Now, so we are discussing a series of lecture. We are going to take a series of lecture on air pollution. This is air pollution part 5, actually not part 4. Air pollution part 5. Already 4 parts completed. This air pollution we are discussing for GATE, ESC, Civil Engineering Technical subject. And also we are discussing the topic which is helpful for General Studies in Engineering Service Examination under the subject of Energy and Environment. And also it was helpful for all state government competitive exam aspirants, for the students who are preparing for state government examinations. Already we have completed in the previous 4 parts, part 1, part 2, part 3, part 4. Introduction, causes and types of air pollution. Air pollutants, types, their effects, major air pollutants, their effects and their permissible limits we have discussed. Conversion of units, microgram per meter cube to parts per million and vice versa, parts per million to microgram per meter cube. And also microgram per meter cube to parts per billion and also vice versa. We have discussed it already. And we have gone through just introduction of meteorological factors yesterday. Today we are going in depth related to meteorological factors. So we have discussed what are meteorological factors, what are their effects and all those things. Just in brief, within 5 minutes I am going to tell the introduction yesterday what we have discussed. So yesterday what we have discussed is regarding effect of temperature on air pollution. Effect of temperature on air pollution we have discussed. That is studied with respect to lapse rate. Lapse rate is change in temperature with respect to altitude, dt by dz. What we can write down? T2 minus T1 by Z2 minus Z1. Temperature at an altitude Z2, T2. Temperature at an altitude Z2 is T2. Temperature near to ground level at an altitude Z1 is T1. Difference in temperature to difference in altitude, that is said to be lapse rate. This lapse rate we have differentiated 2 types: adiabatic lapse rate, environmental lapse rate. Theoretical, standard or reference lapse rate that we conclude as adiabatic lapse rate. Practically varying, actually what is going to happen in the atmosphere, time to time, place to place, region to region, practically as per atmospheric condition, what is going to happen? Environmental lapse rate. This adiabatic lapse rate we have given average adiabatic lapse rate in the entire atmosphere, where we can say dt by dz equal to a decline of 6.5 degrees Celsius per 1 kilometer. That is average adiabatic lapse rate. Wet adiabatic lapse rate, where we have concluded dt by dz is equal to a decline of temperature of 4 degrees Celsius per kilometer. The most comparable and most important for our exam point of view, dry adiabatic lapse rate, where dt by dz is equal to decline minus 10 degrees Celsius per kilometer. Actually, that is a 9.8. We have rounded it off to 10. Minus 10 degrees Celsius, minus 9.8 degrees Celsius per kilometer. That we said to be dry adiabatic lapse rate. Now today, the continuation of the topic we are discussing. Types of ELR. ELR is environmental lapse rate. Takbir, hi. Banu Prakash, good evening. Manoj, Narendra, good evening all of you. So till now, just a quick revision of yesterday's what we have discussed. A quick synopsis I have discussed. The most important, we are entering into the most important types of environmental lapse rate. First of all, environmental lapse rate is the change in temperature profile. Clear? Change in vertical temperature profile. Vertical height goes on increasing. How the temperature is modifying. That change in temperature profile practically, actually happening depending upon modifications in the atmosphere. That is said to be environmental lapse rate. This environmental lapse rate we have differentiated into 4 categories. The first type of environmental lapse rate, super adiabatic lapse rate. We have given types of ELR, but the name is given super ALR. Why? We are discussing about types of environmental lapse rate, but for that type, why we have given super adiabatic? Because in comparison with this standard dry adiabatic lapse rate, we are expressing environmental lapse rate in comparison with the dry adiabatic lapse rate. So it is called a super adiabatic lapse rate, where we can say environmental lapse rate is greater than dry adiabatic lapse rate. That means practically occurred change in the atmosphere. What is practical occurred change in the atmosphere? dt by dz. We have measured temperature at ground level and temperature at 1 kilometer, and the obtained value of dt by dz, that is greater than, what is greater than? Dry adiabatic. What is the value dry adiabatic? This one, greater than a decline greater than 10 degrees Celsius per 1 kilometer. Very important thing I am going to reveal here. Normally, if you say mathematically greater than minus 10, what you will say? Greater than minus 10 is minus 9, minus 8, minus 7. No. Here, don't apply that mathematical condition. Here, minus is the word representing minus, we are writing to represent decline. So, dt by dz greater than minus 10 means decline more than 10 degrees Celsius takes place. So, temperature decline is either more than 10 means either 11, 12, 13, 14, whatever higher than 10 degrees Celsius decline. So, don't take this minus as a mathematical thing. Consider that minus as a decline. I will simplify you and easily explain you. Consider this is 0 kilometer line where we are living, ground level. This is 1 kilometer altitude, Z. Now, at ground level, consider the temperature as 40 degrees Celsius. Take at ground level the temperature as 40 degrees Celsius. So, according to dry ALR, what is the temperature after 1 kilometer? Minus 10 degrees happened. Means temperature fall down to 30 degrees Celsius according to dry adiabatic lapse rate. Now, our super ALR is going to happen. Same 40 degrees Celsius temperature fall down to, take for example, fall down to 25 degrees Celsius. And what is the decline of temperature? 15 degrees Celsius decline. Means temperature is falling down more than 10 degrees. It may be 25, it may be 26, it may be 24, it may be 20 also. But it is not 30 or less than 30, 30 or more than 30. It is always less than 30 only. So temperature decline, any value. For example, I have given 15 degrees. It may be decline of 11, decline of 12, decline of 13, decline of 14, decline of 20 also. So 40 degrees Celsius under super adiabatic lapse rate, it is falling down to 25 degrees Celsius. That condition, dt by dz greater than a decline of more than a decline of 10 degrees Celsius per kilometer. That condition we call it as a super adiabatic lapse rate. This super adiabatic lapse rate, remember, we are expecting an atmospheric fluctuation of 10 degrees. But happened is more than expected. If it is more than expected, can you say, will temperature change is more than expected? Will you say, will atmosphere is stable or unstable? Here, three conditions we are going to discuss. Normal condition, temperature exactly equal to decline of 10 degrees. More than expected condition, less than expected condition. Temperature fluctuation is very high, more than expected. That is unstable condition. Temperature change is very less than expected. That is stable. Now what happened? Temperature expected 10 degrees decline, happened is more than 10 degrees. So fluctuations in the atmosphere is more than expected. That is atmosphere is unstable condition. This is unstable atmosphere condition. So what we have expected, more than that occurred. So atmosphere is not quite common, not quite stable. It is an unstable condition. So in unstable atmosphere, how spread and mix are going to be happen? How dispersion and dilution for a unstable atmosphere. What happened? Yesterday we discussed relation between stability of atmosphere, dispersion and dilution. Relation between dispersion and dilution and air pollution also. So unstable atmosphere, dispersion and dilution is very, very high. Spread. Impurities are going to spread throughout the atmosphere, mix with more and more fresh air molecules. So dispersion and dilution, very good Manoj, more. High, dispersion and dilution is high. Now, if dispersion and dilution is high, what happened to air pollution? What happened to air pollution? Air pollution is said to be less. Why air pollution is said to be less? Because spread of pollutants will make pollutant mass to take far away from the chimney. So there is no fall down of pollutant mass. It was taken far away because of more dispersion and more dilution. Due to that reason, air pollution is said to be less. If I consider, I am going to plot a graph. Altitude is taken on y-axis, z in kilometer. This is ground level, 0 kilometer. Temperature is taken on x-axis in degrees Celsius. And we have marked 1 kilometer line. Consider this is a line of 1 kilometer. Now, the ground level surface temperature is 40 degrees Celsius. So, first we have drawn the curve for ALR, dry ALR. The curve is like this. Dry ALR we have identified. It is 30 degrees Celsius. Got the point? (30°C). This is the condition of dry adiabatic lapse rate. minus 10 degrees Celsius decline. Less air pollution reduces air pollution less. So everyone answered. Pallavi, Tagdir, Sai Mukesh, Tagdir, Aditya Kumar. Very good. Nice. Then, what happened if super adiabatic lapse rate occurred? This is the curve of adiabatic lapse rate. What happened if super adiabatic lapse rate occur? How the curve shift? Curve will shift to right or left? Tell me. For adiabatic lapse rate, the graph is given to you. This is important question, theoretical question given in ESC and GATE. This is the curve related to adiabatic lapse rate. Super adiabatic lapse rate going to happen. How the curve will shift? Show me the curve for super ALR. Left. Very good. Manoj, you are very fast. The curve will shift towards left 25 degrees Celsius. Super ALR, because the decline is more, curve fall down to left condition. Curve fall down to left condition. We'll consider along with the curve, you need to know what is the behavior of plume. Yesterday we have drawn 3 patterns of the plume. First pattern will go exactly vertical upward direction. Second pattern, it may move horizontally. Third pattern, it is getting fall down. Now, the plume behavior for super adiabatic lapse rate, we call it as looping plume behavior. The plume behavior for super ALR. Important question. Plume behavior for super adiabatic lapse rate is, that is looping plume behavior. This is the looping plume. I am going to show in the form of a picture directly. The pollutant mass move on like a loop, like a wave which passes far away, raising thermal. The plume mass rises up, not falling down, move on horizontally, spread in the atmosphere. So convective mixed layer, it is not at all falling down, it is going horizontal direction. Yesterday we have given the diagram. This is the stack of the chimney. Pollutant mass is released. There are 3 possibilities. One is vertical upward, second one horizontal, and the third one fall down to ground level. This horizontal, what we consider here, going to occur because of super ALR. So leftward shift. Sai Mukesh Gajala, it is not a left, right, it is towards left because temperature decreases. So horizontal dispersion of pollutant mass taken far away, not near to that chimney, taken far away, goes far away from the chimney. So this is going to be happen. This is related to looping plume behavior. Clear? We'll move ahead. Then, second type of environmental lapse rate, sub-adiabatic lapse rate. Second type of environmental lapse rate, sub-adiabatic lapse rate. And very important thing I would like to tell you, remember these diagrams, match the following questions are given to you. Identify plume pattern. So by seeing the diagram, you have to identify what kind of plume behavior is going to happen. So you can identify plume pattern. That is very important. Remember it. Then second one, sub-adiabatic lapse rate. The environmental lapse rate is less than dry adiabatic lapse rate. That condition we call it as a sub-adiabatic lapse rate. What we can say? The practically occurred dt by dz. You have measured temperature at ground level, temperature at 1 kilometer high above the ground level. Difference estimated. That difference estimated is less than, practically estimated difference is less than 10 degrees Celsius decline per 1 kilometer. So decline, decreasing value less than 10 degrees Celsius is happened per every kilometer. So that is said to be subadiabatic lapse rate. That is considered as a subadiabatic lapse rate. Again, I will show this one to you in the form of a diagram. That is easy for you to understand. Now, ground level 0 kilometer, altitude 1 kilometer. So as it is same, we know about ALR, 40 degrees Celsius fall down to 30 degrees Celsius for ALR, minus 10 degrees Celsius per kilometer. Now, if sub ALR is going to happen, what is occurring? Tell me. Modification is done. Sub adiabatic lapse rate is going to happen. Sub adiabatic lapse rate is going to happen. Then it may be temperature 40 to 35 degrees Celsius. Temperature is declined, but not 10 degrees Celsius. It may be 9, 7, 8, 6, 4, 5, 2, 3, 1, whatever it may be. But not equal to or greater than 10. Is less than 10. So we take, for example, only. Don't feel every time minus 5 only. Don't feel like that. Maybe minus 5, minus 4, minus 3, minus 2, minus 1, minus 6, minus 7. Decline any value less than 10 degrees Celsius. Decline any value less than 10 degrees Celsius per kilometer. This is with respect to subadiabatic lapse rate. So if whatever happened, fluctuations, atmospheric condition is less than normal, less than expected. You have expected a decline of 10 degrees, but practically occurred is less than you expected. Got the point? You have expected a decline of 10 degrees. Practically happened is less than 10 degrees. What happened? Whether atmosphere is stable or unstable. Yes, temperature will be greater than 30 for 40 degrees because we have taken 40 degrees. Not always 40 degrees. So it may be any value greater than 30 if you take 40 degrees. Correct. Gopi Satish Malla. Nearest the temperature rise we will discuss in inversion. That temperature rise we are going to discuss in inversion nearest fourth condition. We'll continue. Go ahead. Okay, don't worry. We'll discuss temperature rise also. First three conditions are related to temperature decline. After that, the conditions are related to temperature rise. Yes, stable. Very good, Narendra and Gopi Satish Malla. Stable atmosphere. The change is less than expected. So, atmospheric condition is stable. If atmospheric condition is stable, what happened to dispersion and dilution? Tell me. For a stable atmosphere, what about dispersion and dilution? For a stable atmosphere, clear, atmosphere is changing less than expected, so it is stable. Fluctuations are not too much, very small fluctuation. So not considerable. What happened? Dispersion, dilution. Good, Manoj. dispersion and dilution is less. Good. Naveen and Neeraj also less dispersion dilution. Then air pollution. Dispersion and dilution is less. Pollutant mass is not spreading away, not mixing with fresh air. Pollutant mass is not moving away. It is not spreading, located there itself. It is not moving away, not mixing with fresh air. What happened? Air pollution is high. So pollutant mass not moving away. It moves a certain distance. Accumulated mass gain, weight of accumulated pollutants mass gain after some distance that may fall down near to ground level. That falling down near to ground level, we call it as a sub-ALR. High pollution, correct Takdir? High pollution, because pollutant mass not moving far away from the industry, from the chimney, is located there itself. Time to time, pollutant quantity goes on increasing. At some time, it may fall down near to ground level. High air pollution. We plot the graph related to it. Again, altitude, temperature, this is 1 kilometer line, 40 degrees Celsius temperature. As per ALR, 30 degrees Celsius. Because the decline of 10 degrees Celsius occurred. Now, sub-ALR happened in the atmosphere. Tell me. If sub-ALR occurred in the atmosphere, what is going to happen? Tell me. How the curve shift? Will the curve shift to left or curve shift to right? Tell me. ALR curve is given 40 to 30. Sub-ALR falling down. Right shift. Very good, Manoj. Right shift. This is the right shift, 35 degrees Celsius. Sub-adiabatic lapse rate. Curve shift towards right. Minus 5 degrees Celsius decline. Minus 5 degrees Celsius decline. Now, plume behavior. For subadiabatic lapse rate, the plume behavior we call it as coning plume behavior. The plume mass, what happened to plume mass? The released plume mass accumulated, generated a cone-shaped mass. This cone-shaped mass, we call it as a coning plume behavior for sub-ALR, because spread is less, mixing with the fresh air is less, pollutant mass circulated, forming a cone-shaped structure. So this is the cone generated near to the ground level. See here, cone-shaped structure generated, accumulation generated, coning. I'm writing here, coning mass is going to be created, accumulated near to the ground level. This is for sub-adiabatic lapse rate. Then, next one, the third condition, neutral lapse rate. So, neutral lapse rate. Environmental lapse rate is equal to dry adiabatic lapse rate. So, what we have expected in the nature to be happened in the nature, the same thing happened in the nature. we have expected in nature to happen dt by dz exactly equal to decline of 10 degrees Celsius. The same thing happened in the nature without any modification. So we can write down dt by dz exactly equal to dt by dz exactly equal to minus 10 degrees Celsius per kilometer. Change in temperature. So stable, high pollution, subadiabatic. Correct. Takdir. Ideal condition. So neutral lapse rate, you have designed the stack or height of the chimney considering dt by dz exactly equal to 10 degrees Celsius. You feel that is happened, pollutant mass does not horizontally go, pollutant mass does not fall down, it go high above into atmosphere, not returning back. So you have designed the height stack of the chimney for that condition. So you got dt by dz minus 10 degrees Celsius per 1 kilometer. That is practically happened. Practically occurred lapse rate is equal to reference theoretical lapse rate, dry adiabatic lapse rate. So such condition is called neutral lapse rate. This condition we are going to say having that condition in the atmosphere is a very rare condition. So no need to plot the graph, same graph. Whatever we have given for dry adiabatic lapse rate, same graph going to happen. Whatever temperature shift happened, same temperature shift happened. No need to draw any kind of graph related to it. This is neutral plume. Vertical plume. The plume we call a neutral plume, or even we can say it as a vertical plume for neutral lapse rate. Plume mass is releasing, flowing vertically upward direction. See here. Flowing vertical upward direction. Plume mass is going away. Vertical upward direction. Neutral plume mass. Exactly dt by dz exactly equal to decline of 10 degrees Celsius per kilometer. Plume mass not moving horizontally, not getting fall down. So we have given 3 conditions to you. See. First condition, moving horizontally. We call moving horizontally super LR. Falling down near to ground level, that we have given sub LR. Going exactly high above chimney, not horizontal, not falling down. That condition we call it as a neutral lapse rate. In the beginning we have explained, from the stack of the chimney, plume mass is releasing. It has 3 fates. First fate, horizontal fate, super adiabatic lapse rate. Falling down fate, subadiabatic lapse rate. Going vertical upward, neutral lapse rate. So the 3 fates condition. This condition is a very rare condition. First thing you need to remember, my dear students, we can't say when it is going to happen, how it is going to happen. Everything is atmospheric behavior. So what happened previously, our scientists have analyzed and given us to study like this. We can't control any kind of the behavior. That is going to happen under 3 circumstances in the atmosphere. Our scientists have differentiated, classified 3 conditions going to happen. One is exactly equal to minus 10 degrees Celsius per kilometer, that is neutral. Greater than minus 10 degrees Celsius, super adiabatic. Less than minus 10 degrees Celsius, that is subadiabatic. That is going to be happen 3 different conditions in the atmospheric behavior. No human, no scientist, no environmental engineer will not control. We can't say when it is going to happen, when it is does not going to happen. Can you guess when rainfall occur, when rainfall does not occur? Can you guess when summer high temperatures are there, low temperatures are there? Like this atmosphere behavior, we can't guess anything. Depending upon atmospheric behavior, our plume mass is going away. If exactly equal to 10 degrees Celsius, clear, If exactly equal to 10 degrees Celsius, our plume mass will travel vertically upward direction. If greater than minus 10 degrees Celsius, our plume mass will travel horizontally. That traveling horizontally we named super ALR. If practically occurred is less than 10 degrees Celsius decline, whatever happened in atmosphere, then subadiabatic lab state. We are not controlling. Whatever going on, we have given some words to understand how the plume behavior is going to happen, how the plume will travel. For that, we have given some terms. So noise pollution in next session will go ahead. For the air pollution only up to Sunday we'll finish off air pollution. After that again I move on. Till now we are taking Monday to Sunday we have taken air pollution 7 days in YouTube. After this I move on to Unacademy platform. Again next month I come to YouTube. In Unacademy platform I may cover some free classes. Noise pollution I will inform you time to time. Regarding how stability depends on temperature. Aditya Kumar, stability is depending upon not only temperature. Atmosphere is said to be stable if there is no temperature fluctuation, there is no pressure variation, there is no quick change in the moisture content, there is no quick travel of wind masses. Atmosphere is said to be stable if wind masses are not moving away, temperature is not too much fluctuated, very small fluctuations in the temperature, and pressure variations are not that much high. In such a case, atmosphere is stable. Wind masses, continuous flow of air, wind masses moving away. Ultimately, temperature reduction goes on happening. Reduction of temperature. If air is more, wind mass is moving away, temperature reduction goes on, takes place now. So if air mass flowing away, suddenly air mass is moving, wind is blowing, pressure is released, pressure is reduced. That sudden fluctuations, that is called unstable. Air is not moving away, pressure is more, temperature is more. Air is moving, high wind masses are there, pressure is less, temperature is less, fluctuations are high. Atmosphere is unstable. So this, depending upon these factors, we can say whether the atmosphere is stable or unstable. That is depending upon passage of wind masses, velocity of wind, temperature fluctuation, pressure fluctuation, humidity and moisture content in the atmosphere. Based on all these factors, we conclude whether it is stable or unstable. Got it, Aditya Kumar? Then, in 3 cases we have studied now. What 3 cases we have studied? Super adiabatic lapse rate, sub adiabatic lapse rate, and what is the third one? Neutral lapse rate. Now, in all these 3 conditions, what is the relation between temperature and altitude? Temperature and altitude are inversely proportional for these 3 conditions. For superadiabatic lapse rate, subadiabatic lapse rate and neutral lapse rate, temperature is inversely proportional to altitude. Means with increase of altitude, what happened to temperature? Decreases. Whatever the value of decrease, it may be decline of 10 degrees, decline of less than 10, or decline of more than 10. But ultimately, what is going to happen? With increase of altitude, vertical rise, if you go high above the ground level, always temperature goes on decreasing for this 3 conditions. For all the 3 conditions, how can we say in subadiabatic lapse rate stability is more and stable atmosphere? Because temperature decrease is less. Na? Temperature decrease is more, atmosphere fluctuations are more. So we'll write down, that is easy for you. Temperature decreasing more means wind velocity is high. Wind velocity high. Pressure is, when wind masses are moving faster, what happens? Pressure reduces. That means fluctuations going to happen in the atmosphere. Fluctuations are high in such a case. If wind mass, suddenly some wind mass is coming, will the atmosphere is stable? No, no. That wind mass will disturb the atmosphere. That disturbance created in the atmosphere, we will call it as a stable atmosphere converted to unstable condition. Here, temperature decreases more, wind velocity is high, pressure is reducing more, fluctuations are more, unstable. If temperature fall down is less, that means what velocity of wind or wind masses are negligible. Wind is not that much moving away. Then wind is not that much moving away, pressure decrease, pressure will be high. So pressure is high, fluctuations are less, clouds are not moving away. Clouds are not moving away, pressure is high, wind masses are not traveling, no air in the atmosphere. We call it as a stable. I think now you got the clarity, Aditya Kumar. So, super adiabatic lapse rate, subadiabatic lapse rate, neutral lapse rate. Temperature is inversely proportional altitude. With increase of altitude, temperature decreases. If that decline in temperature is very high in atmosphere, atmosphere is unstable. If decline in temperature is less in atmosphere, atmosphere is said to be stable. Clear? Decline is more, atmosphere is unstable. Decline is less, atmosphere is stable. Now, so this condition, temperature inversely proportional to altitude. Now we have a special condition, inversion. What happened to inversion? Temperature directly proportional to altitude. Means with increase of altitude, when you go high above ground level, temperature also increases. In the first three cases, that is reverse. Altitude and temperature are inversely proportional. In the first three cases, subadiabatic, superadiabatic, neutral. Whatever value, irrespective of value, in all three cases, same thing happen. When you go high above, temperature fall down. But now, exactly opposite. Both directly proportional to one another. When you go high above, altitude increases, temperature also increases. The value of change in temperature to change in altitude. That means, if you calculate T2 minus T1 by Z2 minus Z1, you will get a positive value. Will get a positive value. So we call this as a positive lapse rate. Till now what we have? Negative lapse rate. Clear? Because minus value, we are having minus values. Now we have plus values, positive lapse rate. dt by dz. Till now what expected is a negative lapse rate. Now we are expecting positive lapse rate. Temperature goes on increasing with the altitude. I will explain you. So again we'll take, this is 0 kilometer line. This is 1 kilometer line. So we have taken at ground level 40 degrees Celsius. As per ALR, reference is always dry adiabatic lapse rate. So as per ALR, 10 degrees Celsius decline, it is said to be 30 degrees happen after 1 kilometer. Now, for inversion, 40 degrees Celsius at the ground level, inversion is going to occur. 40 degrees Celsius at the ground level, inversion is going to occur. There is a raise. The raise may be +1, +2, +3, +4, whatever it may be. Increase of temperature. 40 degrees may be increased to 45 degrees Celsius. Increase of temperature. 40 degrees may raise to 45 degrees Celsius. Maybe 40, maybe 45, 40 maybe 50, 40 maybe 48, 40 maybe 60, whatever. Raise. Temperature goes on increasing with respect to altitude. That condition we call it as inversion. If you plot a curve, altitude on y-axis, temperature on x-axis. Now, this is 1 kilometer line, altitude in kilometers. So as per ALR, maybe this is 30, 40 to 30 as per ALR. Now, how inversion will occur? It is at 45 degrees Celsius. So this is curve for inversion. There is an increase of 5 degrees Celsius. That is curve for inversion. Got it? Temperature directly proportional to altitude. Increase of altitude increases temperature. Positive lapse rate value, you are getting a positive value. That condition we call it as a inversion. Shifts right only near us, very good, correct? Yes, correct. Third day. In all lapse rate, negative means decline temperature and inversion positive means increase in temperature. Simple. Positive means increase in temperature. Very, very important thing you need to remember here. This inversion is the lapse rate happened during winter season, especially winter nights. Inversion is the lapse rate happened during winter season, especially during winter nights. Because I will explain you clearly about this also. This is the stack of the chimney. From this stack, pollutant mass is releasing into atmosphere. And now, during winter season, what is going to happen is the temperature of pollutant mass released. This plume temperature, plume mass temperature, T plume. This is greater than temperature of atmosphere. Because this is winter season. What happened in winter season? Low temperatures are there. In winter season, the temperature is said to be low. Low atmospheric temperature. We are discussing about the atmospheric temperature in winter season. It is said to be low. The plume mass, gaseous mass, pollutant mass, particulate matter, whatever released from this stack, having high temperature when compared with the atmospheric temperature, surrounding air. Consider surrounding air in the atmosphere. So this is the surrounding air masses which are available in the atmosphere. And these air masses are wet. cold and moist air masses. The air masses during winter season in the atmosphere are wet, cold and moist air masses. The plume which is released is dry, warmer air mass. Two different conditions. Na? The air mass released from the plume is dry and warmer air mass. The air partially available in the atmosphere is wet, cold and moist air mass. So, this air mass creates some inversion layers. This wet air mass is there. Na? Wet and cold moist air mass create some layers. So, this is layer 1, inversion layer 1 above chimney, and the second layer inversion layer 2 below chimney. So in between this, plume mass is trying to travel in between the two layers. I will show you with picture, that is easy for you. So here to here ground level, moisture layer 1 because of wet atmospheric condition in the winter season, inversion layer 1 and also high above ground level also inversion layer 2. So what is inversion layer? What is inversion layer? I have explained now. Inversion layer is a wet, cold, moist air parcel. This wet, cold, moist air mass does not allow, consider this is the condition, it does not allow pollutant mass to go down, and also it does not allow pollutant mass to go high. So pollutant mass is moving in between these two. What the point? Pollutant mass not allowed to move downward direction by this inversion layer 1. Pollutant mass not allowed to go upward direction by the inversion layer 2, moisture layer. In simple, you remember, moisture layer, wet moist layer 1, wet moist layer 2. These two layers suppress the pollutant mass to travel only in this narrow passageway. Take far away from the chimney. Clear? It is moving now, far away from the chimney. Moving, far away from the chimney. Take through narrow passageway. How much distance it can travel? Tell me, how much distance it can travel? Till that moisture layers disappear. For example, today winter season, today night 11:30 plume mass travel started its journey. Tomorrow morning at 8:30, 9 or 10 o'clock sunlight appear, suddenly moisture disappears. At that point where suddenly moisture disappears, at that point, till that journey it has traveled, suddenly at that location it is going to disperse in the air, fall down near to ground level. Such plume behavior, fanning plume, we call it as fanning plume, extreme inversion condition. Extreme inversion, where the two suppressed layers of moisture, top moisture layer suppressed downward, bottom moisture layer suppressed upward, very narrow passage of plume masses will take place. That narrow passage of plume mass go travel far away from the chimney till moisture layer disappears. Next day when sunlight coming appears, removes moisture layer. There at that location, means location of effect of pollution is not near to the city. It may be far away at some other place away from the city. Location of pollution. So that is said to be fanning plume, extreme inversion condition. Yes, this plume act as a borderline itself. Correct Tagdir. That plume act as a borderline itself. Got it? For everyone, you got it? Inversion behavior, fanning plume behavior. So I am going to draw a curve which is going to give you the clear picture of all types of lapse rates. Altitude on y-axis, temperature on x-axis. Temperature is taken in degrees Celsius. Altitude is taken in kilometer. Then this is 1 kilometer line. 1 kilometer line. Now first we are going to draw for a dry adiabatic lapse rate. 40 degrees Celsius temperature. So dry adiabatic lapse rate occurred 40 degrees Celsius to 30 degrees Celsius. So this is dry adiabatic lapse rate. How much change happened? Minus 10 degrees Celsius per kilometer. So 40 degrees Celsius of temperature fall down to 30 degrees Celsius according to dry adiabatic lapse rate. Now I am going to plot for ALR. ALR is going to happen here 20 degrees Celsius towards left minus 20 degrees Celsius is happened. dt by dz minus 20 degrees Celsius happened. What we call it as a super adiabatic lapse rate. Super adiabatic lapse rate towards left. Then I am going to plot for a sub ALR. I am going to plot for sub ALR. This is the condition. 35 degrees Celsius. How much decline? Minus 5 degrees Celsius. Less than dry adiabatic lapse rate. Less than dry adiabatic lapse rate. Now plotting for inversion. 40 degrees Celsius increases temperature of 10 degrees Celsius. 40 to 50. This condition is called inversion. So all the four we have represented. All the four we have shown in this curve. Super adiabatic lapse rate, dry adiabatic lapse rate, subadiabatic lapse rate, inversion. All the four we have shown. So some match the following questions, or they may give the curve, they may mark like this A, B, C, D. Identify the lapse rate conditions according to A, B, C, D in the graph. So you have to choose options. This is the previous question. They provide the complete graph like how I have drawn and ask you for 2 marks question in GATE or IS. Identify the lapse rate conditions as shown from the graph. Very important. All the 4 conditions we have shown here. Got it? Hello Ashish, you came late, I think so. So this is not yet completed. The next phase of meteorological factors still there. Some other plume behaviors are there. We will discuss tomorrow. Clear? This is lofting, fumigating, trapping. This is total plume behaviors. We will solve some numerical questions also. So meteorological factors and plume behaviors not yet completed. Phase 1 of meteorological factor completed. You came to know 4 conditions. Superadiabatic lapse rate, subadiabatic lapse rate, neutral lapse rate, and finally inversion. And again there are some differentiations in the inversion. Tomorrow we will discuss what are different conditions of inversion, what are other factors affecting air pollution, and also numerical question. Same, air pollution part 6, same time tomorrow class at 8:30, same time. Clear? So I don't want to repeat again and again. I don't want to getting bore you regarding myself, regarding my team of faculty. Just I'm going to show the slides only. Any doubts? I know Ashish, you are doing in plus course. I identified you. The only thing I am going to repeat, and I am going to just warn you, while you are going to take online course, ask them whether it is online live interactive session or it is recorded session. If they say live interactive, then ask them till what? Till course completion or till lockdown ending? So people are making you fools. Putting online, they are giving you recorded classes, or they give live sessions till lockdown end. They will invite for classroom coaching, physical coaching. So if you want online class, go for live interactive sessions only, because immediately, instantly your doubt is clarified. If you put a message in the comment box, instantly your doubt is going to be clarified. So remember, online class means it is a live interactive session only, not a recorded class, not invited for you, not invited after lockdown ending, not invited you for physical classroom coaching. Go for live interactive sessions only. You go ahead. Tomorrow we'll meet again. Clear? Tomorrow we'll meet again. We are continuing second phase of meteorological factors, the different conditions, plume behaviors of inversion. We'll meet again. Any doubts? Don't worry. You text me WhatsApp message 9704571767. And if you want to subscribe for Plus course or you want to follow me on Unacademy, click on KP Civil. You will get so many benefits. I don't want to repeat again and again. I don't want to getting bored. So you will get these benefits, 10% discount, free online test series and other benefits. So I have my own Telegram channel, Engineering Guru. You join in it, you get all benefits required for you. Okay? We'll continue. We'll go ahead tomorrow at 8:30. Again, same session will continue. Hello, students. Welcome to Unacademy. Good evening, all. Unacademy provides you a great opportunity to meet legends and top educators in the engineering studies, engineering education. So that will help you, the students who are in the remote places. Now, mostly due to lockdown, students are located at their villages. They are in a situation what to do and how the time is going to be getting passed. But Unacademy provided you the best opportunity to interact the students along with the top educators in the field by providing special free classes on YouTube as well as Unacademy platform. So generally free classes may be 1 or 2 provided by any coaching center, but not several number of classes. But here Unacademy we have several number of free special classes. Every day 1 class, monthly 30 hours of subject you are going to learn for free. Just free online classes will give you around 50 to 60% of syllabus to solve numericals in GATE and ESE. So utilize this opportunity. Good evening all. CTAX Consultancy, Mayank, Dahia, Manoj, good evening. So utilize the opportunity provided by Unacademy. Work for the best. Learn the subject. Spread the knowledge to everyone. And make more number of your friends to be benefited by these free special classes. Inform them Unacademy is giving this opportunity for free classes. So we'll go ahead into the subject. So Air pollution part 6. Till now we have completed 5 days, 5 sessions related to air pollution. Good evening, Prakash. And in ESC General Studies, this air pollution is an important topic which is under energy and environment. And in GATE and IES, for civil engineering students, air pollution you have 2 question compulsory, very important topic. So we have completed 5 parts of air pollution, entering into 6th part. We have completed air pollution introduction, causes and types, pollutants, types and their effects, concentration unit conversions, and meteorological factors affecting air pollution. We are in the middle of this topic, which include different types of plume behavior. Both are interrelated with one another, both topics. 50% of topic yesterday we have completed related to meteorological factors affecting air pollution and types of plume behavior. Bala Saheb, Venkat, Negi, good evening all of you. So now we are entering into the meteorological factors affecting air pollution. So what we have studied yesterday, just a brief 2 to 3 minutes discussion we are having. Yesterday we have studied about different types of environmental lapse rate. In that different types of environmental lapse rate, the first one, this is the first one, super adiabatic lapse rate, where we can consider dt by dz greater than minus 10 degrees Celsius per kilometer. What it shows? It shows a looping plume behavior. This plume behavior shown by this is looping plume behavior. And second one, this is said to be sub-adiabatic lapse rate, showing coning plume behavior, where we'll consider dt by dz less than minus 10 degrees Celsius per kilometer. The plume masses form like a cone-shaped structure near to the chimney. They may fall down at any time. Near to the stack, plume masses is accumulated. Here, plume masses have been taken far away, long journey, along with the spread. Along with, they are going to be spread, huge mass spread in the atmosphere. The third one, neutral lapse rate, where we consider dt by dz exactly equal to minus 10 degrees Celsius per kilometer. Pollutant mass will travel vertically high above the atmosphere. Vertical plume behavior. It is going on in all the 3 conditions. In this all the 3 conditions, we can write down here. Super adiabatic lapse rate, sub-adiabatic lapse rate, and neutral. In all the 3 conditions, temperature is inversely proportional to altitude. Temperature is inversely proportional to altitude. In all the 3 conditions. Means altitude increases, temperature decreases. In superadiabatic, subadiabatic, as well as in the neutral lapse rate. Then we have the fourth one, inversion. What happened in inversion? Fourth one, temperature directly proportional to altitude Increase of altitude increases temperature. This is the condition. Now all the kinds of three, superadiabatic, subadiabatic and neutral lapse rates, temperature and altitude are inversely proportional to one another. In inversion, it is changing temperature directly proportional to altitude. The increase of altitude, temperature increases. And this is the fanning plume behavior due to two inversion layers. Pollutant mass not falling down, not going away. Both does not occur. Exactly horizontally, linearly, it is going to travel, lateral traveling, horizontal traveling. That was shown. And the plume behavior, we call it as a fanning plume. So we have discussed four types of lapse rates. Superadiabatic lapse rate, subadiabatic lapse rate, neutral lapse rate, inversion. How many changes of temperatures will be happen in the four? Only one change. From ground level throughout the atmosphere, whatever modification it is going to be happen, only decrease with respect to first. From ground level till atmospheric zone, tropospheric zone, continuous increase of temperature with respect to inversion. So one change. Now all the cases. Now all these cases will conclude. We will conclude one change of temperature. The change may either it may decrease in first three cases, or it may increase in the next case, inversion. The first three cases decrease, the inversion case increase. But only happened means either increase only happened, happened means or decrease only happened, but not increase and decrease both. Only one change. Now we are entering into two change condition. Now we are entering into two change condition. What we call first one, lofting plume behavior. Lofting plume behavior. What is going on in lofting plume behavior? In lofting plume behavior, very important, remember, inversion below the stack. Inversion below the stack. Super adiabatic lapse rate. Super adiabatic lapse rate, where it occurs? Above the stack. That means temperature fluctuation modification are two. The vertical temperature profile is not going to show single modification. The vertical temperature profile is going to show two modification. I will clearly explain you. Consider this is a stack of the chimney. Consider this is a stack of the chimney. Then up to the stack height, what is going to happen? From ground level till the stack height, from here to here, inversion. Clearly written, below the stack. And above stack, what is going to happen? Super adiabatic lapse rate. This is the meaning of inversion below stack. From this stack means from ground level till stack height. Consider this is ground level. From ground level till stack height, temperature goes on increasing. Temperature increases with altitude. After reaching stack height, temperature is going to fall down, increase of altitude. Means ground level to stack height, temperature directly proportional to altitude. Above stack height, temperature inversely proportional to altitude. Got the point? From ground level to stack height, temperature directly proportional so that it is goes on increasing. Above stack height, super ALR. Super ALR means temperature inversely proportional altitude. We have written clearly now. So super ALR, sub ALR, neutral. What is temperature inversely proportional altitude? So above stack temperature is inversely proportional. Below stack temperature is directly proportional. I will give a graph. So we are taking Z altitude on y-axis. Altitude on y-axis, temperature on x-axis we have taken. And very important, we need to mark here. This is 1 kilometer. And remember, this is stack height. Stack is located from ground level to this point. Okay. For your understanding only, I have drawn stack height in the exam, in the paper, in the question, in the textbooks, materials, never stack height is done. For your easy understanding, I have taken advantage, I have drawn stack height. Okay. Now, when we take dry ALR, what happened? Dry ALR? From ground level at this point, take 40 degrees. So this is 30 degrees according to dry ALR. Now what we are going to plot? Lofting, behavior of lofting plume. Clear? Behavior of lofting plume from ground level to stack. What is happening? Temperature goes on increasing. From ground level to stack, temperature rise is going to take place up to this. This is happening up to this. Ground level to stack height, inversion is going to take place. Temperature goes on increasing. Ground level to stack height, what is happening? Inversion. Temperature increases. So it moves right. After reaching stack, what is occurring? After reaching stack, what is occurring? Super adiabatic lapse rate. So after reaching stack, it is moving like this. Super adiabatic lapse rate means temperature fall down. So it is moving downward, moving leftward. Moving leftward. Temperature increases. Initially, it is at this point. Temperature increases, it goes this direction. Temperature decreases, it go left. Temperature increase, right. So, initially from ground level to stack height, temperature increases. Stack height to up to whatever altitude, it goes on, temperature goes on decreasing. Super adiabatic lapse rate. Then, very important, this is the diagram. The flow mass, plume mass is flowing continuously, not allowed to fall down. Which is not allowed to fall down? Inversion layer is there. This inversion layer not allowed to fall down. It may spread in the atmosphere because this is super adiabatic lapse rate. It may spread in the atmosphere, but not falling down. See here. Mass is spreading, but not coming down. Is it falling down here? Mass is not falling down because top end spread, huge spread because of super ALR, but bottom end inversion layer, if it is trying to fall down, what the inversion layer? Inversion layer will push upward direction. So inversion layer does not allow pollutant mass to fall down. That makes spread here. Super ALR is always showing high dispersion and dilution. Clearly we have explained. Super ALR is going to show high dispersion and dilution. Because of that reason, in that upper atmosphere, it is going to spread more. So spread is going to be happen due to super ALR. So it is going on upward direction only, not coming downward direction. That is lofting plume. Anything to explain in this super ALR and inversion related to lofting? Super ALR at the top, inversion at the bottom. Plume mass does not fall down below stack. See here, this is the stack height. Plume mass is not going to fall down below stack. Na? See here also, plume mass does not going to fall down below stack. Plume mass go high above the stack. So such condition we call it as a lofting. The important point you need to remember, inversion below the stack, super adiabatic lapse rate above the stack. Remember this graph also. Okay. We are moving on. Next one, fumigating plume behavior. Exactly opposite. Exactly opposite to what is the previous one? Lofting. Exactly opposite to lofting. In lofting, inversion is below stack. In fumigating, inversion is above stack, and the super adiabatic lapse rate is below stack. It is simply like a mirror image, downward mirror image. Super adiabatic lapse rate is below stack, inversion is above stack. Exactly opposite, downward mirror image of what we have discussed previously. Consider again, this is ground level, stack. Now, what is happening from ground level to stack? From ground level to stack, super adiabatic lapse rate. Meaning of super adiabatic lapse rate is temperature goes on decreasing. But above stack, what is there above stack? Inversion. Above stack, what is going on? Inversion. Inversion, meaning of inversion, temperature increases. So from ground level up to stack height, with increase of altitude, temperature decreases. From stack height to throughout the troposphere, temperature goes on increasing. Clear? From ground level to up to stack height, temperature decreases. Above stack height, temperature goes on increasing. That is said to be fumigating. I will show the diagram. See what is going on here. Yes, Manoj, it is possible practically, especially winter season, evening time, that is going to be happen possibly, Manoj. Fumigating. What is this layer we call here? This is inversion layer. This is inversion layer, na? Where the mass is falling down? Mass is falling down near to ground level. Because below inversion layer, super ALR. It is meaning of super ALR. Super ALR means high dispersion and high dilution. In which direction they are dispersing and diluting? Downward direction. Why downward direction? Because top layer is inversion. So this top layer will suppress, does not allow to go high above. It does not allow to go high above. It suppresses. This top inversion layer make plume mass to go suppress downward direction and showing super ALR. So where this mass is releasing? Very important point. pollutant mass or plume? Pollutant mass or plume? Where it is released? Released near to surface, ground level. Pollutant mass or plume releases near to surface. And this point is very important. The plume behavior or the kind of plume which allows pollutant to be released into ground level. The type of plume which releases pollutant to near to surface, that is said to be fumigating plume behavior, falling down near to ground level. Is it clear? Shall we move on? Because we need to plot the graph. We are going to plot the graph here. Same altitude on y-axis, temperature on x-axis, this is stack, and this is 1 kilometer. Now, as like previous, first we are going to draw for ALR. This is adiabatic lapse rate. In every graph, remember this point. The line is a standard reference line of temperature fall down shown with respect to dry adiabatic lapse rate. In each graph, you need to mention it. Without it, you are not going to plot the graph. Okay? Remember that point. Now, which direction it is moving? From ground level to stack. Very important. From ground level to stack. What is happening? Below stack, super adiabatic lapse rate. So, from ground level to stack, it move on like this. Because here is going to occur super ALR, temperature decline. Temperature decline means curve shift to left. Temperature decline, curve shift to left. Up to what point? Up to what point curve shift to left? Till stack height. After that, inversion. What happened after that? Inversion. Inversion means temperature increases. Inversion. Inversion. Temperature increases. Curve shift towards right now. Curve shift towards right. In the first case, curve shift towards left. From ground level to stack, curve shift toward left. And after that, curve shift towards right. This is the graph related to fumigating plume behavior. Got it? Neeraj Zunani answered left. Okay. So anything to explain here in this regarding fumigating plume? What the points you need to remember? First one, inversion above the stack, super adiabatic lapse rate below the stack. 2, temperature modifications in the vertical profile. Then the pollutant mass released near to the ground level. So high pollution happened due to fumigating plume. Highest air pollution caused due to fumigating plume. And this is the diagram. You need to remember, I told you yesterday also, you need to remember the diagrams also, because match the following questions are provided to you. Got it? Good. We'll go for the last type of plume behavior. It is a trapping plume behavior. trapping plume behavior. What is going on in trapping? In trapping plume behavior, inversion above as well as below the stack. Inversion is going to be occurred above as well as below the stack. Consider this is the stack. A layer of inversion is present in the middle of the stack, and another layer of inversion is present above the stack. This is inversion layer 1, and this is inversion layer 2. And what is going to do this inversion layer 1 and 2? Inversion layer 1 does not allow pollutant mass to fall down. Does not allow pollutant mass to fall down. And also inversion layer 2 does not allow pollutant mass to raise up. Means there is an opening, big opening. Then pollutant mass is not going downward, not allowing upward. So both the direction, downward flow and upward flow of pollutant mass is not allowed. Then what is the difference here? Because the same we discussed here in fanning. In fanning also same thing. Inversion layer 1 not allowing here and not allowing here. The difference here is this width. The width goes on more in trapping. Second one, here pollutant particles are closely packed. Dispersion and dilution in the fanning is very less. But very important point related to trapping I am going to reveal. Very important point. In between two layers, in between two inversion layers, what is present in between? In between two inversion layers, what is there? Lapse. Especially lapse as super adiabatic lapse rate. This is very important point. Difference between fanning and trapping. Difference between fanning and trapping. Fanning is a narrow layer, small passageway. Through this small passageway, pollutant mass will go. Trapping is bigger. Because, I will tell you, I am writing regarding fanning here. What is happening in fanning is two inversion layers. There also in fanning also two inversion layers. Where the two inversion layers are formed? One just above stack, one just above stack, another one attached to the stack. Two layers of inversion, same like trapping and fanning. But the distance between two layers is varying. The distance between two layers is varying. Consider this is the stack. Layer 1 is formed here and layer 2 is formed here. Consider this is X1. This X1 is related to fanning. Clear? The layers are very close to one another. Pollutant mass will travel like this only. This is X1. Inversion layer 2, inversion layer 1. The same when we discuss with respect to this. What is the height difference between inversion layer 1 and layer 2? X2. Which is bigger? X2 is bigger, na? X2 is greater than X1. X2 is related to trapping. X2 is related to trapping. X1 is related to fanning. That is the basic difference between trapping and fanning. The layer pollutant mass is traveling in a small narrow passageway. Here the pollutant mass is traveling through bigger passageway. This bigger passageway X2 is bigger and very important. Here there is no possibility in X1, there is no possibility of dispersion at all. Here super adiabatic lapse rate is going to take place. What happened if super adiabatic lapse rate is going to occur? Dispersion, spread of pollutant. So inversion happened above and below the stack. Above and below the stack inversion happened. In between the inversion layer, super adiabatic lapse rate. Due to that super adiabatic lapse rate, more hues spread. Dispersion and dilution of pollutants is going to occur very highly. What the point? Difference between fanning and trapping is very important. Got it? Now, how many temperature fluctuations occur? How many temperature fluctuations occur? First, we have studied one temperature change. Super adiabatic, subadiabatic, neutral lapse rate. From ground level throughout troposphere, temperature goes on decreasing. Inversion, from ground level throughout troposphere, temperature goes on increasing. One change. Then, in a lofting plume, two changes. From ground level to stack height, temperature increases. Stack height to throughout atmosphere, temperature decreases. Lofting, two variation. Same mirror image happening, fumigating. Ground level to stack height, temperature decreases. Above stack height, temperature increases. Two modifications are going to happen. So one modification, temperature profile modification, one happen. Super, sub and neutral lapse rate along with inversion. Inversion means fanning plume of inversion. In lofting and fumigating plume, how many variation? From ground level to stack height, one variation. From stack height up to a troposphere, second variation. Two temperature fluctuation. Now how many are going to happen in trapping? So this is the trapping diagram. From ground level to stack height, inversion layer 1, I1. This is inversion. And above stack, inversion layer 2. Means above stack also again there is a inversion. Pollutant mass is going to be moving, spread, mixed, dispersed and diluted within these zones I1 to I2. What is in between? In between super adiabatic lapse rate. In between super adiabatic lapse rate. Now, how many changes will you shall we show here? Any one of you answer? How many temperature variations shall we show here? Subhadeep. Okay. So from ground level, this is ground level. This is the middle of the stack. What is going on? Inversion. So this is a line showing adiabatic lapse rate. Remember, this is the line showing adiabatic lapse rate. From ground level to middle of the stack. From ground level to middle of the stack, what happened? Temperature increases because inversion is there. First change. And after that, from this inversion layer to inversion layer 2. Inversion layer 1 to inversion layer 2. What is going on? Super adiabatic lapse rate. Temperature decreases. This is change 2. Above that, what is there? Again inversion. Temperature increases. Change 3. How many temperature fluctuations are there? 3 different altitude ranges, 3 different fluctuations of temperature. I will show by plotting the diagram. By plotting the graph, that is easy for you to understand. Temperature on x-axis we have taken. Altitude in kilometer on a y-axis we are considering. We are going to mark. This is 1 kilometer. And take this is the height of the stack. Stack is located here. Good, Neeraj. 3 variations you have answered. Now, as regular, this is the regular flow as per adiabatic collapse rate, regular model, reference line. Now, what is the first going on? What is the first change going to happen? From ground level to some middle of the stack. What is going on? Inversion. So, temperature increases. Temperature increases means which direction it moves? Temperature increases means it move on right side. It move on right side up to some distance. Move on right side up to some distance. Why right side? Because this is happening inversion. It is condition of inversion. Temperature increases. Temperature increases. Now, second condition. Up to some height above the stack, temperature goes on decreasing. Why up to some height temperature goes on decreasing? Because super adiabatic collapse rate, super ALR is there. After that height, again what happened? Temperature increases. After that height, temperature goes on increasing because again there is a inversion. Again there is a inversion. So how many changes we have shown here? Change 1, inversion from ground level to up to certain height of the stack. Inversion 1, temperature increases. After certain height of the stack till up to somehow above the stack, super adiabatic collapse rate change to temperature fall down left. It move towards left. Above the stack, then inversion change 3, again temperature increases. So this is the model of the curve we are forming. By what kind of behavior this one? By trapping plume behavior. Trapping plume behavior is having this kind of graph. 3 different fluctuations, 3 temperature fluctuations in the vertical temperature profile of the atmosphere. Got it? In the vertical temperature profile of the atmosphere, first one change by superadiabatic, subadiabatic, neutral lapse rate and fanning plume of inversion. Next, 2 changes. Up to stack one change, above stack another change with respect to lofting and fumigating plume. With respect to lofting and fumigating plume of inversion. The last one, 3 temperature fluctuations from ground level to middle of the stack, from middle of the stack to above stack to throughout a troposphere. 3 temperature fluctuations in the vertical temperature profile related to trapping plume of inversion. So this is complete picture related to plume behavior of pollutant mass in the atmosphere. So we have finished plume behavior. If any doubts, you can post it, I will answer. So these are what graphs as well as plume behaviors we have provided. We are discussing about till now what we have discussed is these are the different kinds of temperature fluctuations and graphs. So first one, it is first one we discussed. super adiabatic lapse rate. Super adiabatic. Dotted line, remember dotted line is always ALR. So super adiabatic lapse rate shift left of ALR, and this is looping plume behavior. Atmosphere highly unstable, strong instability. Atmosphere is highly unstable, strong instability. This is the first one, super adiabatic lapse rate. Second one, this one, second one, sub adiabatic lapse rate. The first one, this is ALR, and this is super ALR, and this is sub ALR. Adiabatic lapse rate middle, left super, right sub, and near to neutral stability. That means temperature is not unstable, near to neutral stability. What behavior? Plume behavior is coning plume behavior. Third one, neutral plume, temperature travels vertical upward direction. Same like ALR, it is going to happen. It is not going to fluctuate anything. Same like ALR, it is going to happen. Then fourth one, what we discussed about actual inversion, fanning, extreme inversion condition, surface inversion condition, extreme inversion condition, fanning. Masses are moving like this. So exactly opposite na. This is ALR line and this is inversion line, exactly opposite condition. Then after fanning, what we have? Lofting. Pollutant mass not falling below. From ground level to stack height, temperature increases. After stack height, temperature decreases. Temperature increases from ground level to stack height because of inversion. Above stack height, temperature decreases because of super adiabatic lapse rate. This is a fifth one. Fifth one, aloft inversion. Aloft inversion means falling down near to ground level. Opposite to loft. Loft is pushing upward. Aloft, pushing downward. Exactly opposite. Aloft, opposite to loft, falling downward near to ground level. From ground level to stack height, temperature fall down, super ALR. After stack height, temperature increases, inversion. This is sixth one, related to fumigation. Last one, clearly shown, three changes. From ground level to middle of the stack, inversion, temperature increases. Inversion, temperature increases. From middle of the stack to up to certain height, super ALR, temperature decreases. Then above the stack height, temperature increases because again inversion. This is the last condition we have, what we call it as a trapping. Inversion below and above the stack, lapse, super adiabatic lapse rate in between. So this is just a synopsis model showing curves as well as plume behaviors in the picture. Now we are discussing other factors. Other factors means other than temperature, remaining factors influencing. First factor is temperature. We discussed in detail related to temperature. The second one, wind velocity. Wind velocity. Air in motion, moving air. That moving air is said to be wind. If suddenly wind masses are coming from the chimney, pollutants are released. Suddenly fresh air mass is moving. Then what the air mass will take? The air mass will take away pollutants far away. So the dispersion and the dilution is more. So remember, wind velocity directly proportional to dispersion and dilution. It causes high dispersion and high dilution. Continuous flow of air masses are going on. Shall we say atmosphere is stable? No. Atmosphere is unstable. So it is inversely proportional to stability of atmosphere. It is inversely proportional to stability of atmosphere. So that ultimately less air pollution. Wind velocity is high, air pollution is less because atmosphere is unstable. Clear? Atmosphere is unstable, so air pollution is less. Then estimation or measurement of wind velocity. Wind velocity is measured using the instrument anemometer. Anemometer is the instrument used to measure wind velocity. Then we apply a law which is called 1/7 law. We are going to apply a law, 1/7 law. First we are measuring wind velocity at 0 kilometer, Z0. Altitude Z0 is wind velocity at 0 kilometer and the velocity is V0. We need velocity at altitude Z1. Velocity at altitude Z1 is V1. Velocity at ground level Z0 is V0. Then how will we determine V1? We can't fly high above the atmosphere. Na? We are not moving high and go there and we are not measuring wind velocity. Na? So using 1/7 law, what we can write down? V1 by V0 is equal to Z1 by Z0 whole power 1/7. This is called 1/7 law. V1 by V0 is equal to Z1 by Z0 whole power 1/7. So we'll estimate using this formula, we'll estimate V1. V1 is equal to V0 into Z1 by Z0 whole power 1/7. V1 is equal to V0 into Z1 by Z0 whole power 1/7. So velocity at altitude Z1 is estimated. Then direction of wind. How direction of wind is measured? Direction of wind is measured using wind vane. Direction of wind is measured using wind vane. And wind distribution at a location. These are important theoretical questions. You remember it very well. Wind distribution at a location in atmosphere, at a particular region in the atmosphere, that is picturized diagrammatically by using wind rosette diagram. Wind velocity estimated using anemometer. Direction of wind travel is known using wind vane. At a particular place, distribution of wind for a specific time is known by using wind rose diagram. Then third factor. First factor, temperature completed. Second factor, wind velocity completed. Third factor will take pressure. Atmosphere. Pressure in the atmosphere. So pressure in the atmosphere will consider first high pressure region. What we call high pressurized air. high pressure air, we consider it as anticyclone. High pressure air will conclude as anticyclone. Under these circumstances, anticyclone means, again we'll say, unstable atmosphere. Anticyclone means anticyclone. High pressurized region will consider as anticyclone. Stable atmosphere. So air pollution is more. Air pollution is high. Second condition, low pressure. Because of passage or instability in the atmosphere, pressure is released out. Air masses have been passed. So due to that reason, pressure is released out. Temperature fall down. So ultimately, unstable atmosphere is created. Low pressure, we can consider low pressure, unstable atmospheric condition. Due to that, air pollution is less. Air pollution is less. Again, I am repeating. Under high pressure, pressure is there in atmosphere because there is no movement of free air. Wind masses are not circulating, not distributed. So pressure and temperature are high. So due to that reason, stability is more, air pollution is more. Suddenly wind mass came. What happened? Pressure in the atmosphere wiped out, released out. So temperature also fall down. Drastic changes in the atmospheric condition. That drastic changes in the atmosphere, unstable condition. So air pollution is said to be less. The last factor, humidity. Moisture content in the atmosphere, we call it as humidity. What the humidity will do? The moisture reacts with pollutant mass responsible for formation of secondary air pollutants in atmosphere. Humidity or moisture in the atmosphere. We have studied the secondary air pollutants. Smog, ozone, peroxyacetyl nitrate, all the secondary air pollutant, because of chemical reactions of, including acid rain, because of chemical reactions of primary air pollutants with atmospheric moisture or humidity, these secondary air pollutants are going to be caused. So these are the effects imparted due to various kinds of meteorological factors. We have studied temperature, pressure, wind velocity, humidity, effects, meteorological factors effects on air pollution. We are going to solve one numerical question. Clear? We are going to solve one numerical question. Elevation and temperature data for a place is tabulated below. Elevation 4 meters, temperature 21.25. Elevation 444 meter, temperature 15.70 degrees Celsius. Based on above data, lapse rate can be referred as based on above data. So remember, the elevation or altitude which is near to the ground level, always take it as Z1. Don't take in the order given. The value of altitude near to 0 kilometer, near to ground level, that is Z1. And its temperature is taken as T1. The altitude farther from the ground level, that is Z2. And its temperature is T2. So what is the formula for lapse rate? Lapse rate, we have the formula. dt by dz. dt by dz is equal to T2 minus T1 by Z2 minus Z1. dt by dz. T2 minus T1 by Z2 minus Z1. T2 15.70 minus T1 21.25 temperature divided by altitude Z2 444 minus 4. And a very important thing you need to remember here, this altitude values must be taken in kilometer, not in meters. What is given here? Given here is in meters. We need to convert to kilometer. Multiply here with 10 power minus 3. So why we are multiplying with 10 power minus 3? Because converting meter to kilometer. Converting for meter to kilometer. What is the answer you are getting? It is the value of lapse rate you are getting. Tell me. Value of lapse rate. Okay, answer is super ALR. We know it. Answer is super ALR. What is the value you are getting? T2 minus T1 by Z2 minus Z1. 15.70 minus 21.25 divided by 444 minus 4. Till that everyone will do. But multiplying with 10 power minus 3 to convert meter to kilometer, that is very important. Okay, Manoj, very good. Minus 13.875 degrees Celsius per 1 kilometer divided by total kilometers, total altitude we have taken. So, minus 13.875 degrees Celsius dt by dz more than 10 kilometers, more than 10 degrees Celsius. dt by dz greater than minus 10 degrees Celsius per kilometer. So, answer is super adiabatic lapse rate. The value of lapse rate greater than 10 degrees Celsius decline, we can consider it as a super ALR. Next one. An air parcel having 40 degrees Celsius temperature moves from ground level to 500 meter elevation in a dry air following ALR. Clearly mentioned. Dry air and ALR means this condition dry adiabatic lapse rate, which we can say dt by dz is equal to minus 10 degrees Celsius per kilometer. Dry air, clearly mentioned, dry air. Then resulting temperature air parcel 500 meter elevation means from here to here 0 meter to 500 meter. 500 meter means half kilometer it is completed. 0.5 kilometer. If it completed 1 kilometer, how much decline? For 1 kilometer decline is 10 degrees Celsius. For half kilometer decline is 5 degrees Celsius. So here it is 40 degrees, 35. Manoj is very fast. So at 0 meter 40 degrees, after 500 meters it is 35. After 1 kilometer it is 30. So we will take also like this using formula. Answer is 35. We also use the formula and solve the question also. We will take T2 is needed. T1 40 degrees Celsius. Z2 0.5 kilometer. Z1 0. Both are in kilometers only. Is equal to minus 10 degrees Celsius. So we'll get T2 is equal to 35 degrees Celsius. We'll get T2. Without formula, simple analysis, we will get it. For 1 kilometer travel, 10 degrees. Half kilometer travel, 5 degrees decline. 40 minus 5 degrees decline is 35 degrees Celsius final temperature. So, again tomorrow, same time 8:30 p.m., Same YouTube live we are having. The final part of air pollution. Air pollution part 7. We are discussing about air pollution control devices. What are the various equipments, treatment units used in the industries to reduce air pollutants in the atmosphere? So tomorrow's topic is air pollution control devices. We are discussing in the same time, at the same time 8:30 p.m. in YouTube live. Same the last part of air pollution part 7. We'll discuss tomorrow. Not getting you making both. I am not going to discuss all these slides again and again, but I will tell you one thing. So these are the subjects taught by me in Unacademy: environmental engineering, hydrology, irrigation, open channel flow, construction materials. This is my friend, colleague who is going to teach you in Unacademy: transportation engineering, steel structure, structural analysis and RCC. And some of my friends also are coming and they will teach remaining subjects and will complete as a package of GATE ESC Civil Engineering. We will support you till you crack GATE examination. Very important thing, we don't dump unnecessary information and does not create any confusion. It should be clear to you if you go through the air pollution concepts. You can understand how much clear you got the concept of air pollution. What is required for exam point of view only we discuss. We are not going to discuss unnecessary dump for you. Only we provide exam specific content that comes with vast experience in teaching GATE and ESC only. So don't confuse about anything. Believe the faculty, those who are giving exactly required specified content in clear and simple manner. So remember, live class means always live interactive sessions only, not recording sessions. Again, I am repeating. Unacademy will provide you always live interactive sessions. It does not till lockdown, even after lockdown also you have live interactive sessions only. We never invite you to come for the physical classroom coaching. We never ask you to go recorded sessions after lockdown. Till lockdown you go for the live interactive session. Till we prepare recording sessions. No, not like that. Unacademy always unlimited access for live interactive sessions. If you miss the class, these live sessions are recorded, stored, saved. You go through it. But always we provide unlimited live interactive session. Remember, for Unacademy, live class, online class means live interacted only. It is not a recorded class. And if you take subscription in Unacademy using my code KP Civil and Engineering, you can use any code of the faculty or any code of the ad given by Unacademy management also. The common advantage, you are getting 10% discount. But along with that, I will provide you the best online test series platform for free. If you use my code KP Civil Engineering Guru, provide a free online test series to you. And regarding all subjects, complete pack of notes, soft copies I will forward you. Not only for civil, remember, for any branch student this is applicable. You spread it to your friends also. They will get the complete pack of their notes, scanned copies of their notes and other materials through mail if they enroll. They also, any branch of student will get online test series. Any branch of student will get soft copies of notes and other materials if they use my code. And I will support through the panel of experienced faculty accompanied with me. And also I will provide doubt clearance session in WhatsApp group, and also I will provide post-gate guidance. If you want support from me, join in my Telegram channel Engineering Guru. And before taking online class, just ask whether it is recorded live interactive session. Recorded till lockdown period or forever. Ask that one. That is very important. Think twice before joining the course. Most of the top civil engineering faculty in India are moving to Unacademy. Unacademy is the India's largest online learning platform. Any doubts related to you, text me 9704571767, my WhatsApp number. Okay. GATE special course is going to start early. So as early as possible, subscribe for Unacademy course. Okay, good night for today. Again, tomorrow we are meeting at the same time, 8:30, same on YouTube live. So until then, good night for today. Hello students, good evening all. How are you? So this is KP sir. I'm going to teach you environmental engineering. Since the last 6 days, we are in a continuous live sessions on YouTube. This is the last part of air pollution we are going to discuss. I hope you enjoyed all the 6 parts previously we have discussed. From Monday to Saturday, 6 parts of air pollution we have come across. I hope all of you have enjoyed. Now, we are going to have the last session of air pollution. So, now, this air pollution, just for clarity, I am going to say, is it clear for everyone? The voice and video, is it clear for everyone? So, any one of you can comment on the chat box so that I can get everything is clear. Okay, Raz. We'll go ahead, Raz. Yes, clear. Okay, done. Hi, Jagannath Reddy. So, this air pollution, we have the topic of air pollution for GATE, IES, Civil Engineering, and also in IES General Studies, in the topic of energy and environment, we have the topic of air pollution. And you write any state government competitive exams. It may be TSPSC, APPSC, KPSC, MPSC, whatever, PSCs. Compulsory general studies air pollution topic is there. If you write SSC, RRB, any competitive exam, whatever competitive exam, general studies, science and technology, without air pollution, there is no question paper. This much is important, air pollution. And Unacademy people are providing you, during lockdown, they are providing you best opportunity for the students to interact with the top educators in the India. So students are getting more benefited by this free live special classes. So utilize the most knowledge provided by our educators. Now what we have discussed previously. Good evening, Manos. Most abundant air pollutant, Raz, it is SOx only. Don't worry about it. Already I have written in the video also. Air pollution introduction, causes and types we have completed. Air pollutants types and their effects completed. Then concentration units conversions, microgram per meter cube to ppb or ppm conversion is done. Previous days we have discussed, last couple of days, meteorological factors affecting air pollution and different types of plume behaviors. We are in the last phase, air pollution control devices. This topic is very much important for GATE examination. This is the most important topic for GATE examination. Now, air pollution control devices. This is the basic classification of air pollution control devices. There are 3 categories. First one, solids removal. Solid particle removal. Solids removal. The solid particles available in the air, we call it as a PSP, total suspended particulate matter, or SPM, suspended particulate matter. For that suspended particulate matter removal, we have gravity settling chamber, centrifugal settling chamber, electrostatic precipitator, and finally fabric filters. And for the same, we have wet devices, scrubbers. Separation of solid particles using some moisture content, water content, or liquid chemicals. Wet devices for the same, okay, for the same solid particulate matter in presence of some water or some liquid chemical using devices, what we call it as scrubbers. Scrubbers are cyclonic scrubbers, tray type scrubbers, Venturi scrubbers. RAS CO is 48%, SOx is 16%. If you take overall atmospheric condition, if you consider 1 meter cube of air has been taken from a polluted area and estimated concentration in microgram per meter cube, then that polluted air, that polluted air contain more sulfur dioxide because carbon monoxide after entering into air converted into carbon dioxide. Carbon monoxide reacted with atmospheric air and converted into carbon dioxide. So after release from the chimney, after it is mixing with the fresh air, high concentration is sulfur dioxide. But as from the source, if it is released from the chimney, you have entrapped in a container, you collected and you estimated carbon monoxide is high. But after spread in the atmospheric air, carbon monoxide mostly transformed into carbon dioxide because of its chemical reaction with atmospheric oxygen. But sulfur dioxide is available as sulfur dioxide for a very long time. After that long time, it may convert it into smog, whatever other components. So rapid conversion or instant conversion happened for carbon monoxide. So if you take atmospheric air, sulfur dioxide is most abundant. And if you are considering entrapped in a container from the chimney, whatever released from the chimney, carbon monoxide is higher. Then coming for the third condition. Good evening, Banu Prakash. Gaseous impurity removal, absorption, adsorption, combustion. Three phenomena. First, solid particulate matter removal and also by wet devices, both same. Dry manner, we have given first gravity settling, centrifugal settling, electrostatic precipitation, fabric filter. Same solid particle in presence of some liquid chemical or water, wet devices. Finally, gaseous impurity removal, absorption, adsorption and combustion. First one, the name itself provide you the information. Gravity settling chamber. Means settling of particle. Settling of particle under the influence of no artificial force, no physical mechanical force, only depending upon natural gravitational force. So if a particle is to be settled down under the influence of gravitational force, what are the parameters to be considered? Based on mass, self-weight of the particle, based on mass, self-weight of the particle and its density. Because the density of particle is greater than density of air. So, considering these two parameters, the particle whose mass is attracted by gravitational force and the particle whose density is greater than air density, that particle is going to settle down. So it is similar to what we discussed under sedimentation topic in water treatment, same manner. And this is designed to separate out particles with diameter greater than 50 microns. gravity settling chamber is provided to separate out particles with a diameter greater than 50 microns, but efficiency is only just 50%. Efficiency is only just 50%. Why? Because settling carried out only under influence of gravity, particles self-weight and density, not modifying the particle, not additional other forces are provided, particles original mass and density under the influence of gravity. See here, this is a dust laden air stream, means impure air given into chamber. Now that impure air is traveling inlet to outlet. During the journey from inlet to outlet, the particles having the mass, they have been settled in a dust hopper. This dust hopper is going to collect the particles. Particles are settled based on their mass and density. Clearly written, heavy particles drop out due to reduced velocity, and it was given that heavy particles are given to dust collector. So the particles are settled based on mass and density. This is one more figure. Dirty gas entered into it. Dust hoppers are collecting impurity. Impurities are collected while the air is traveling from inlet to outlet. Clean gas is going out. Impure particles are collected, falling down, and settled in the dust hopper. So this is a clear picture for you that is easy for you to understand. There are two collection hoppers at the bottom. At the inlet, raw gas, polluted air. So this large diameter particles, what we have given here, these large diameter particles entered into cross section of the chamber. Entered into cross section of the chamber. Clean gas, this is traveling, going out, clean gas is exit out. During the journey, all this large diameter particle in dust hopper 1, these are fine particles. The fine particles are collected in the second hopper. So in the initial hopper 1, largest diameter particles are collected. While it is flowing slowly, smallest particles also getting falling down. Here we need to estimate Vs. It is Vs, settling velocity of air particle. The air particle is going to settle down. That is settling velocity of air particle. And also we have Vf. Vf is air flow velocity. Vs is settling velocity of air particle. Vf is air flow velocity. You can write down settling velocity. We have the formula, settling velocity formula. Na? GD square by 18 mu into rho p minus rho a. Or we can express the same. GD square by 18 mu into S minus 1. Same like sedimentation process in water. Same thing. D. Diameter of particle, impure particle. Diameter of impure particle. Mu. Dynamic viscosity of air. Viscosity of air. Rho p. What is rho p? Density of particle. Rho a. Density of air. Density of particle and density of air. Got it? And we have a relation here. We'll have a relation here. The time taken by particle to settle down. Time taken by particle. For what purpose? To settle. The time taken by particle to settle down. Distance traveled. How much distance? Depth of chamber by velocity. General formula for time. We have general formula for time. What is general formula for time? Distance by velocity. So distance we are considering So general formula for time, distance by velocity of travel. The particle is traveling vertical distance of the chamber depth with a velocity, settling velocity. Then time taken by air. From where to where the air is traveling? Air is traveling from inlet to outlet. Air is traveling inlet to outlet. The distance between inlet to outlet, length of the chamber, air is traveling with air flow velocity Vf. Clear? Inlet to outlet. Inlet to outlet, we'll consider it as length of the chamber. Particle distance travel, we'll consider the depth of the chamber. So, length of travel is the distance traveled by air. Air is traveling with velocity Vf. The condition required for settling. What is required for settling? Both the times must be same. That means H by Vs is equal to L by Vf. Both the times. In the industries, Naveen, we are not going to install in the atmosphere. We are going to install these instruments or equipments in the industries. So from this we have formula for airflow velocity. Vf is equal to L into Vs by H. So we have the formula for airflow velocity. Because to settle down the particle, the time taken by particle to settle down is equal to time taken by air to travel. H by Vs is equal to L by Vf. Vs already we have derived using these formulas. So Vf is equal to L into Vs by H. This is related to gravity settling chamber. Okay, we'll go ahead. Second one, centrifugal settling chamber, which is also called cyclonic separator. This is designed to separate particles of diameter greater than 25 microns and is achieving efficiency 50 to 90%. To separate out particles of diameter 25 micron and to achieve an efficiency 50 to 90%, we are providing centrifugal settling chamber. What is the difference? Difference is in gravity settling chamber only gravitational force. But here we have additional. What is additional? Centrifugal force. Additionally, we have centrifugal force here. Now, this is the inlet which is allowing the air to enter into it. Air is entered through the inlet, passing through it. Because of centrifugal forces, air is rotating continuously. So air is rotating. This is the plan view. Continuously air is rotating. The particles without having any mass go towards outward. Particle having mass attracted towards center. Go towards outward means particles without mass go outlet. Particle with mass attracted towards center and then falling down. discharges downward direction. This can be understood by this diagram. This is completely depending upon Bernoulli's principle and Venturi effect. You can write down Bernoulli's principle and Venturi effect. So this is the chamber 1. Clear? This is chamber 1. And through a narrow passage, air will travel from chamber 1 to chamber 2. Chamber 1, chamber 2. During this journey, while air is passing from A to B, this is happening while air is passing A to B, area decreases. Area, while air is passing from A to B, area decreases. What the decreased area will do? Increases velocity. Because rise in velocity happened. Because discharge is constant. Air flow rate we are not modifying. Same air flow rate is passing. Diameter changes at this junction. Due to decrease in diameter, area decreases. So, discharge is constant. Q is constant. So, velocity raise up. What the raise in velocity? Raise in velocity will do drop in the pressure. So, due to sudden pressure drop, what happened? Due to sudden pressure drop, particles will be fall down. Suddenly, the particles are traveling with a certain high pressure. Suddenly, velocity rises, pressure fall down. So, particles are collected in the bin because particles are falling down. Again, when it reaches to this C, again velocity and pressure are normal. Clean air blown through the extraction fan is going out. So this is the section where lighter pressure, see here, clearly mentioned here. Velocity is high here. Pressure is falling down towards low, pressure is falling down. Here velocity high, pressure high. Here velocity moderate, pressure moderate. Here velocity moderate, pressure moderate. This is condition at A and this is condition at B. In both conditions, velocity and pressure are exactly in the moderate condition. See here, velocity and pressure. But this is at B. What happened velocity? Velocity high increases. What happened to pressure? Pressure low decreases. So low pressure in the section C is noted. Sudden pressure drop will fall down the particle. Now, cyclone dust extraction system, same cyclonic settling chamber we call cyclone dust extraction system. So, one more diagram just for your more clarity. Dirty air is entered through inlet. Cleaner air will exit out through upper extraction fan. During this journey, the air is circulating. Dust particles are falling down. Sealed dust collection will. Through the conical section, cyclones are rotating. Cyclone is a continuously rotating air that push fresh air into upward direction. Fresh air, impurities are less, mass is less, so it go upward direction. Impure air, particles are there, mass is there, pressure fall down occurs, so it is falling down. So, just remember, fresh pure air, cleaner air, we call cleaner air, go upward direction. Dust, because the dust consists of high mass, so it is falling down due to sudden drop in the pressure. The dust particles are falling down due to sudden drop in the pressure. Okay. This is one more diagram, mostly not required for you. Then, electrostatic precipitator, the third one. Electrostatic precipitator, we can write it down as ESP, electrostatic precipitator. This is provided to separate out particles of diameter greater than or equal to 1 micron. To separate out particles of diameter greater than or equal to 1 micron. and it can achieve an efficiency between 90 to 99%. It can achieve an efficiency between 90 to 99%. What is going on here? The basic principle in electrostatic precipitation is providing electrostatic forces of attraction. Electrostatic forces of attraction. What are electrostatic forces of attraction? Simply we call electrostatic force of attraction positive, negative forces. The positively charged ion or negatively charged ion attracted by oppositely charged ion. Then will the air consist of charged particles? No. And especially we have given diameter, very minute diameter, greater than or equal to 1 micron. In such a case, how the charge come across? So, first initially, what the electrostatic precipitator will do is, initially it impart negatively charged particles. See here, these are the particles, solid particles going into it, and this is a negative electrode. This is a wire frame of negative charge. So negative electrode is connected. Clearly see the diagram. Negative electrode is connected to this wire frame. So all these are negative electrode wire frames. All these are negative electrode wire frames. Where we have placed it? Wire frame of negative electrode is placed in the inlet, at the inlet. So, air with solid particulate matter, incoming gas with particulate matter. Clear? Air with incoming solid particulate matter started entry. Then near to the inlet only, we are providing wire frame negative electrode. Now, the negative electrode is provided with some 250 to 300 volts electrical currents. Now, this solid particulate matter gain the charge. What charge? What charge solid particulate matter gains? Negative charge. So then, for what charge they will attract? Solid particulate matter gained a negative charge, so they attract to positive electrode. Now, this is positive electrode. Where it is present? Positive electrode given here, given here, given here. 3 plus. So positive electrode, positive electrode, positive electrode. Negative electrode wire frames are here. So particles are converted into negative charge, attracted to positive electrode. All particulate matter which have been converted into negative charge, attracted to positive electrode plate. This is what we call this as electrostatic plate. This charge of electrostatic plate, positive charge. So air particles entered into chamber, electrostatic precipitator. So it is traveling like this. It was first interacted with a wire frame. Wire frame is carrying negative charge. So if it passes through the wire frame, particulate matter converted into negative charge. So immediately it was obstructed by positive charge. So it was attracted onto the positive surface. So outgoing gas is particulate free gas. This is for your easy understanding. The charged particles are entering. So this is the entry of gas flow. Clear? This is entry of gas flow. What is this blue color? All this blue color are particles. Clear? All this blue color impure particles, impurity. Then this is a negative electrode. So impurities travel through negative electrode. Then the blue color particle converted into pink color because they gained the charge. Negative electrode is represented in pink color. Blue color particle converted into pink color by gaining negative charge. So immediately they have been attracted by, what is this? Yellow color. Yellow color is positive. So I'm writing for your clarity. Particle initially blue color. So this is the impure particle. Blue color, whatever there, impure particles. Then what happened? They passed through negative electrode. Particles are passed through negative electrode. How they have been transformed? Transformed into pink color, negatively charged particles. They have been transformed into negatively charged particles. Then this negatively charged particles are attracted. Which is attracting? Attracted by this positive electrode. So particulate matter first gain the charge, attracted by negative electrode, gain the charge, immediately attracted by positive electrode. Clean gas is traveling outward direction. I will draw a simple picture for you. Take this is electrostatic plate we are having. This electrostatic plate of positive electrode. Both the surfaces of electrostatic plate are positive electrodes. So it was connected to positive electrode. Electrostatic plate of positive electrode. And here there is a wire frame. Wire frame of negative mass. So this wire frame of negative mass connected to negative electrode. Okay. Now air particle. This is air particles. And these are impurity. Particulate matter in the air. Dust, flue gas, we call it as plume gas or flue gas, carrying impurities. Now the impurities will interact with this negative charge. How they have been converted now? All impure particles are converted into each negatively charged particle. When they exit, they will exit out of negative wire frame. Consider this is a negative electrode wire frame. So when they exit out through negative electrode wire frame, impure particles are converted into negative charge. And this is positive electrode. Throughout the length it is positive electrode only. So immediately all these particles are attached onto the positive electrode. What is remaining? Remaining is fresh air. Clean and fresh air. Clean air goes outside. Clean air goes outside. Got it? Manoj, from tomorrow onwards, you can attend the class in Unacademy live session. Free special classes are there, Manoj. 8:30 to 9:30, same time. Free classes only. No need to subscribe for it. No need to pay for it. Manoj, Unacademy plus subscription, you can go for it. Unacademy, free subscription, you can watch it. Got it? Now, for what particles? This electrostatic precipitation given for fine suspended particulate matter. fine suspended particulate matter, especially fly ash particles, dust particles, and including some aerosols, small amount of aerosols also. For that, we are providing electrostatic precipitation. Efficiency of electrostatic precipitation. Dutch-Anderson equation. Dutch-Anderson equation, efficiency is equal to 1 minus e power minus WA by Q. 1 minus e power minus WA by Q. W, terminal drift velocity, final velocity of air particles, meter per second. Efficiency is nothing but fractional collection efficiency, we know it. A, total collection area in simple. Remember this as electrostatic plate area. Electrostatic plate area. And Q is discharge, meter cube per second. So velocity into area by discharge we are considering. Velocity into area by discharge is nothing but, we'll conclude here. Instead of all this information, I am going to give you one simple formula. What is given according to this? Efficiency is equal to 1 minus e power minus WA by Q into 100. Efficiency in the percentage. Efficiency in the percentage. We consider air flow rate after ESP inlet is designed. Inlet is already designed, means discharge is constant. Discharge is constant, diameter is constant, area of electrostatic precipitator is constant, velocity also constant. So I will take W by Q. Once electrostatic precipitator construction is completed, W by Q is said to be a constant. What we represent it as a K. So now how can we write down the formula? Simple. Efficiency is equal to 1 minus e power minus Ka into 100. Efficiency is equal to 1 minus e power minus Ka by Ka into 100 for electrostatic precipitator efficiency. Clear? Shall we move on? Fabric filters. These are also called cotton baghouse filters. Fabric filters, same as cotton baghouse filters. Both are same. Designed to separate particles of diameter less than or equal to 1 micron. Designed to separate particles of diameter less than or equal to 1 micron. Efficiency greater than or equal to 99%. Highest efficiency. Greater than or equal to 99%. So air is passed through the inlet. Air traveled through the filter bags. These are the filter bags. Chamber 1, chamber 2, chamber 3, chamber 4, like that. Air passes. Particles are entrapped. Particles are not entrapped inside the filter bag, outside the filter bag. So all particles are falling down outside the filter bag. Purified air passes from each air bag and going out as an outlet. Filter does not allow entry of particle into it. Filter allows passage of air only. Then where the particles are there? Particles attached on the filter, on the surface. See here, particles are attached on the surface. Na? So particles which are attached on the surface, they slowly fall down and separated out. I will show you. This is the condition. Impure raw gas with particles. Particles allowed to enter into filter chamber. Particles allowed to enter into filter chamber. This is a filtration area. Clear? This is a filtration area. Where pores are there? This is the pore. Very minute. Na? This one and this one, this gap. This is the pore, very minute pore. Now these pores are not allowing. Pore diameter 10 power minus 12 meter. Very minute pore, very minute and microscopic pore. So and internally air will passes. What happened? Particle? Particle is attaches onto the surface, unable to go inside. Particle not entered inside, attached on the surface. So the particles will be falling down later on. Air, clean air goes out. How the filter is prepared? And I am going to show the picture of this filter. Remember, consider this is one cylindrical filter bag. This is one cylindrical filter bag. So that one, whatever I have drawn, that one cylindrical bag, na, this is happened. This is a wire frame network covered with this fabric material. This is the fabric. The fabric may be cotton, acrylic material is given as a fabric. Polyester may be also given as a fabric. Any of the three provided. Fabric material, cotton fabric. So we cover total, we'll make it total, the cover is placed. So the grill-like chamber is there now. So grill-like chamber covered with cloth, which is made of fabric, which is made of cotton, acrylic and polyester. Now air is given, air and particles are given. Air will go inside, air. But what happened to particle? Particles are stopped here. This fabric consists of minute microscopic pores. The pores are not even visible to microscope, very minute pore. It allows passage of air only. So what is going inside this? Inside this air is going. What happened to particle? Particles are attached on the outside of the fabric. So particles are attached on the outside, air is going inside. That is called a fabric filter, cotton baghouse filter. Then total area of filter. When we consider total area of filter, we can take it as air flow rate divided by air flow velocity. What is air flow rate? Air flow rate is nothing but discharge. Air flow velocity is nothing but velocity Q by V. But we have individual bags now. Individual surface area of filter bag, each one filter bag. What is that filter bag? This one. This is called a filter bag. This diagram what I have shown, this is named as a filter bag. What is the individual area of filter bag? This is a cylindrical filter bag. We'll consider pi dl, length of travel of air, diameter of filter bag, pi dl. Now for one filter, how many bags are required? Number of filter bags required. Number of filter bags required is equal to total area by individual area. Number of filter bags required is equal to total area by individual area. What is total area? Discharge by velocity. Individual area, pi dl. So how can we write down? N is equal to number of filter bags, N is equal to discharge by velocity into pi dl. This is the number of filter bags. Got it? Now, scrubbers. I think you know about the scrub. Normally in a kitchen, the people are used to clean the utensils by using scrub. Have you seen it? A scrub is a rough textured surface. Internally, it carries a smooth sponge-like material. Can you clean or wash the utensils with the scrub directly without water? Is it possible? Will you clean the utensil with the scrub without giving water? Is it possible? Cleaning off or washing off utensil, impossible without water. So water is required. Same phenomena here. Air is going to be cleaned away, washed away by passing air through a scrubbing chamber. But that scrubber needs water, na? Liquid. So same thing here. From the top, mist, water droplets. Clear? This is a dirty gas in, this is a liquid in. Liquid is entering in this path, dirty gas is entering in this path. Both the liquid as well as gas mixed together, passed through scrubbing chamber. The liquid with impure particles are getting settled down. Liquid with impure particles are getting settled down. Then clean air goes out because this mist eliminator will take out moisture content. This is one model. Okay, this is second model. This is liquid inlet. Liquid is releasing from top. Scrubber is present here. Scrubbing chamber is present here. Then air is entering. Air contained particles are entering, traveling in this path. So in the scrubbing chamber, air and water both interact with one another. Air and water will interact with one another. Then clean air will go away. Water with impurities are falling down. That overflow will be collected in the drain. Overflow will be collected in the drain. This is the diagram. One more additional diagram. Same, just color picture. Contaminated gas is entering in. Scrubbing liquid is loaded here. Scrubbing liquid is loaded here. Mixed through venturi throat. Venturi throat will make mixing. So due to that mixing through the wetted elbow, it is entering here. Particles with scrubbing liquid both are entered into liquid reservoir. Air will travel in the cyclonic motion and collected in the mist separator, polishing mist eliminator. Clean air goes out. I will write down, easy for you. So from the top, water is entering, liquid droplets. From the bottom, air is entering, gaseous particles. In the middle, at some part in the middle of the chamber, this is scrubbing layer, scrub provided. Now, water and impure particles of air. These are impure particles of air entrapped in the scrubbing chamber. Air goes upward direction. Clean air goes upward direction taken out. This water with impurities is falling down in the drain. Drain will collect water with impurity. So air impurities are transferred to water. Simple. Impurities in air are collected, transferred to water and collected in the drain. These scrubbers we can classify 3 types. Types of scrubbers. First one, cyclonic scrubber. provided for separation of particles with a diameter greater than 10 microns, and it can achieve an efficiency of 80%. Cyclonic scrubber is designed to separate out particles with a diameter greater than 10 microns, achieves an efficiency of 80%. Second one, tray type scrubber. Tray type scrubber provided to separate particles of diameter 2.5 micron, achieved an efficiency of 85%. Last one, the Indian model of scrubbing device. The scrubbers we are going to use in India, Venturi scrubber for diameter greater than 1 micron, achieves an efficiency of 90%. So if you have any question related to scrubbers, you can answer that as a Venturi scrubber only. Got it? Absorption. First one, absorption. Absorption means taking inside, engulfing, taking inside, absorption. So again, using some liquid propellant, some liquid is given. Liquid is given from the top, gas is given from the bottom. So both will be absorbed, collected in the stripping column. Liquid from the top is loaded, gas from the bottom is loaded. Both attaches with one another. Liquid is a chemical which absorbs a specific gas. So absorption is utilized for separation of a specific gas component, not all gaseous impurity. Specific gas by chemical reaction with liquid. Chemical reaction with liquid absorbent. Liquid absorbent. So we are selecting some specific gas. For example, you need to separate out carbon dioxide. Then the liquid specific to carbon dioxide is taken as a chemical absorbent. That is loaded. So that liquid chemical absorbent and carbon dioxide reacted with one another, entrapped, remaining gases out. That means we have separated carbon dioxide from that air. Same thing here. Adsorbent is in, liquid distributor is taken, liquid is loaded here. Both chemically react here, remaining gases goes out. Remaining gases goes out. Here, waste gas loaded from the bottom. See, waste gas loaded from the bottom. Absorbent is given from the top. Liquid is not given by a single pipe. So this is a pipe, inlet pipe. Inlet pipe carries several outlets. See, this is the liquid distribution channel. Liquid is distributed by this several outlets. Liquid is falling down. From where air is coming? Air particles are going upward direction. In the junction, they mix. Liquid will absorb only that specific gas, separates out. Remaining gas will exit out. For separation of specific gas, we are using absorption. Adsorption. Adsorption is provided for separation of NOx, SOx and ozone, including few hydrocarbons also, even volatile organic compounds also. Now, adsorbent, this is very important, adsorbent. Adsorbent is a chemical. What is adsorption? Adsorption is the phenomena of attachment of a particle onto its surface. Attachment to surface. Whose surface? Adsorbent's surface. Attachment to adsorbent's surface the adsorbent used here. We may use carbon, maybe activated carbon as adsorbent. Silica, we may use silica also adsorbent. Agar material also utilized as adsorbent. We can use carbon, silica or agar as adsorbent. Here we are taking carbon. Most used adsorbent, carbon bed. So contaminated gas is given into this carbon bed, and carbon bed attaches to the particles, impure particles, gases. Treated gas is taken out. Same thing, same diagram. Dirty gas, impure gas passed through carbon bed. So previously how the carbon bed is clear now, white, very white. What happened after treatment? All gases are entrapped. It was transformed into dirty carbon bed, black carbon bed. Black carbon bed is generated. Pure carbon bed is given, converted into black carbon bed. Clean gas goes out. That is said to be adsorption. This is the mechanism of adsorption. Diffusion to adsorbent surface. First phase. Contaminant molecules trying to diffuse into surface. This is surface. This total we consider it as adsorbent surface. Whatever I am going to draw with red color, this total is adsorbent surface. Now, migration of contaminant molecules into the pores. Into adsorbent pores, molecules are going to be migrate and attaches. Finally, a single layer of contaminant molecules, so monolayer buildup. What happened? So this is adsorbent lining. Adsorbent lining we have provided this one. Then particles are, where the particles are attached? Particles are attached here now. So I will show. So here at each surface of adsorbent layer, particles are entrapped, attached. Attachment onto the surface of adsorbent. This phenomena, what we call it as adsorption. So a good adsorbent is very important for adsorption. This is adsorbent only. Good, Manoj, very good. So this finishes the total air pollution. Starting from first, we have discussed what are the types of air pollution, how they have been occurred. Then we discussed what are types of air pollutants, what are their sources, what are their effects caused, what is the damage happened to humans, plants and animals. And then we come across unit conversion, concentrations and their unit conversion. After that, very important topic, meteorological factors. Due to meteorological factor, temperature, wind velocity, humidity, how the plume released from the industrial chimney will behave. We have studied about looping plume, coning plume, fanning plume, trapping, neutral, like that, n varieties of plume behaviors. Vertical temperature profile, how from ground level to stack to chimney, how temperature modification. And finally, what are the devices to be installed in the industries to control air pollutant mass not to be released into atmosphere. So we have finished the complete topic of air pollution in 7 hours. If you go through this 7 hours topic, surely you have one numerical question compulsory, mandatory in GATE exam. One question in ESC, minimum I am saying, one question in ESC technical paper, one question in ESC general studies paper. 2 questions in ESC you have, one in technical, one in general studies, minimum. Sometimes both, 2 general studies paper, 2 technical paper, 4 questions also. So very important for any competitive exam. Go through this again, write down the notes neatly. So while I am teaching in the live class, maybe it is not possible for you to write down the notes. So again, you go through it. Put a pause button wherever you want. You can write down the notes neatly. Prepare your best notes, and then go through it. Solve the numerical questions, solve the theoretical questions from your material. So air pollution, you can ask any question, you can solve it. Like that, you prepare for it. I have given my maximum effort to cover all the topics, all the concepts related to air pollution. Maybe some numericals are not solved. You can go ahead. Even we have some free session in Unacademy. We'll go ahead. The numericals on air pollution again, we'll solve it. No issue. So you do it. Clear. You do prepare your own notes from this YouTube free classes. Make solutions for numerical questions. Be prepared the topic of air pollution very well. Okay. As combustion is just burning in absence of oxygen, burning at very high temperature near us. That is not that much important. That is a costly device in India. We are not at all providing regarding combustion. That very high temperature burning, we call it as combustion or incineration. More than 1000 degrees Celsius burning in a closed chamber. So we never use it because that is very costly process. Okay, Niras? So again, tomorrow's class at 8:30 p.m. Where it is? It is going to be on Unacademy live, not on YouTube. Don't come to YouTube again. Tomorrow onwards. Again, next month we have YouTube classes. Okay, till 1 month we are having again Unacademy live classes. Those who are not having Unacademy app, download Unacademy app. Click on KP Civil. Follow me. Click on the link. If you type Unacademy, search KP Civil. My photo and follow. You click on the follow me link. You will get updates about my classes. Okay. If you want regular updates, you send text message, WhatsApp message to my number so that I will add you into the group where all the students are getting notifications related to free classes and also about all the competitive exams related information, materials, questions, everything you will be having in my Telegram channel and also WhatsApp group called Engineering Guru. So you just text me your number, WhatsApp me your number. I will be add you into that WhatsApp group and Telegram group. Okay. So again, I'm not getting bored you by telling all this stuff. This time I'm going to show my faculty team in Unacademy. Myself, I am going to teach environmental engineering, hydrology, irrigation, open channel flow, construction metals and management. You'll get 25 marks. And my friend, colleague from ACE Engineering Academy is again shifted to Unacademy. Transportation, steel structure, structural analysis, RCC and PSC surveying. Weightage, 23 marks. Remaining, you can depend upon other faculty. I will provide you best faculty to you. So most of the faculty are vast experienced. Only they provide you exam specific content. If you go through my video of air pollution, have you find any kind of unnecessary content I have dumped to you? That was known if you go to previous question papers and verify exactly what is required for the exam I have shown you. Unnecessarily, I am not dumping anything. Like that, you will exactly get a clarity in the subject, exam specific content. So if you want to buy plus subscription in Unacademy, use the code Engineering Guru or KP Civil. You will get a 10% discount and other benefits also. Okay. Unacademy will give you 24/7 live interactive sessions. Around 25 to 30% of subject is covered in free classes also. So if you are unable to purchase a special course, paid course, no issue. You can go for free course. So follow me. I will give you 25 to 30% of marks in that. No issue. So remember, for Unacademy, live class, online class means live interactive session only. It is not a recorded one. So what is tomorrow's class? This is tomorrow's class. Tomorrow, basics of open channel flow. Tomorrow at 8:30. Tomorrow at 8:30, we are discussing introduction or basics of open channel flow. Tomorrow 8:30 p.m. Unacademy live, not in YouTube live. Remember this. 8:30 p.m. introduction to open channel flow. Very important basics. If you miss those basics, you are unable to understand remaining topics. So attend the tomorrow's live session in the Unacademy. We'll meet again tomorrow 8:30. Until then, good night for today. Bye bye. I'm signing off for today.